welcome. My name is Zaid. I'm an ethical hacker, a computer scientist, and I'll be your instructor for this course. In this course, you'll learn network penetration testing from scratch. So you'll learn both wired and wireless network penetration testing, and by the end of it, you'll be at a high intermediate level, being able to launch attacks exactly like black hat hackers would do. Not only that, but you'll also be able to secure your networks from these attacks. The first thing we're going to learn is how to set up your lab so that you can practice penetration testing safely in your own environment. Once done with that, we're going to move in and learn how networks work, how devices connect to a network, and how they interact with each other. Once we understand how these things work, we'll move into our three main penetration testing sections. The first section is pre-connection attacks. So in this section, you'll learn all the attacks that you can do before you connect to the network. So it's going to be mostly geared towards wireless networks at the start, because if you want to connect to a wired network, you can literally just connect using the wire, and then you'll be able to move to section 3 where you can run more sophisticated attacks. So in the first section, you'll learn how to control all the connections around you, so you can disconnect any device from any network without having to connect to that network. You'll also learn how to set up a fake access point and lure people into connecting to it, and then you'll be able to capture all the data sent or received by any of the people connected to your fake wireless network. So you'll be able to see the usernames, the passwords, anything that they do really. Once done with that, we're going to move into the second section, which is gaining access. So again, if your target is a wired network, you can use the wire, connect to it. Some networks use filtering, so we'll see how you can bypass the filtering by changing the MAC address. If the target is a wireless network, the process is much more complicated. Most wireless networks these days, they use encryption and they use passwords. So you learn a number of attacks to get the passwords for any network, whether it uses WIP, WPA, or WPA2 encryption. Once done with that and we have access to our target network, we're going to move into section 3, the post-connection attacks. This section is going to be the most fun, and you're going to learn attacks that you can run against both wired and wireless networks, and it's going to work against any type of device, whether it's a laptop running Windows, Linux, Mac OS, or a TV, a phone, an Android phone, an iOS phone, any computer at all, any device that is connected to a network, these attacks will work against. These attacks will allow you to capture anything sent or received by any of the devices in your network. So you'll be able to capture usernames, passwords, cookies, websites visit. You'll be able to get screenshots of any device in your network. You'll be able to inject keyloggers, and at the end of it, you'll even be able to gain full control over any device that is in your network. Once we're done with all of these sections, I'm going to teach you how to detect and secure your networks from the attacks explained. Now, the course is highly practical, but it doesn't neglect the theory part. So you're going to learn how each of these attacks work, why do these attacks work, and then we're going to launch the attack against real devices in my environment. So these aren't proofs of concepts or anything theory. These are practical attacks that work against all devices.
As I mentioned, this course is going to be highly practical. Therefore, you will need a lab, a place where you can practice and experiment with the things that you're going to learn in the course. Not only that, but having a lab is essential for hackers or pen testers, because let's say you discovered a new attack, or you want to experiment with a new attack, or you learned something new online and you want to test it, then the perfect place for you to test this and practice hacking is a hacking or a testing lab. Now, to create a lab, you just need a number of computers with different operating systems, and you'll need a number of networks if you're testing network attacks, and if you're testing website attacks, then you will need to install websites on these computers. Or you can do all of this inside your computer, inside one machine, and install everything else as virtual machines. And this is what we're going to do. So let's say you have your computer right here. This is your main computer that you use every day to check your emails or even to watch this course. This computer might be running Windows, OS X or Linux. It doesn't really matter. It can run any operating system. You can keep all the programs that you love and like and install a virtualization software such as VirtualBox. A virtualization software allows us to create a number of virtual computers inside your main computer. So we can have 3 or 4 or 5 or 10 computers all installed inside your main operating system, inside your main computer. The really cool thing about this is you will not need a number of computers. You can do everything inside a single computer. So what we're going to do is we're going to have a hacking machine. This is going to be the machine that we will use in order to hack into other machines. We're going to install Kali Linux on it, and we'll talk about what that is later on. And we're going to have 2 target machines. These are machines that we're going to try to hack into and practice hacking against. One of them is going to be running Windows, and the other one is going to be running an operating system called Metasploitable, and we will talk about that once we get to it. Now, it is very important to understand that you will not lose any functionality when you install an operating system as a virtual machine. You can use that machine exactly as if it's a real physical machine. So the really cool thing about using virtual machines, first of all, you're not going to lose any functionality. Second, all the machines are going to be isolated. So as we go through the course, we're going to be trying to hack into these machines, and we might actually break one of them. But that's fine. It will not affect your host machine. You will be able to easily fix this and go back to a snapshot of when the machine was working without affecting your main computer. The other cool thing is that you'll be able to have a number of different versions of each of these machines, and you'll be able to change the configuration easily, change the network settings, or switch between different states of these machines, and so on. So, by using virtualization, you will not lose any functionality, but you will gain so many cool features. And the main thing to keep in mind is your host machine, your main computer, will never be affected. It's completely isolated. And if we break any of these machines, nothing will happen to your precious computer that you use every day. And this way, you can always use your host machine for daily use, for checking emails, watching the videos, doing whatever you do normally, and then use your virtual machines for hacking and practicing the attacks. And this is what I actually do. So you can see I have my host machine running OS X, and I never use this for hacking. But right here I have VirtualBox, and as you can see I have a number of operating systems installed on it, and I can literally start any of them by selecting the one I want and just click on start. Now don't worry about this, I will show you how to install these virtual machines as we go through the course. But what you need to do right now is download and install VirtualBox, this program. So you can download it from this page. I'm going to include its link in the resources. And like I said, you can install VirtualBox on Windows, OS X or Linux, so it supports all operating systems. Just pick your operating system from here, download the relevant installer and install it. Installing it is very, very simple. All you have to do is literally double click the installer, click next, 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 and it'll install it for you. Once you start it, you'll see a program similar to this, but you will not have any virtual machines here, so it will be empty. And I will show you how to install all of these machines as we go through the course. Now, throughout the course, we're going to be using a number of penetration testing tools. You can go ahead and install each of these tools manually, or you can do what most pen testers do, including myself, and save time and effort and use an operating system designed for hacking. We're going to be using an operating system called Kali Linux, and it's just a flavor of Linux based on Debian, and it comes in with all the programs and the applications that we need to use pre-installed and pre-configured. This means that we can just install this operating system and then start learning or hacking. There are two options to install Kali. You can install it as a virtual machine inside your current operating system, or you can install it as a main machine, as a main operating system. Throughout the course, I'm actually going to be using it as a virtual machine because using it as a virtual machine works exactly the same as installing it as a main machine, because it will be completely isolated from your computer because it's only going to run inside VirtualBox. So if you break it or if you mess things up, it's very, very easy to fix. It's very easy to go back to other snapshots, other configurations, and also you won't lose any functionality by using it as a virtual machine. That's why I always use it as a virtual machine. And in this lecture, I'm going to cover how to install it as a virtual machine inside VirtualBox. Now, I'm going to be doing the steps on a Mac OS X computer, but these steps are exactly the same regardless of what operating system you use. So if you're on Windows or on Linux, you just have to download the VirtualBox version of your computer, and then the steps shown in this lecture are exactly the same after installing VirtualBox. So I'm going to include the download link in the resources of this lecture, and I have it already opened in here. All you have to do is just scroll down. Make sure you click on the Kali Linux VirtualBox images, not on the VMware, and then download the version of Kali that's compatible with your system. So if you have a 64-bit computer, download the 64 bits. If you have the 32 bits, download the 32 bits. Now, one click on this will start the download for you. If you're using Internet Explorer or Edge browser, then you're going to have to right-click and save target as. On Chrome and Firefox, you can just click the link. Now, this is downloading for me, and I'm going to stop it because I've already downloaded it. So I already have it downloaded in here. And as you can see, you should get a file with a .ova extension. So you have the name followed by .ova in here. So to install this in VirtualBox, all you have to do is literally just double click the file. And as you can see, I get a window which will allow me to import this virtual machine. Now I'm going to keep everything the same for now, and I'm just going to click on import. Now that's it, the virtual machine is ready to be used. Now before I start it, I want to show you how to modify some of its settings. So we're going to click on it. Then we're going to click on the settings in here. Now, depending on the host operating system you're using, the layout of VirtualBox might be slightly different, but using it is exactly the same. So make sure you follow the steps that I'm gonna do right now, and it should work on all operating systems, whether you use Windows, Linux, or Mac OS X. So the first thing that I'm gonna do, I'm gonna go to System, and I'm gonna modify the amount of RAM it has. Now, depending on how much total RAM you have on your computer, you can leave this at 2 if you want, but 1 GB is enough for Kali. I usually leave it at 2 because I have 16 gigs of RAM, but if you have less, 1 GB is enough for it. Also, if you come here on the processors, you'll see that by default, I have 2 processors assigned to it. Again, I have 8 CPUs, so 2 is not gonna cause too much pressure on my computer. If you have less, 1 CPU is enough for Kali. Now, we're gonna go to the network settings, and we're gonna set this to use a NAT network. Now, sometimes when you set this to a NAT network, you won't see a network name in here. If you don't, please check out my link in the resources, and it will show you how to create a NAT network. For me, it already has a NAT network, so I'm going to keep it on this one. And what this setting basically does is it's going to create a virtual network where my host machine, which is my Mac OS X computer in here, is going to be the router for this network. And then all the virtual machines are going to be clients connected to this network. So they're going to get internet connection from my host machine, and at the same time, all of my virtual machines will be connected to a virtual network. This is very handy because my virtual machines will be able to communicate with each other. We can use one of them to hack into the other. We can use it to test network attacks and much more. So it'll first allow my virtual machines to have internet connection. It'll also allow them to communicate with each other. And it'll do all of this through a virtual network. It will not use any of your wireless adapters or any of your wireless cards. It'll create a virtual Ethernet network. So as far as the virtual machine is concerned, they're going to think that they're connected to a network through a wire.
Now, the last thing that I want to do is go to the ports and make sure that enable serial port is unchecked, it's disabled. And I'm also going to go to USB and make sure that enable USB controller is disabled. So I'm going to uncheck it. We will talk about how to use USB devices with virtual machines later on in the course, but for now, make sure that you disable it by unchecking this box. Now I'm done with all of the settings. We're going to click on OK.
And we can start our virtual machine. Now to start it, all we have to do is just click on the start button in here. Now I'm going to click inside the virtual machine and hit enter. And we are inside the virtual machine.
Now if you followed everything that I did so far, started Kali and got stuck at a black screen, so if you did not get the screen that I have right now, then don't worry about that. This is a common issue, and I've included a link in the resources of this lecture that shows how to fix this issue. You can access the resources of this lecture or any lecture by clicking on the resources icon on the top left of the player. If you follow all of the steps shown in the link and you're still stuck at this issue, or if you're getting a different issue, then please post this issue in the Q&A section, and we'll respond to you within 15 hours and help you to fix this issue.
Now it's asking us for the username, and the default username is root, so ROOT. And then it's asking us for the password, and the default password is the reverse of that, which is TOOR. And that's it. Now I'm inside my virtual machine. Now, since we installed this using the ready image, we can just go to view, full screen, and we'll be able to go in full screen, and the screen will resize automatically to the size of our screen. Now, note in here, you see that I have a network icon appearing in here. And if I click it, you'll see it looks like I'm connected to a wired network. As you can see in here, it says wired connected. So Kali thinks it's connected to a wired network because we set this machine to use a NAT network. So if I open my browser in here, you'll see that I have internet access. So that's it. That shows how to install Kali Linux as a virtual machine. Don't be intimidated by this new operating system. We're going to go through the basics and we're going to use it a lot. And it's actually going to become very easy for you to use. Also, like I said, you won't lose any functionality when you install Kali Linux as a virtual machine. It's actually better to install it as a virtual machine because it's completely isolated from your computer and it'll be very easy to fix if things go wrong. Keep in mind, installing this on different hardware and different computers might show you some errors and some issues. So please, if you have any errors, just add them in the discussions and I'll help you resolve them.
Now that we created our virtual machines, it's a really good idea to take snapshots of them. A snapshot allows you to store the state of the current virtual machine. So it allows you to go back in time or go forward to a certain state after you go back. So you can think of it as bookmarks. For example, now we can take snapshots of our fresh installation of the operating systems. And in the future, if we update or configure something or break something, you can literally just go back to the fresh install or go back to factory settings if you want to call it. Then, if you did something there and then you wanted to go back to your updated system, then you can go back to the updated system as well. So you can literally take a snapshot whenever you want to store the state of the machine, and then you can go back and forth between these states. Now I'll show you how to do that. I have Kali Linux right here, the one that we installed.
And it's very easy to create a snapshot for it. All you have to do is just go on the snapshots here and click on the camera icon. Then it's going to ask you to call this snapshot something. So I'm just going to call it fresh install. And I'm just going to give it a description saying it's a fresh snapshot with no updates. It's always a good idea to give a good name and good description so that in the future you can actually remember what these snapshots stand for. So now that I'm done, I'm just going to click on OK. And now you can see that we have the current state. So whatever you do in here, you can update, you can install programs, you can install libraries. And then if you break something, or if you ever wanted to go back to the fresh install, you can just come back, click on the fresh install and restore. So let's see now. I'm just going to go back to the details as normal, and then we're going to start our virtual machine. I'll just show you an example now. So let me just create a new directory in here. And I'm just going to call it test. So let's imagine that you actually updated the system. Now in the future, we're going to talk about updating the system. And I'm going to tell you that when you update, there is a good chance that some libraries, some programs will not be as up to date as the libraries that will be installed. And then these programs might start giving you issues. Now, if you had the issues, you can put them into discussion and then I'll help you with them. But some cases, I'll tell you that you need to go back or downgrade to the older version without the update. So all you'll have to do is just get back to the fresh installation to your fresh snapshot. So now I've just created a new file just to show you that once you actually go back, everything will go back to the way it was before the changes that you made. So I'm just going to turn off Kali. And now if we go back to the snapshots, you'll see that we have our current state. This state has been changed, so it's a changed state. Now let's say that you updated and the update was successful, so nothing was broken and you are happy with it. So what you should do is you should just come in and click on the camera icon again to create another snapshot. And we're going to call this one updated system. And then you can just put the date if you want to. And then I'm just going to put the description updated with no problems. So I'm going to click OK. And you can see that we have two snapshots. We have the first one, which is our fresh install. And then we updated our system and we have an updated snapshot of an updated system. So now let's say that after you updated and you thought everything is okay, you are using the machine and you have problems, so you wanted to go back to the fresh installation. All you have to do is just click on the fresh install. And you can see that the restore icon right here, just click that. It's going to ask you, do you really want to do that? I'm going to say yes. And now it restored me to the fresh installation. So now if I start the Kali machine, you'll see that the new directory that we created will disappear. Now, as you can see, we're back to where we were without the new directory, without anything. So we are actually back to the fresh installation of Kali, to when we actually took the snapshot. So now I'm going to show you another example. So let's say you went back in time and you went back to your fresh installation, and then for some reason you wanted to go back to your updated state to see if you can fix the issue. If I suggested the solution, or if you read the solution online and you want to go back and fix the issue that you had after the update, or for any other reason, maybe you just wanted to go back to a different state. It wasn't an updated state. I'm just giving an example with the update. So if you want to go back to a future state, you can still do that. So all you have to do is just again click on the updated, click on the restore. And we don't want to create a new snapshot from the current state because the current state is the updated state. So we're going to restore this, start the machine, and you'll see that we'll be back to the updated state to where we had the new directory created. So we're actually going to go back in the future now. And as you can see, now we have our test directory. So we're back to the state where we updated the system. So again, as you can see, the snapshots can be really useful. They can allow you to store bookmarks or states of the operating system. So you can actually have different configurations and you can switch between them as you want. Okay, now that we have Kali Linux installed, I want to give you a basic overview of this operating system in this lecture so that you're comfortable with it. And we're going to be using it throughout the whole course. So everything is going to become easier for you as we go through the course. Now, the first thing that I want to talk about is the status bar in here. So you can see we have an applications menu in here, and inside it, you can see all the applications are categorized. So we have information gathering applications, vulnerability analysis, web application analysis, reverse engineering, and so on. So you can go on each one of these entries and just select any program that you want to run. And the next menu that we have is the places, which shows you the most common places in the file system. So we have home, we have the desktop, we have the documents, downloads, and so on. So you can access the places from here and then you click on home, or you can just click on the files icon in here on the left, and both of these will bring you to the home directory, which is actually the root directory. So it says home in here, but the actual location of this, if I do Control L, you'll see it is /root. So inside this, you can see we have our downloads, music, pictures, similar to the way that you'd have it in Windows and OS X. We also have the time in here, and in here on the right, we have more controls. So the first thing that we have in here is the workspaces. So Linux comes with multiple workspaces by default. Basically, what this allows us to do is we can have this desktop in here. For example, we can open the places and we can, for example, navigate to downloads and do some work in here. But if we go here to workplaces and go to the second one, you can see that I have an empty desktop that I can do whatever I want. And for example, I can launch Firefox in here. And then again, if I want to go back to the first workspace, all I have to do is click on here, click on number 1, and I'm back in here. And because I've already used up 2 spaces, the system is already creating a third empty space, so I can click on that, and as you can see, I'm in the third space where I can do more stuff. Now you can also navigate between the spaces by pressing Ctrl-Alt up or down to go up and down in the spaces. The next part of the status bar is this last part in here, and if you click on it, basically the first thing it'll allow you to do is control the sound. Next, you'll see your connections. So as you can see right now, and as I showed you before, this is showing up as if we're connected to a wired network because I configured this network to use a NAT network. If you have a wireless adapter connected to this computer, you should be able to see it here. If you don't see it, then follow the link in the resources of this lecture to see how to properly connect your wireless adapter or any USB device to a virtual machine. Now I should note, you can only use external USB adapters in order to access Wi-Fi networks from Kali. You cannot use the built-in Wi-Fi card. But Kali should have internet connection anyway because it is configured to use a NAT network, and as you can see in here, it's telling me my wired is connected. So if I actually go down to Firefox, I'll close this. And if I just go to google.com, you can see it is connected to the internet. So let's go back to where we were. And if we click here, we also have the battery settings, the user settings. You have this button to turn off the machine. This is to lock the machine, and this will show the preferences where you can modify the preferences of the machine. So you have Bluetooth, Wi-Fi, change the background, change the languages, and so on. So you can spend some time getting familiar with this. It's very easy and very intuitive. Same goes to the file manager in here, very intuitive. Double click to go in. You can right click and archive and extract here to uncompress it. You can navigate throughout these files by clicking them, and then you have the trash here, which contains the deleted files. Now we also have the dock in here, which contains the favorite applications, and you can also access all the other applications by clicking on this icon right here, the show applications, and this will show you a menu with the most frequent applications, and then if you click on all, it will show you all the available applications. Okay, now that we had a quick overview of Kali Linux, I want to spend some time talking about the Linux terminal. So you can access the terminal through this application right here. So if we click on that, it will open the terminal window for us. And as you can see, all it is a black screen where you can type commands. Now, the Linux terminal is actually very, very powerful because it can be used to do anything that you can think of, really. A lot of the applications in Linux that have a graphical interface were command prompt programs first, and then people made a graphical interface for it. So a lot of the time, maybe the graphical interface will be buggy or crash, and the terminal program will still work. Also, a lot of the penetration testing tools do not even have a graphical interface. A lot of them can only be used throughout the terminal. Not only that, but in many scenarios, you might only have an SSH or a command prompt access to a machine. So you need to know how to use this command prompt in order to achieve your goals. So throughout the course, we're going to be using the terminal a lot, and that's why I want to spend some time just showing you the basics of it and making sure that you're going to be comfortable using it. Now, the basic idea is you type a command and the result will be displayed for you on screen. So let's have a look on a very, very simple command, which is pwd. Now this command prints the current working directory, hence the name pwd. So if I hit enter, you can see it's printing /root, which means right now I am in the root directory. So basically I am in here. This is the root, it's home. So if I do ls, which is a command to list all the directories and files in the current working directory, we should get all of these directories that we see in here. So if I hit enter, as you can see, I can see all these directories in the current working directory. Now, another very useful command is the cd command. This command allows us to navigate into another directory. So for example, let's say I want to navigate into the downloads. All we have to do is type cd followed by the name of the directory that I want to navigate to. So I'm going to type downloads. Now if I hit enter, I should be inside the downloads now. So if I do pwd to see my current working directory, you'll see that it's saying I'm in root /downloads. So if I do ls here, it should show me all the directories and files inside downloads. So if I do enter, as you can see, I have a directory and a file in here. And these are the exact same files that you'll see if you double click the downloads here. Now, if you want to go back one directory, so similar to pressing the back button in here, all you have to do is do cd, again the command to change the working directory, followed by ... And now if I do pwd, you'll see I'm back in root. And if I do ls, you'll see all the directories and files in root. So that's all good. And there's actually a huge number of commands that you can use. So I'm going to include a link in the resources of this lecture of all the Linux commands that you can use. You don't need to know them by heart. We're actually going to be using a lot of them throughout the course. So you're going to naturally learn them as you go through the course. Now, if you are using a command and you're not sure about how this command works, you can just use the man command to display the manual of this command. For example, we've used the ls command here to list the files and directories in the current working directory. But if I do man followed by ls, this basically means I'm requesting the manual of ls. So I'm asking, how can I use the ls command? So if I hit enter, you'll see I'll get a screen similar to a text file. And basically it's giving me a lot of information on how to use the ls command. So you can see that it's telling us that this command will list the directory contents. You can see the way it works by typing ls followed by the options followed by a file if you want to run it on a file. You can see a longer description of the command. And then you can see all the options and the arguments that we can use with this command. Now, in Linux, most of the time, the options will always follow the same syntax. So you either use -letter or -- a word to specify the argument. For example, in here, the -a and -- will ignore entries starting with dot. So if you keep going down in here, you'll see all the options and arguments you can use with the ls command. And we have another example here. We have the -l, which means it's going to use a long listing format, which will display more information about the files in the current working directory. So let's have a look on that. I'm going to press Q to exit this, and then we're going to do ls as usual. And since we read the manual, we know we can do -l to see more information about the files. And if I hit enter now, you can see I'm still getting the same directories, but it's also showing me the permissions, the users, the date created, and so on. So you can use the man command on any command you want, not only on the ls. So you can use it on the pwd, you can use it on the cd, or any other command, and it'll show you full description or the manual page of how to use this command. Now, I'm going to clear the screen by typing clear. And the next thing that I want to show you is the --help. So this is something that you can use again in almost all commands and all programs in Linux. So you can just type the program name or the command name followed by --help. As you might think, this will show you a help message telling you what this command is or what this program is, the arguments that it takes, how to use these arguments, and examples at the bottom. Now, another useful thing with the terminal, so I'm going to clear this again, is the arrows. So you can press up to go up to see all the commands that we executed before, and again you can go down to navigate between the commands that you executed previously. You can also use the tab for autocomplete. So again, let's do ls, and you can see all the files, and let's say we want to go into documents. So we can do cd followed by documents. You can type documents, or if you're lazy like me, you can just do doc and press tab, and as you can see, it's automatically completing the rest of the word for me. So this is something that comes very, very handy when you're using the terminal for a long time. Now, what I also want to show you is how to install programs in Kali from the terminal. So first I'm going to clear this. And the first thing that you want to do is update the sources where Kali can search and download programs from. So we're going to do apt-get update. Now, apt-get is the name of the application that allows us to download and install programs. And we're saying update because I'm saying that I want you to update the list of all the programs that I can install. So I'm going to hit enter. And you want to make sure that you have internet connection when running this. And as you can see, it's telling me that it's done. And now we can go ahead and start installing applications. So the first program that I want to install is actually a terminal program, so similar to this one, but it allows us to have multiple terminal windows open in the same window. So in order to install a program through the command line, we're going to do apt-get, which is again the name of the program that allows us to install programs on the system. We're going to say that I want to install, and the program that I want to install is called Terminator. So very, very simple. First of all, we're typing the name of the command, which is apt-get. We're saying that I want to install, and the program name that I want to install is called Terminator. So I'm going to hit enter. And this is going to download and install Terminator for me. So you can use the same command to install any program that you want. You just need to replace Terminator with the name of the program that you want to install. Now, I've already downloaded and installed this before, so it didn't ask me to confirm. But if you're running this for the first time, it might ask you to confirm whether or not you actually want to install this program. So all you'd have to do is press Y from the keyboard and hit enter. Now, as you can see, it's done. So if I go to my all applications in here and just type Terminator, you can see that I have it here. So I'm actually going to drag it and put it in my dock so I can access it easily in the future. So now I can just click it in here and that will open Terminator for me. Now this is another application that allow me to run commands. So it's exactly the same as this. So again, I can do ls and pwd. The only difference is with this one, I can actually right click and click on split horizontally, for example. And this will split the same screen into two screens where I can run commands at the same time. So I can have some commands in here and I can run commands in here. And then I can even split this more if I want, again, vertically or horizontally. And as you can see, I can have as many terminal windows as I want. And this will be very helpful in the future when we'll be running a number of programs and a number of commands at the same time. Now, before we start talking about network hacking, you need to have a basic understanding on how networks work. Now, we all know that a network usually contains a number of clients connected to each other, and clients usually connect to a network in order to share data or share a resource. A really good example of a resource that we all have connected to networks in order to access is the internet. So we connect to Wi-Fi networks and even wired networks all the time just to access the internet. Now, all networks, whether it's Wi-Fi or wired, work on the same principle. They have a device that is considered a server. Now, in many cases, for example, in your home network, this server is your router. This is also referred to as an access point. Now, this router or server or access point is the only device that has access to the resource. So none of these clients have direct access to the resource even after connecting to the network. The only way they can access the resource is through the access point. So let's say, for example, you're client number 1 and you connected to your home network over Wi-Fi or over Ethernet over a cable. And then you opened your browser and you typed google.com. What happens is your computer will send a request to the access point asking for google.com. The access point has access to the resource, which is the internet in this example, so it's going to go and look for google.com. It will receive google.com and it will forward that response to your computer, and as a result, you will see the website loading on your browser. So if you actually go to your router at home and look at it, you'll see at the back it's connected through a cable to the wall, and this is how it's getting its internet access. Therefore, it is the only device in your network that has direct access to the resource, and none of your computers, none of the computers connected to the network can access the resource or can access the internet without the router, without the access point. So the only way for all of the connected clients to access the resource is to go through the router. Now the data is transferred between the clients and the access point as packets. So you can think of all of these arrows as a series of packets being transmitted between the client and the router as requests and responses. Now in Wi-Fi networks, these packets are transmitted in the air. Therefore, if you have a wireless card and you're within range, you'll be able to capture all of these requests and responses. So basically, you'll be able to see anything that any computer connected to the same network as you does on the internet. Because they will have to send all of this data to the access point, and because they're sending this data in the air because you're in a Wi-Fi network, you'll basically be able to capture these requests and responses, and you'll be able to see the URLs they visit, the usernames, the passwords they enter, the chat messages. Anything they do on the internet will be sent as packets, and therefore you'll be able to capture it and analyze it. We'll talk more about that and more about how networks work as we go through the course, but this is enough to get you going through the next few lectures so that you can sniff data, analyze it, and start launching some cool pre-connection attacks. In this lecture, I'm going to show you how to connect a USB device to a virtual machine. As an example, I'm going to be connecting a wireless adapter to my Kali machine. But the same method can be used to connect any USB device. Now, as mentioned in the course requirements, you need a wireless adapter for the cracking section of this course. So these are the lectures where we're going to show you how to crack the passwords for Wi-Fi networks. Other than that, you can do everything else in the course without a wireless adapter. What I mean by a wireless adapter is a USB device that connects through USB to your computer, and it allows you to communicate with wireless networks. Now, most computers and laptops come with a built-in wireless card. The only problem is, first of all, you can't access built-in wireless cards from a virtual machine. Also, even if you can, so even if you install Kali as a main machine, the built-in wireless cards are not good for hacking because we need a powerful adapter that supports monitor mode and packet injection, and we're going to go into what each of these mean. But basically, the built-in wireless adapter does not support these modes and can't be used for hacking. That's why I recommend powerful wireless adapters. They're listed in the course requirements, and I'm going to list them in the resources of this lecture, and you can connect them to Kali like I'm going to show you right now. So I already have VirtualBox open, and you just want to click the machine that you want to connect the adapter to. We're going to go to its settings. We're going to go to ports. We're going to go to USB. And make sure that USB is enabled, and you want to pick the USB option that is used by your adapter. So it's either USB 1, 2, or 3. And for the adapter that I have, it uses USB 2. Then you want to come here to the plus sign and click on it. Now you'll see that I have a number of devices that I can attach to the Kali machine. Now I still haven't connected the adapter. So first of all, I'm just going to have a look on the available devices. Then I'm going to connect the adapter. And I'm going to list the devices again. I did that because we're assuming that I don't know the name of my adapter, because the name that you'll see here is the name of the chipset that's used inside the adapter. So it's not the brand name that you see on the adapter itself. So when I click on it now, you'll see that I have a new entry called Atheros, and this is actually my wireless adapter. It's an Alpha AWS 036NHA. So I'm going to click on it. That's it added here. I'm going to click on OK. And that's the adapter added to Kali. Now, before we can start Kali, we have to install VirtualBox extensions to allow VirtualBox to use this USB device. Now, the download link will be included in the resources. I have the page already opened in here. And you can see in here, we have a link for VirtualBox extension pack. And you can just click on this link to download it. Now, this will only work for VirtualBox 5.1.22. If you have a different version, so to get your version, you can just go to VirtualBox, About VirtualBox. If you're on Windows, you'll have to go to File, About VirtualBox, and you'll see that I'm on 5.0.20. So I'll have to come back here, and I don't have the latest version, so I'm going to have to go down to the VirtualBox older builds, go on 5.0,
and look for 5.0.20 and download its extension pack. So if you have the latest version that's listed on the main page, then download it from there. If you have an older version, go to the old builds like I did, scroll down and download the one that is compatible with your version. Now once it's downloaded, you'll be able to find it in your downloads or to whatever location you downloaded it to. And then you can just double click it to install it. So this is the one that's compatible with my VirtualBox. I'm gonna double click it. And as you can see, for me, it's telling me that it's already installed. For you, it's just going to give you an install button. For me, it's called reinstall. So I'm just going to reinstall it just to show you how it's going to go. And we'll need to scroll down and agree. Put your password. And that's it. The extension pack is installed. So I'm going to hit enter. Now, before starting my virtual machine, I'm going to physically disconnect my wireless adapter, and then I'm going to connect the adapter once Kali fully loads. Now I'm going to start it. So I'm going to put my username, which is root, and my password, which is TOOR. Okay, now Kali is fully loaded. I'm going to go and physically connect my wireless adapter. And like I said, I usually do this just to avoid any conflicts. Now, once the adapter is connected, you want to make sure that it's attached to Kali. And to do that, we're going to go to the devices menu. So we're going to go all the way to the top. We're going to go to devices. We're going to go on USB. And we're going to make sure that this adapter right here is checked. Now, sometimes it might not be checked for you, so click on it to check it. For me, it's already checked, so I'm not going to click it. And to confirm that the adapter is connected, we can just go on terminal right here and type ifconfig. This command lists all the interfaces that's connected to the machine, and as you can see now, it's showing an adapter called LAN 0, which is the wireless adapter. So if you have this in here, that means your adapter is connected. If you don't, then ask in the discussions and I'll help you through this. Some adapters are not compatible with Kali, so that could be the issue, or the issue could be something else. Also, now if we go here on the top right, you'll see that I have a Wi-Fi option, which I can use to connect to Wi-Fi networks. Now, we don't need to do this because I showed you how to set up a NAT network, and Kali already has internet access through this NAT network. So we only need the wireless adapter to hack into other networks to crack their passwords.
When it comes to networking, you probably heard of the term MAC address a lot. So in this lecture, I'm going to cover what do we mean by MAC address, what it's used for, and how to change it. MAC address stands for Media Access Control. It's a permanent, physical, and unique address assigned to network interfaces by the device manufacturer. So whether you have a wireless card or a wired or Ethernet card, each one of these network cards come with a specific address that is unique to this card. So there is no two devices in the world that would have the same MAC address, and this address will always be the same to this specific device. Even if you unplug it from your computer, connect it to another computer, then this network device will always have the same address. So you might already know that the IP address is used in the internet to identify computers and communicate between devices on the internet. The MAC address is used within the network to identify devices and transfer data between devices. So each piece of data or packet that is sent within the network contains a source MAC and a destination MAC. Therefore, this packet would flow from the source MAC to the destination MAC. So, because this is a physical unique address to each interface, to each network device, and because it is used to identify devices, then changing it will make you anonymous on the network. Not only that, but the MAC address is often used by filters to prevent or allow devices to connect to networks and do specific tasks on the network. So being able to change your MAC address to another device's MAC address will allow you to impersonate this device and allow you to do things that you might not be able to do. So you'd be able to bypass filters or connect to networks that only specific devices with specific MAC addresses can connect to, and you will also be able to hide your identity. Now, changing the MAC address is very simple. So let me show you how to do that. First of all, I'm going to use the ifconfig command to list all the network interfaces available on my Kali machine. What I mean by network interface is any device that allows us to connect to a network. So an example is a Wi-Fi card or an Ethernet card and so on. So you can see, first of all, we have ETH0, and this is a virtual interface created by VirtualBox when we set Kali to use a NAT network. So you can see the interface name is ETH0. You can see it has an IP address because, like I said, it's connected to a network. So if we go here, we can see it's saying wired connected. So this is the interface that represents the wired network that Kali is connected to, which is actually a virtual NAT network. You can also see the net mask, the broadcast, and a really important piece of information, which is the other. This is the MAC address of this virtual interface. Now you can see similar information for my other two interfaces, the LO and the LAN 0. The only thing is, you can see for both of these interfaces, we do not have an IP address. And the main reason for that is because none of these interfaces is connected to a network. Now LO is a default interface created by Linux, and LAN 0 is my real wireless adapter, so I can use it to connect to Wi-Fi networks. But if I go on the network in here, you'll see Wi-Fi is not connected because I actually didn't connect to any network, and that's why it does not have an IP address. Now this doesn't matter because what we want to do is to just change the MAC address, which again is shown here under the other part. So similar to what you're seeing here for ETH0. Now, in order to change any of the values that you see in here, you have to first disable the interface. So, in this example, we want to change the MAC address. So that is represented by the other, and the value is right here. So, in order to disable an interface, we're gonna do ifconfig, followed by the interface name, which is LAN 0 in my example, followed by down to disable it. Now, if I hit enter, you'll see the command runs with no errors, so it means that it got executed properly. And the next thing that we need to do is to change the option that we want to change. And in this example, we want to change the other, which is the MAC address. So first we're gonna type ifconfig. We're gonna type the interface that we want to change one of its options. Then we're gonna type the option that we want to change. And what we want to change is the hardware address. So we're gonna do HW ether. Then we're gonna give it the address that we want to change the MAC address to. So for example, I'm gonna use 001122334455. Very simple command. We're doing ifconfig LAN 0 to select the interface that we want to change its option. We want to set the hardware address, and we want to set this address to this specific address. So you can use any address that you want following the same format shown here. Just make sure your address starts with 00. So I'm gonna hit enter, and again we don't see any error messages, so it means the command got executed properly. And finally, we just need to enable the interface because we disabled it by doing ifconfig LAN 0 down. So we just need to do ifconfig LAN 0 up to enable it. Now the interface is enabled, and if we do ifconfig again and look at the other part in here, you can see that it is changed to the MAC address that we specified. Now this is done and your MAC address is changed. Now you can go ahead and start using the interface, and it will appear to have this MAC address instead of its original MAC address. And like I said, this can be useful in so many scenarios. Now, depending on how you're going to use your interface, the network manager that comes pre-installed in Kali and most Linux distros might automatically reset your MAC to the original. Now, not everybody will face this issue. That's why I'm not going to show you how to fix this issue in this video. But if you do face this problem, then I've included a YouTube video in the resources of this lecture that shows how to fix this issue. From the previous lectures, we learned the basics of how networks work. We learned that devices on the same network communicate with each other using packets. So regardless of what you do on the network, whether you're watching a video, whether you're logging into a website, sending chat messages, sending emails, regardless of what you're doing, all the data is sent as packets. Now in the network, devices ensure that these packets go in the right direction using the MAC address. So each packet has a source MAC and a destination MAC, and it flows from the source to the destination. So in this example, we have the client, it has this MAC, we have the access point, which has this MAC. And as an example, if this client wanted to send a packet to the router, it will set the destination MAC to the router's MAC address. Therefore, by default, each device only receives data that has the destination MAC as its own MAC address. But if you remember, I said in wireless networks, if you're within range, then you'll be able to capture all of this communication because these packets are literally sent in the air. So we can just capture them even if they do not have our MAC address as the destination MAC. To do this, we need to change the mode of operation of our wireless interface so that it operates in monitor mode. So let me show you what I mean. If I go to my computer here and run iwconfig this time, so we've seen ifconfig, which lists all the interfaces. We can use iwconfig to see the wireless interfaces only. And you can see we have LAN 0 right here, which is my external wireless adapter. And you can see the mode of this adapter is set to managed. What this means is basically this is the default mode of all wireless devices, and what it means is this device will only capture packets that has the destination MAC as the MAC address of this device. So basically it will only capture devices that are directed to my Kali machine. But this is not what we want. What we want is to be able to capture all the packets that are within our range, even if they are sent to the router and even if they are set to another device. So to do this, we need to set the mode to monitor mode instead of managed mode. So as usual, before you can change the options of your interface, you have to disable it. And previously we've seen we can do that by doing ifconfig, the device name, which is LAN 0 in my case, down. Then we can enable monitor mode. But before we do that, I'm actually going to run a command to kill any process that could interfere with using my interface in monitor mode. So the command that I'm going to run right now is not mandatory, but running it will actually give you better results when you come to running the attacks that you will learn as we go in the course. So this command is going to be airmon-ng check kill. Now you'll notice when you run this command, it'll actually kill the network manager that usually runs in here. So you'll completely lose your internet connection. But this is no problem because we will only need to be in monitor mode when we are running pre-connection attacks. So attacks that do not require us to connect to any network. So we actually do not need internet connection to run any of the attacks that require monitor mode. Now we're going to enable monitor mode. So we're going to do iwconfig followed by the interface name that we want to enable monitor mode on, which is LAN 0. We're going to say that I want to change the mode and I want to change that to monitor. So very simple command. We're using iwconfig to change the mode. We're given the name of the interface that we want to change its mode. We're saying I want to change the mode and I want to set it to monitor mode. Now if I hit enter, you'll see the command will run with no errors, which means the command got executed properly. And finally, we'll need to enable the interface, again similar to what we did when we changed the MAC address. So we just have to do ifconfig LAN 0 up. That's done. Now if I run iwconfig again, you will see that the mode is set to monitor now. So basically this interface now can be used to capture any packet that is within our range, not only the packets that are directed to this computer. That's why in the future you'll see how we can use it to sniff packets, to analyze them, and even break into networks. So in the future, if I say use your interface in monitor mode, this is what I mean. You'll basically have to enable monitor mode as shown in here. Now I've also included a YouTube video in the resources of this lecture to show an alternative method to enable monitor mode. Just in case you got errors with this method or you tried to follow something that I do in the next lectures and it didn't work, then you can come back and try the alternative method. But if this worked and if monitor mode is enabled successfully, then you don't need to watch that video, you can just continue with the course. One more thing to keep in mind, not all wireless adapters support monitor mode. So for this to work, you need to make sure that your actual adapter supports monitor mode. There are a number of adapters that support that, and I've included another video, again in the resources, of me talking about wireless adapters, how to pick the best one, and which ones that I recommend and use when I'm testing the security of networks. Now that we have enabled monitor mode on our wireless interface, we are able to capture all the Wi-Fi packets sent within our range. Even if the packet is not directed to our computer, even if we're not connected to the target network, and even without knowing the key or the password to the target network. So all we need right now is a program that can capture these packets for us. The program that we're going to use is called Airodump-ng. It's part of the Aircrack-ng suite, and it's a packet sniffer, so it's basically a program designed to capture packets while you're in monitor mode. So it'll allow us to see all the wireless networks around us and show us detailed information about its MAC address, its channel, its encryption, the clients connected to this network, and so on. So let me show you how we're going to use it. First of all, you need to enable monitor mode on your wireless adapter as shown in the previous lectures. So if I go to my Kali machine and run iwconfig to list all the wireless devices on this computer, you'll see that I have an interface called Mon0, and this interface is in monitor mode. Now, depending on the way that you enabled monitor mode, this can be called LAN 0, it can be called LAN 0 mon. It doesn't really matter. You just want to make sure you enable monitor mode using one of the methods shown before, and then use the name of the adapter that is in monitor mode when you run Airodump-ng. Now, to run Airodump-ng, we're just going to type the name of the program, which is Airodump-ng, followed by the name of my wireless adapter in monitor mode, which is mon0, as you can see in here. So the command is very simple. We're typing the program name, which is Airodump-ng, followed by the name of my interface in monitor mode. If I hit enter, you'll see it'll start working, discovering all the wireless networks around me and displaying useful information about them. This program will continue working unless you quit it, and to quit this program, you have to press Ctrl-C from your keyboard. You can actually use Ctrl-C to quit any running program in your terminal. Now that we stopped the program, let's analyze the output so we understand what it's showing us. So first of all, if we look at this column, the ESSID column, it should be a little bit familiar to you. And basically, this shows us the names of the wireless networks around us. So if I just go to my Mac machine and look for wireless networks, you'll see the same names that we see in here displayed under the ESSID. Now, all of the other columns show us more information about the network name that you see in here, and this information will actually be very useful to us as we go through the course. The first column, the BSSID, shows us the MAC address of the target network. Next, we have the PWR, so this is the signal strength or the power of the network. Now, the higher the number, the better signal we have. So for example, the network with the best signal right here is this one. Next, we have the beacons. These are frames sent by the network in order to broadcast its existence. So every network, even if it's set to be hidden, always sends these type of frames, basically broadcasting its existence and telling all the wireless devices around it that I exist, I have this BSSID, I work on this channel, I use this encryption, and my name is this. Next, we have the number of data packets or data frames, and these are the useful packets that we'll talk about later on once we get to the cracking section. This column represents the number of data packets that we collected in the past 10 seconds. Next, we have the channel, which is the channel that the network works on. So for example, this network right here, the test AP, works on channel 6. This network works on channel 1, and so on. Next, we have the maximum speed supported by the network. The encryption is a very important column, and it shows us the encryption used by the network. So we can see that the test AP network is using WPA. We can see we have a network that uses web. We can see this network right here is an open network, so it doesn't use encryption. We don't even need a password to connect to it. And we can see we have a WPA2 network right here. Cipher is the cipher used in the network. So we can see here we have CCMP, we have web, and we have CCMP again here. Auth is the authentication used on that network. And in here we can see it's PSK, pre-shared key, and MGT for this network. Now don't worry about the INC, the cipher, and the auth. We will talk about breaking into all these networks into web, WPA, and WPA2 in the gaining access section. And finally, you can see we have the ESSID section, which shows the name of the network. So this is what you see when you look for networks in your network manager. So that's it for this lecture. I just wanted to give you a quick look on how to discover all the networks around us using Airodump-ng. Don't worry about Airodump-ng too much now. We're going to be using it a lot in the next lectures, and you'll get very comfortable with using it as we go through the course. In the last lecture, we've seen how to use Airodump-ng to list all the networks around us and display useful information about them. Usually, we do this in order to see our target network, see the signal strength, see how far we are from it, and then start targeting this target network. Now, in this example, I'm going to assume that my target network is this one right here. This is actually the network that my host machine is connected to. And now that I have my target network and I have some basic information about it, let's see how we can run Airodump-ng against this network only, not against all networks. And this way we'll be able to gather more information about it. So to do this, first of all, I'm going to have to write the name of my program, which is Airodump-ng. Then I'm going to specify a specific BSS ID or a specific MAC address for Airodump-ng to sniff data from. So my target network has a BSS ID of this. We can see it here under the BSS ID. So I'm going to copy it. And then I'm going to do --BSS ID. And I'm going to give it the BSS ID that I just copied. Next, I'm going to specify a channel for Airodump-ng to sniff on. Again, if we look under the channel column in here, we can see my target network is on channel 2. So I'm going to do --channel 2. So now we're telling Airodump-ng that I want you to sniff data on channel 2 and only from a network that has this BSS ID. I'm also going to tell Airodump-ng that I want you to store all the data that you're gonna gather for me in a file. So I'm gonna say --write, and then I'm gonna type a file name, and let's call this test. And at the end, as usual, I need to give it the name of my wireless adapter in monitor mode, which is mon0 in my case. So, very simple command. Let's go over it one more time. We're doing Airodump-ng, that's the name of the program that I want to use. I'm telling it that I only want you to sniff data from a specific BSS ID. Then I'm giving it the BSS ID of my target. Then I'm telling it I want you to only sniff data from a specific channel. And I'm giving it the channel that I wanted to sniff data from. Again, we can get it from here, it's number 2. Finally, I'm telling it that I want you to write all the data that you're going to capture in a file that we're going to call it test. And then I'm giving it my wireless adapter in monitor mode, which is mon0. Now I'm going to hit enter. And as you can see, unlike the last time, Airodump-ng is only showing me one network in here. This is the network that I wanted it to sniff data on. And we can also see we have a completely new section right now. So when I ran Airodump-ng in the previous lecture, you seen I only had the networks in here and I had nothing here at the bottom. But now you can see we have more entries in here at the second section of Airodump-ng. And basically anything that you see here in the second section, these are the clients or the devices connected to this network. So right now we can see this network has 3 devices connected to it, and you can see the MAC addresses of these devices under the station. So you can see all of these devices are connected to the same network. So the BSS ID is still the same. This is the MAC address of the network, and under the station we have the different clients or different devices connected to this network. We can also see the power, so this is the signal strength of each of these devices. We can see the speed, we can see the amount of data lost, we can see the amount of frames or packets that we have captured, and we can see if any of these devices are still probing for networks. So sometimes when you run Airodump-ng against all networks, you'd still see this section, and you'd see that some devices are not connected and they're literally trying or looking for networks. So you'd see the name of the networks that they're looking for under the probe. Now, if I hit Ctrl+C, Airodump-ng will quit, it'll stop working, but I should have new files in my current working directory that contain the data that we just captured. Because remember, when we ran the command, we used the right option in here to store the data in a file called test. So if I just do ls to list all the files in my current working directory, you can see I have 4 files. All of them start with test, but they all have different extensions. So we have a CSV, we have a netxml, we have a cab, and we have a Kismet CSV. Now also notice that Airodump-ng automatically appended -01 to each of these files. So in the future, when you go and try to use the capture file, make sure you append -01 to the file name that you specify in the command. Now, the main file that we're going to be using is the cap file. Again, this file contains the data that we captured during the period that Airodump-ng was working on in here. And basically, this file should contain everything that was sent to and from my target network. So it should contain URLs, chat messages, usernames, passwords, or anything that any of these devices did on the internet. Because anything that they have to do will have to be sent to the router, as we've seen before. The only problem is, if you look at the encryption in here, you can see that my target network uses WPA2 encryption. So all of the data sent between the router and the clients is encrypted. So let me show you what I mean. I'm going to use a tool called Wireshark to analyze the data. And don't worry about how to use Wireshark. We will talk about it in details later on. Right now, I just want to make sure that you understand the idea that now we're able to capture all these packets. The only problem is these packets are encrypted. So I'm going to do Wireshark to run Wireshark. And then I'm going to open my capture file. So I'm going to go to File, Open, and it's already in my root directory. So I'm just going to scroll down and select my test1 cap. I'm going to open it, and I'll just put this in full screen. And as you can see, if we click on any of these packets, you can see we really have no useful data. You can see everything looks like gibberish, and we can't read anything, even though these packets might contain usernames, passwords, or URLs. The only useful thing that we can see here is the device manufacturer. So we know one of the devices connected to the network that has this specific MAC address. So it's the one that ends with E8. And if we go up, we can see that it's this specific device. We know now it is an Apple device. So it could be an Apple computer, it could be an iPhone or an iPad. And this is actually my MacBook computer that is the host machine. Again, we can see we also have a device that's using a Huawei chipset. So this can be a phone, or it could be the router. And if you look at the MAC address here and compare it to the MAC addresses that we have here, you can see that this is actually under the BSSID. So this is the MAC address of the router. So now we know that the brand of my router is Huawei. So we can gather more information by opening this file in Wireshark, and we can kind of guess what computers are there and what operating systems they use. But this is not detailed enough. And the main problem with this is the fact that the network is using encryption. Now, in the next section, we're going to be talking about how to break this encryption. And once we do, you'll see how we can see the passwords, the usernames in plain text. And you'll also see how we can map all of the computers on the same network, gather detailed information about them, hack into them, and do some really, really cool stuff. Now you should guess by everything that I said so far, if this network was an open network, if it was a network that does not use any passwords, then you would have been able to actually see all the URLs and everything that they do in here. But again, if you can't connect to the network without a password, then you'll automatically be at the post connection section. And in that section, like I said, we're gonna talk about some really cool attacks that you can do once you have the password or once you can connect to the network. So don't worry about Wireshark for now. I just wanted to make sure that you understand why encryption is useful and why it's used and why we can't see much now because we don't know the key. We will talk about Wireshark and all of that later on in the next section. Now, before leaving this section and moving to the gaining access section where I'm going to teach you how to break the different encryptions and gain access to networks, I want to spend one more lecture talking about a really useful attack that still falls under the pre-connection attacks under this section. The attack that I want to talk about is the Deauthentication attack. This attack allows us to disconnect any device from any network before connecting to any of these networks and without the need to know the password for the network. To do this, we're going to pretend to be the client that we want to disconnect by changing our MAC address to the MAC address of that client and tell the router that I want to disconnect from you. Then we're going to pretend to be the router, again by changing our MAC address to the router's MAC address, and tell the client that you requested to be disconnected, so I'm going to disconnect you. This will allow us to successfully disconnect or deauthenticate any client from any network. Now we're actually not going to do this manually. We're going to use a tool called Airodump-ng to do that. From the previous lecture, we know that this MAC address right here belongs to an Apple computer, and like I said, this Apple computer is actually my computer right here. And as you can see, this host machine is connected to this network right here, which is the same as the one that you see in here. And it actually has internet access. So if I just look for test, you'll see that I'm connected and I can look for things. I can use Google. So I have a proper working internet connection. Now, we're going to come back here and we're going to use a tool called Airodump-ng to launch the deauthentication attack and disconnect this Mac computer from the internet. So we're going to type the name of the program, which is Airodump-ng. We're going to tell it that I want to run a deauthentication attack. Then I'm going to give it the number of deauthentication packets that I want to send. So I'm going to give it a really large number so that it keeps sending these packets to both the router and the target device. Therefore, I'll disconnect my target device for a very long period of time, and the only way to get it back to connect is to hit Ctrl+C and quit Airodump-ng. Next, I'm gonna give Airodump-ng the MAC address of my target network. So I'm gonna do -A and give it the MAC address, which I'm gonna copy from here. Then I'm gonna use -C to give it the MAC address of the client that I want to disconnect. And the client that I want to disconnect is this client right here, which is the Apple computer, like we said. So I'm gonna copy it and paste it here. And finally, I'm gonna give it the name of my wireless adapter in monitor mode, and in my case, it's called Mon0. So a very simple command. We're typing Airodump-ng. This is the name of the program that we're going to use. We're doing --deauth to tell Airodump-ng that I want to run a deauthentication attack. I'm giving it a really large number of packets so that it keeps sending the deauthentication packets to both the router and the client and keep the client disconnected. I'm using -A to specify the MAC address of the target router or the target access point. Then I'm using -C to specify the MAC address of the client. Finally, I'm giving it mon0, which is the name of my wireless adapter in monitor mode. Now you can run this command like this, and in most cases it would work. But in very rare cases, this command will fail unless Airodump-ng is running against the target network. So what I'm going to do now is I'm going to go back to my first terminal in here, and I'm going to run Airodump-ng using the command that we've seen before. And I don't want to write anything to a file, so I'm going to remove the write argument. So I'm just doing a normal Airodump-ng command. I'm literally just giving it the BSS ID of my target network, and I'm giving it the target channel. And then I'm just going to hit enter. We've seen how to do this. We spent a full lecture on it. That's why I did it really quick. And then I'm going to go back to the command that we wrote so far, and I'm going to hit enter. Now, as you can see, AirPlay-ng, it's telling me that it's sending the deauthentication packets. And if we go back here and look up, you can see that I actually lost my connection and I'm trying to connect back. So obviously, if I try to look for anything, so let's say test2, you'll see I'll get stuck and nothing will load for me. So the only way for me to connect back is if I go back here, if I quit this by doing Ctrl+C, quit this again, and now my machine should be able to connect back and restore its connection. This is actually very handy in so many ways. It's very useful in social engineering cases where you could disconnect clients from the target network and then call the user and pretend to be a person from the IT department and ask them to install a virus or a backdoor, telling them that this would fix their issue. You could also create another fake access point and get them to connect to the fake access point and then start spying on them from that access point. And we'll see how to do that later on in the course. And you can also use this to capture the handshake, which is what happened in here actually. And this is vital when it comes to WPA cracking. And we'll talk about this once we get to the WPA cracking section. So, like I said, this is a small attack that can be used as a plugin to other attacks or to make other attacks possible. Everything we've done so far can be done without the need to connect to the target network. Now, once we connect to the network, we can do so many cool things. We'll be able to gather so much more info. We'll be able to intercept the connections and see everything that the people send, whether it's usernames, passwords, URLs, or anything really. We'll also be able to modify the data, and you'll see all of this in the next section of this course. Now, if your target does not use encryption, then you can just connect to it. If your target is a wired network, then you can just use a cable and connect to it and move to the next section. The only problem is if your target is using encryption. So, in this section, I'm going to show you how to break that encryption and gain access to Wi-Fi networks, whether they use WEP, WPA, or WPA2. Once we get the key, we'll be able to connect to the network and you'll be able to do all of the things that you'll learn in the next section, in the post-connection section. The first encryption that we'll learn how to break is called WEP, or Wired Equivalent Privacy. This is an old encryption that can be easily broken. The reason why I'm still covering it in this course is, first of all, because, like I said, it's very simple, so it's a good starting point. Also, it's still used sometimes in some networks. Therefore, you can't really call yourself a hacker, and then if you see a network that uses web, you'll get stuck and you won't even be able to break into it. So, in this lecture, I'm going to explain how web works and what's the weakness that we can use to break it. And in the next lecture, you'll see how we can use this weakness in order to break web and get the key for any network that uses WEP. So basically, WEP uses an algorithm called RC4 to encrypt its data. So the way this works is basically, if a client wants to send something to the router, and let's say it wants to send this text, data to send to the router, it'll first encrypt this using a key. Therefore, this normal text will be converted into gibberish, as you can see here. This encrypted packet will be sent into the air. So if a hacker captures this packet, as we've seen before, if we open this packet, we'll see that it's full of gibberish. Even though it actually contains useful information, we won't be able to read it because it's encrypted. The access point will receive this encrypted packet and it'll be able to transform it back to its original form because it has the key. Therefore, it'll actually be able to read the contents, which is data to send to the router. The same happens if the router wants to send something back to the client. It'll first encrypt it using a key, send it to the client. The client will be able to decrypt it because it has the key. So the concept is always the same. The transmitter encrypts the data using a key, sends it to the receiver. The receiver is able to decrypt it because it also has the key. Therefore, anybody who captures the packet in the middle, they will get the packet, but they won't be able to see the contents because they do not have the key. So the algorithm and the way RC4 works is actually fine. The problem is with the way that WEP implements this algorithm. And to understand this, let's zoom in a little bit more on each step. So going back to the first step, we have the client trying to send data to the router, and the data that it wants to send is data to send to the router. So in order to encrypt this, WEP tries to generate a unique key for each packet. So literally each packet that's sent into the air, it tries to create a new unique key for it. To do that, it generates a random 24-bit initialization vector. The initialization vector is then added to the password of the network, to the actual key that people use to connect to the network. This generates a key stream, and then this key stream is used to encrypt this packet and transform it into gibberish. So basically we have the key stream plus the data that we need to encrypt, gives us the gibberish, and then the gibberish is sent into the air. But before sending this into the air, WEP will also append the initialization vector. This is the 24-bit random number that I said it creates in order to make sure that each packet has a unique key. The reason why it adds the initialization vector to the packet is because once the router receives this packet, it needs to be able to decrypt it. And to decrypt it, it needs the key and the IV. But the router already has the key, so there is no need to send that. Therefore, we just need to send it the IV. So, when the router receives the packet, it has the IV, it has the password or the key, so it can generate a key stream and then use that key stream to transform this gibberish into its original form and read the packet. So, if you think about what I said, you can probably guess what the weakness is. Basically, the IV is sent in plain text. So if you look at this, you can see the packet content is encrypted. So if someone captures this packet, they won't be able to read this, but they will be able to read the IV in plain text. Also, the size of the IV is only 24 bits. Now, considering the huge amount of traffic that can be generated on a Wi-Fi network, this number is not big enough, and the IVs will start getting repeated in a busy network. This makes WEP vulnerable to statistical attacks, so we can use a tool called AirCrackNG to determine the key stream once we have enough repeated IVs, and from that it will also be able to crack WEP and give us the key to the network. So from the previous lecture, we know in order to crack WEP, we need to first capture a large number of packets. This means that we'll capture a large number of IVs. The IVs, because they are short, they will be repeated. Therefore, we'll be able to use a tool called Airodump-ng to run statistical attacks and crack the web key. So we're using Airodump-ng to capture the data, and we've seen how to do this before. Then we're using Airodump-ng to analyze this data and break the key. Let's see how to do this in practice. So I already have my wireless adapter in monitor mode, and it's called Mon0. I've also already run Airodump-ng to list all the networks around me. And as you can see, I have only one network using WEP. This is called test AP3. And this is my actual network that I use every day. I've just configured it to use web to make this lecture. The main reason why I'm targeting the network that I use daily, because like I said, for this to work, we need to capture a large number of packets. And therefore, we need a busy network, a network that gets used constantly to capture a large number of packets. If the network is idle, then the process is a little bit complex, and I will cover that in the next lecture. So for now, let's focus on the simplest form, which is how to break into a busy network. So I'm going to copy the BSS ID of this network, and I'm going to run Airodump-ng against this network only. So I showed you how to do this before. I'm going to do Airodump-ng. I'm going to do --BSS ID to specify the BSS ID of the network. Then I'm going to do --channel to specify the channel of the network, and we can see it's running on number 1. And I'm going to do --write to store everything that we capture into a file, and let's call this file basic web. And then I'm going to specify my wireless adapter in monitor mode, which is Mon0. So we ran this command before in the targeted sniffing lecture. All we're doing is we're running Airodump-ng against a specific network with this MAC address, with this channel, and we're storing everything in a file called basic web. I'm going to hit enter, and as you can see, Airodump-ng is working against my target network. And if you notice, you'll see the data in here is increasing really fast. So this is something that I told you I'll talk about it later when we were talking about Airodump-ng, because I didn't want to talk about IVs at that early stage. So basically what you see under the data column is the number of useful packets that contain a different IV that we can use in order to crack the key. So the higher this number is, the more likely we will be able to crack the key. As you can see, this number is increasing very fast because, like I said, this is a busy network that is being used at the moment by my own computers and my own devices. If yours isn't increasing fast, then don't worry, we will tackle this problem in the next lectures. So for now, we're capturing a lot of data, and this should actually be enough to crack the key. So what I'm going to do, I'm going to go down to my other terminal in here, and if we actually list the files, you'll see that we have the capture file that we specified in the right argument. And like I said, we're always interested in the .cap file. So all we have to do right now is do step 2 in here, run Airodump-ng against the file that we captured in order to crack the key. So I'm going to do Airodump-ng, followed by the file name, which is basicweb01.cap. I'm going to hit enter. And as you can see, it's telling us that the key is found. So let me cancel this here. And right now, we can connect to the target network, which is called test AP3, using this ASCII password. So you can literally just copy this and paste it, or you can connect using this key. Now, in some cases, you will not see this ASCII password. That's why I'm going to show you how to connect using this key right here, because you'll always get this. So I'm going to copy this, and I'm just going to paste it here. You can paste it anywhere in a normal text editor or anywhere you want. And all you have to do is remove the columns that we see in here between the numbers. So I'm going to remove this one, going to remove this one, and this. And now we can just copy this. And just to show you, I'm actually going to connect from my host machine. You can connect from Kali, but when we enabled monitor mode, we killed a lot of processes, and sometimes even after you restart these processes, getting connected to your target will be a little bit buggy. So it's best to literally just restart Kali and connect again. So just to save all of this time, I'm going to connect from here. I'm just going to click here. I'm going to connect to test AP3, and I'm going to paste the password. So I'm just going to click on show the password to show it to you. Again, the same password, we just removed the colons. I'm going to click on join. And as you can see, we managed to connect, and we can test this connection by going to Google. And perfect. As you can see, it's working, and we managed to break the WEP encryption. In the previous lecture, we've seen how easy it is to crack WEP. All we had to do is capture enough data and then run aircrack-ng to crack the encryption and give me the key. Now, one problem that we could face is if the network is not busy. If it's not busy, then the number of data will be increasing very, very slowly. Therefore, we're going to have to wait for a while before we have enough data to crack the key. So let me show you an example. I'm just going to run Airodump-ng here and list all the networks around me. And you can see I have my test network, my test AP in here. It's using web. And if you look under the data, you'll see that it's at 0 and it's not increasing. And even if it's going to increase very, very slowly. Which means that I'm going to have to be waiting for hours before I can crack this network. So a solution to this is to force the AP to generate new packets with new IVs. Now, before doing this, we need to associate with this network. So what I mean by associate is we need to tell this network that we want to communicate with it, because by default, access points ignore any requests they get unless the device has connected to this network or associated with it. So don't get this mixed up with connecting. We're still unable to connect to the network because we need the password to be able to connect to the network. But what we're doing right now is literally just telling the target network, look, I want to communicate with you. Don't ignore my requests. That's all we're doing. So it's something similar to what happens when you just click on the network when you want to connect to it. You still haven't put the password, you're just telling the target network, I want to communicate with you, please don't ignore me. So in this lecture, I'm going to show you how to associate with the target network so we can communicate with it. And in the next lecture, I'm going to show you how once associated, we can inject packets into the network and force the number of data to increase very, very quickly. First, I'm going to run Airodump-ng against my target network, which has this BSSID. So I'm going to copy it. And we're going to use the exact same command that we've been using so far. So we're going to do Airodump-ng --BSSID, followed by the MAC address of my target, --channel, followed by the channel which my target is running on, which is 6. And we're going to store all of this, so we're going to do --write, and we'll call this file ARP replay because that's the name of the attack. And then I'm going to put my wireless adapter in monitor mode, which is mon0. So a very simple command that we've done before. We're using Airodump-ng to capture data from a network with this MAC address running on this channel. We're storing everything in a file called ARP replay. I'm gonna hit enter, and as you can see, it's running against my target. And notice the data is increasing really, really slow, or it's actually not increasing at all right now. Now, to associate with this network, we're going to use a program called AirReplayNG. So we're going to type -ng followed by -- fake auth because we want to do a fake authentication attack. We're going to put 0 because we only want to do this once. We're going to do -a to specify the MAC address of the target network. So I'm going to paste it. I've already copied it. Then we're going to do -h to specify the MAC address of my wireless adapter. And to get the MAC address of my wireless adapter, I'm going to do ifconfig. And it's the first 12 digits of the unspec field. Usually, you'd see it after the ether, but when you enable monitor mode, it'll show up like so. So I'm going to copy this, and I'm going to paste it here. And I'm going to replace the minuses with colons. And that's it. It's done. And finally, I'm just going to give the name of my wireless adapter in monitor mode. So a very simple command. We're using Airodump-ng, which is a tool that can be used to run a number of attacks. And we've seen using this with the deauthentication attack. We're telling it that we want to run a fake authentication attack. We want to do this once. We're giving it the MAC address of my target network after the A. Then I'm giving it the MAC address of my wireless adapter after the H. And finally, I'm giving it my wireless adapter in monitor mode. Now, before I run this, notice in here under the auth, we have nothing. And we don't have any clients showing up in here at the bottom. Now, if I hit enter, you can see under the auth, it's showing up as open. And you can see we have a new client here associated with the network. If you look in here, you'll see this is the MAC address of my target network. And right here is the MAC address of my wireless adapter. So right now I am associated with the target network, and if I send it anything, it's going to accept it and it's going to communicate with me. Again, I am not connected to the network. I still can't use the internet. I'm literally just associated with the network so I can communicate with it. Now, in the next lecture, I'm going to show you how we can communicate with this network in a way to force it into generating new packets with new IVs, which will allow us to crack the key very, very quickly. Now that we have associated with our target network, we can start communicating with it and it won't ignore us. So now we can go and start injecting packets into the traffic to force the access point to generate new packets with new IVs. This will increase the number of data really, really quickly, allowing us to crack WEP networks in minutes, even if the network was not busy like the one that we are targeting right now. Now, there are a number of ways to do this, but in this course, I'm going to explain the most reliable method, which is using an ARP request replay attack. I actually explain other methods in my network hacking course, but they are a little bit more complex and have less success rate. So this is the most reliable method, and it should work against most networks if you have a good signal and a good wireless adapter. So the idea behind this method is to wait for an ARP packet, and I'll talk about ARP in more details later on. So for now, just think of it as a special type of a packet that we're going to be waiting on. Once this packet is sent in the network, we're going to capture it and retransmit it. Once we do this, the router is forced to generate a new packet with a new IV. So, by repeating this process, we will be forcing the router to continuously generate new packets with new IVs. Then, once we have enough data, once we have enough IVs, we can run Airodump-ng exactly as we've seen before and crack the key. So let me show you how to do this in practice. Now, as you can see, I'm already running Airodump-ng against my target network, and I have already associated with it as shown in the previous lecture. So the only thing that's left right now is to run the ARP replay attack in order to inject packets into the traffic and force the router to generate new packets and increase the number of data. To do that, we're going to use Airodump-ng again, and the command is actually going to be very similar to this command right here. So I'm actually going to copy all of this because I'm lazy, and I'm going to clear this and paste the command here. Now, there are only a few things that I need to modify. First of all, I don't want to run a fake authentication attack, so I'm going to remove all of this. And I want to run an ARP replay attack. Also, this attack does not take a number, so I'm going to remove this number. And I'm also going to replace the A with a B. And we're done. So, if you look at it, you'll see it's actually very similar to this command right here. We're using Airodump-ng, but instead of doing a fake authentication attack, we're doing an ARP replay attack. We're giving it the MAC address of my target network after the B instead of the A. Then we're giving it the MAC address of my wireless adapter after the H, which is identical to this. And then we're giving it my wireless adapter in monitor mode. Now, I'm actually going to associate again before I do that. And then I'm going to hit enter here. And what's happening right now is my wireless adapter is waiting for an ARP packet. Once there is an ARP packet transmitted in this network, it's going to capture it and it's going to retransmit it. Once it does that, the access point will be forced to generate a new packet with a new IV, and we'll keep doing this, forcing the access point to continually generate new packets with new IVs. So you should just wait for it right now. We're literally just waiting for an ARP packet to be sent in the air. And as you can see, the number of data is increasing now very, very quickly, which means that we actually managed to capture an ARP packet. This ARP packet got retransmitted, forced the router to generate a new packet with a new IV, and we are continually doing this process, forcing the router to generate new packets with new IVs. So right now we can go ahead and run Airodump-ng to crack this network. And before I do that, I'll actually just associate one more time. And then I'm going to do Airodump-ng and give it the name of the file which we're storing the data in, which is called arpreplay01.cap. So I'm going to hit enter. And you'll notice the cracking process right now will actually require more data packets. The reason for this is I've actually modified the settings of this network so that it uses a 128-bit key, because in web you can either use a 64-bit or 128-bit key. And obviously the 128 key is longer. Therefore, I actually modified the key length for this lecture to make sure it's the longest key possible. And as you can see, we still managed to get it within about 47,000 packets. We have the key right here in ASCII, and we have the key in here in hex, where we can use after we remove the colons. So perfect, now we managed to crack the target network. It was idle, as you could see, there was no data being sent, and we managed to do this by forcing the target access point to generate new packets with new IVs.
Another method of increasing the number of data rapidly in a network that has no clients associated with it, or if it has very low traffic, is cork chop chop attack. In this method, instead of directly injecting the ARP packet that we capture, we're going to try to determine the key stream for this packet. Once we do that, then we can create a new packet. So we're going to forge a new packet and inject this new packet into the traffic. This will force the access point to create a new packet with a new IV. We're going to capture it and inject it back into the traffic. We'll keep doing this until the number of data is high enough to crack the web key. So, the start of the attack is going to be very similar to the one in the previous video. The first thing we're going to do is launch Airodump against the target network. So I'm just going to call this chop chop test. And here we go. We have our target network here. The second attack that we're going to try to do is the fake authentication attack. Again, we do this so that the target doesn't ignore us. And as you can see, we're successfully associated with the target network. Now, the third attack is going to be our cork chop attack, in which we're going to try to capture a packet and determine its key stream. It's going to be very similar to the fake authentication attack. Just going to paste that here. So instead of having fake auth, it's just going to be chop. And then instead of A, we're going to have V for BSS ID. So Airodump-ng, chop, the MAC address of the target network, and then my own MAC address, and then the name of the Wi-Fi card with monitor mode. We can get my own MAC address from ifconfig LAN 0, and then my MAC address will show up like this. So I'll just do another association with the target network. And then I'm gonna do my chop attack. Now, Airodump-ng is just waiting for a packet. Once it captures that packet, it's gonna ask me, do I want to decrypt it and determine its key stream or not? So we're just gonna wait for it. I'm gonna say yes, please. And now it's working to try and determine the key stream for the target access point. Okay, now I've resumed the video. Just want to show you that we've only reached 86%, but we can still actually use this key stream. It might work, it might not work, but we can still try. And sometimes I remember I had like 64%, and I still was able to forge a packet and inject it, and successfully inject it into the traffic. So let's try this. Now the key stream is saved into this file. So now the next step is to forge a fake packet. We're gonna do this using packet forge. We're gonna put -0 so that it creates an ARP packet for us. The MAC address of the target network and my own MAC address, same as this, A and H. So I'm just gonna copy and paste them. Here we go. Then we're gonna put destination IP, and we're just gonna set it to 255. And then we're gonna set the source, and it's gonna be 255 again. That's just information that has to be there in the packet. And then we're gonna use the option Y to specify the name of the keystream file, and it's this file, as you can see, file that was created in the previous step. So we're gonna paste that, and then the name of the forged packet. So what do we want it to be called? So I'm gonna call it chop forged packet, and that should be in the W option. Sorry, so that's the option. So let's just go again over the command. It's packet forge ng -0 to make an ARP packet, the MAC address of the target network, the MAC address of my Wi-Fi card, then we put the destination IP, source IP, and then we put the file that we created in the previous step, and the name of the forged packet that's going to be created. Now the next step is where we're going to inject this forged packet into the traffic and to cause the number of data to increase rapidly. So I'm just going to go to fake authenticate myself again, just in here, and then I'm just going to clear this Airodump-ng to inject our fake packet into the target network. So -2 for the reply attack, and then R to choose the fake packet, and then we put the name of our Wi-Fi card. So -2 for replay, or the name of our packet, the first packet, and -0. So I'm just gonna associate myself again, and I'm gonna hit enter here. It's gonna ask me, do I want to use this packet? I'm gonna say yes. And here we go. You can see the number of data increasing very, very quickly. Again, I only had 86% of the key stream. I wasn't able to decrypt the whole key stream, but the attack is still successful. That's why I've had good luck with this attack with networks that are far away, or with stubborn networks that the first method didn't work against. So all we have to do now is just wait for the data to reach around 20,000 and fire up aircrack-ng again, as we did in the previous two videos, and it's gonna work. It's gonna get us the key straight away. I'm just gonna do it here. I can do that here. Let's just clear that. And the name of the file is chop, I think. So it's chop test 01. Yeah. And here we go. As you can see, we got the key with 23,000 IVs. Basically, just I'm gonna go again through the steps of this method. So we capture the packet, we try to determine its key stream. We only determined 86%. We used that 86 to create a fake packet, and then we injected that fake packet into the air. The third injection method that we're going to talk about is the fragmentation attack. The fragmentation attack is very similar to the previous one, but in this attack we have to obtain 1,500 bytes of the PRGA, the pseudo random generation algorithm. Because we need to order the full 1,500 bytes, this attack is, we need to be closer to the target network to successfully run this attack, but it's much quicker than the correct chop attack. So again, after we obtain the PRGA, we can use it to forge a new packet, and then we're going to inject this new forged packet into the traffic to increase the number of IVs very quickly. So the concept is very simple. We're gonna capture a packet, determine its PRGA, forge a new packet, and then inject that packet into the air. So let's see how we can do this. Again, first thing is going to be running Airodump against the target network. So I'm just gonna change the name here from chop to fragmentation. We're just gonna call it fragment. Hit enter, and here we go. Airodump is launched on our target network. Second step, as always, is fake authentication, so that the access point doesn't ignore us and starts communicating with us. So we do that, and we see here we have successfully associated with the target network, and the authentication has changed to open, so that's very good. Third step is going to be our fragmentation attack step. It's very similar to the chop attack. So you can see here, that's my chop code that I used, the chop command, sorry. So it's exactly the same command, just instead of chop I'm gonna say fragment. So it's airplay-ng fragment, B, the target address of my target network, and then H, the MAC address of my own network. Of my own Wi-Fi card. So I'm just gonna associate myself again and do the fragmentation attack. So it's waiting for a packet now. Once it captures that packet, it's gonna try to determine its PRGA. And here we go. We got a packet. So it's asking me, do I want to use this? I'm gonna say yes, please. Now it's trying to determine the PRGA. So that packet wasn't useful. It's just waiting for another packet to use. It's asking me, do I want to use this? I'm gonna say yes again. Again, that packet wasn't useful, so we're just waiting for another useful packet. I'm gonna reassociate myself in the meanwhile, and I'm gonna say yes. Okay, now this time this packet was useful, and the key stream is saved to this file. Okay, now we're just gonna need to, again, the same as we did in Chop Chop, we're gonna use this key stream to create a first packet. So I'm just gonna copy its name, and I'm gonna use the same command. I'm just gonna clear this for you. And I'm gonna use the same command that we used with the Chop Chop attack. The only difference is I'm gonna remove the Y, and I'm gonna put the name of the new key stream that we captured, and the name of the packet that we're gonna create, I'm gonna call it fragment first packet. So we're just gonna go over the command again. It's packet forge -0 to create an ARP packet. A, we put the target MAC address, H is my own MAC address, and then K and L are the destination and the source IP addresses. Y is the name of the key stream file, so it's the file that has been created from the previous step, and that's the name of it. And then W is the file name that's going to be created, that's going to contain the first packet, and it's going to be called fragment first packet. And it's telling us that it's been successfully written to this file. So again, just like the Chop Chop attack, we're going to inject this new packet into the air, and this is going to be done using AirPlay-ng with the -2 option, the reply option. Just going to paste the name of my new first packet. So we got AirPlay-ng -2 for the replay, or the name of my first packet, and 10 is my Wi-Fi card with monitor mode. Before I do this, I'm gonna associate myself again, and then I'm gonna hit enter here. It's asking me, do I want to use this packet? I'm gonna say yes. And here we go, we can see the data is flying. We're injecting around 400 packets per second, and once this number is large enough, we're going to be able to crack the key. I can just go here to aircrack-ng. So it's going to be aircrack-ng fragment test .cap. And here we go, we can see the key, that's the web key, and we have 30,000 IVs. So if we go back here, it's probably even more, it's 35,000, and the numbers are increasing quickly. So that was the 3 methods to inject packets into the air. There is more methods, but that's in my opinion the best 3 methods to increase the number of data into idle networks. This way we're able to crack any web encrypted network.
In the previous lectures, we've seen how to crack the WEP encryption in minutes, even if the target network is not busy. Now, in the next lectures, we will talk about cracking WPA and WPA2. First of all, before we start talking about how to crack these encryptions, it is very important to understand that both of them are very similar. The only difference between them is the encryption used to ensure message integrity. WPA uses TKIP and WPA2 uses an encryption called CCMP. In any case, this does not affect the methods that we're going to use to crack WPA and WPA2. Therefore, all of the methods that I'm going to show you from now on will work on both WPA and WPA2. Now, both of these encryptions came after WEP, and they were designed to address the weaknesses in it. Therefore, both of them are much more secure, and cracking them is more challenging. So, before we start talking about how to crack them, I want to cover a feature that, if enabled and misconfigured, can be exploited to recover the key without having to crack the actual encryption. The feature is called WPS. It allows devices to connect to the network easily without having to enter the key for the network. So it was designed to simplify the process of connecting printers and such devices. You can actually see a WPS button on most wireless enabled printers. If this button is pressed and then you press the WPS button on the router, you'll notice that the printer will connect to the router without you having to enter the key. This way, the authentication is done using an 8-digit PIN. So you can think of this as a password made up of only numbers, and the length of this password is only 8. So this actually gives us a relatively small list of possible passwords, and we can try all of these possible passwords within a relatively short time. Once we get this PIN, it can be used to recover the actual WPA or WPA2 key. So as you can see, with this method, we are not exploiting WPA or WPA2. We are actually exploiting a feature that can be enabled on these encryptions. So for this to work, first of all, we need WPS to be enabled on the network because it can be disabled. Also, it needs to be misconfigured, so it needs to be configured to use a normal PIN authentication and not a push button authentication. If push button authentication is used, then the router will refuse any pins that we try unless the WPS button is pressed on the router. Therefore, the method will not work if push button or PBC is enabled. So in most modern routers, PBC comes enabled by default or WPS will be disabled by default, so this method might not work. But because WPA and WPA2 are so secure and so challenging, it is always a good idea to check if WPS is enabled and try the method that I'm going to show you to crack the network. If it fails, then you can try the other methods that I'm going to show you after the next lecture. Okay, now that we know what WPS is and how it can be used to recover the password for WPA and WPA2 networks, let's see how to do that in practice. So, right here I have my Kali machine. I've already enabled monitor mode on my wireless adapter on Mon 0. Now usually we use Airodump-ng to see all the networks around us. But right now we want to see the networks that have WPS enabled, but because like I said, it's just a feature and people can turn this feature off. So first of all, I'm going to use a tool called Wash to display all the networks around me that have WPS enabled. So we're going to do wash --interface and give it my interface in monitor mode, which is Mon 0. So all we're doing is wash is the name of the tool, interface to give it the interface, and Mon 0 is my wireless adapter in monitor mode. If I hit enter now, you'll see it'll list my network straight away. Now I pressed Ctrl C to cancel this, similar to Airodump-ng, because it'll keep running unless you cancel it. And you can see this is my target network. It's called test AP. It's giving us the vendor of the hardware used in this network, in this access point. The LCK tell us whether WPS is locked or not, because sometimes WPS locks after a number of failed attempts. So right now this says no, which means that we can actually go ahead and try to guess the pin. It's giving us the version of WPS. It's using version 1. The signal strength is in here, the channel, and the BSS ID. Now I explained the meaning of all of these things before in my Airodump-ng lecture, so I'm not going to talk about them now. If you forgot the meaning of any of these terms, please go back to the Airodump-ng lecture. Now this network actually uses WPA2, so just to confirm this to you, if I go here to my host machine and just try to connect to it, you'll see that it's telling me that this uses a WPA2 password. But like I said, we don't care if it's WPA or WPA2 because we're going to be exploiting a feature in these encryptions, which is the WPS feature. So now that we know our target network uses WPS, there is a good chance that this attack will work against it. The only reason it might fail is if the target uses PBC or push button authentication. Like I said, if the target uses PBC, then it will refuse all the pins unless the button is pressed on the router, and therefore this attack will fail. The only way to know is to literally try this attack and see if it works. So I'm going to copy the MAC address of this network or the BSS ID. And the first thing that I'm going to do, similar to what we did with WEP, I'm going to associate with the target network using a fake authentication attack. So basically I'll be saying, I want to communicate with you, please don't ignore me, so that when I run the attack, the network will start accepting the pins and not ignore me. So to associate, we're going to use the exact same command that we used when we did it with WEP. So we're going to use AReplay-ng. We're going to tell it I want to run a fake authentication attack. We're going to give it the delay. So this is the time to wait between association attempts. Previously we set it to 0 and we had to do this manually every now and then. Right now I'm going to set it to 30 so that we associate with the target network every 30 seconds. Then I'm going to do -A to give it the MAC address of my target, and -H to give it the MAC address of my wireless adapter in monitor mode, and we've seen that we can get this by doing ifconfig and copy it from here. We said it's the first 12 digits, and I'll just replace the minus with the colon. And finally, I'm going to give it the name of my wireless adapter in monitor mode, which is mon0. So I explained this in details before. That's why I did it quickly. If you don't remember how I did this, please go back to the fake authentication attack lecture. So I'm going to hit enter, and that's working there, and it'll continue working, like I said, associating with the target network every 30 seconds. So I'm going to leave that running in this terminal, and I'm going to move to this one right here. I'm going to clear the screen, and we're going to run Reaver, which is the program that's going to brute force the pin. So it's going to try every possible pin until it gets the right pin. Once it has the right pin, it'll use it to compute the actual WPA key. So using Reaver is very, very simple. It's very similar to everything we've been doing so far. So first of all, we have to type the program name, which is Reaver. Then I'm going to do --BSSID to give it the MAC address of my target network. And I'm going to scroll up in here and just copy it and paste it here. Then I'm going to do --channel and give it the channel of the target network, which is 1. Then we're going to do --interface and give it my wireless adapter in monitor mode, which is mon0. So a very, very simple command. We're using Reaver. This is the name of the program that will do the brute forcing for us and give us the key. We're giving it the BSS ID, the MAC address of my target. We're doing --channel to give it the channel that my target is running on. And we're doing --interface to give it the name of my wireless adapter in monitor mode. I'm also going to add 2 more options. I'm going to add -VVV to show us as much information as possible. This is really helpful. If it fails or things go wrong, we'll be able to know what's happening, why things are going wrong. And I'm also going to do --no associate to tell Reaver not to associate with the target network because we're already manually doing that in here. So Reaver can automatically do this step right here for you, but I've seen that it fails a lot. Therefore, it's actually better to do it ourselves manually here and then tell Reaver not to associate. So now I'm going to hit enter to get Reaver to work. And as you can see, right now I'm getting an error. And this is actually a bug with the latest versions of Reaver. So if you get this bug, this means they still haven't fixed it in the latest version. So it's better to go back and use an older version. I'm going to include an older version that works perfectly in the resources of this lecture, so you can access it from the top left of the lecture. If you tried Reaver and got this error right here, then go ahead and download this older version. Right now I already have it in my downloads right here, so you can see I'm in home downloads, and I have it right here called Reaver. So what I'm going to do is I'm going to clear this again, and I'm going to navigate to my downloads, so CD downloads. I'm going to list, and you can see we have it right here. Now it's already in green for me, but for you, you'd want to change the permissions of this file to an executable. So you'll have to do chmod +x Reaver. This will make it an executable. Once it is an executable, you can run it by doing // followed by its name, so Reaver. Then you can do the exact same command exactly like I just did it with the one that comes pre-installed in Kali. So I'm actually just going to go back to what I had, and I'm just going to go to the start of the command and put // So when we put the // we're basically running the file that is in the current working directory. We're running this. We're not running the normal Reaver file that is pre-installed in Kali. Then we're using all of the options exactly the same way that we were using it with the built-in one. I'm going to hit enter. And as you can see right now, Reaver is trying the pin 1, 2, 3, 4, 5, 6, 7. And perfect. You can see the pin was actually 1, 2, 3, 4, 5, 6, 7, 0. So it's a simple pin. It actually came with this pin, so I didn't manually set this pin. My router came from the factory with WPS enabled with this pin. So like I said, this still works, but again, not against all routers. From that, it was able to discover the WPA key, which is UAU RWSXR, and the name of the router is test-AP. So I can literally go ahead and connect with this password, and I'll be able to connect to the network and see and decrypt all of the packets sent in the air. Now, if WPS is disabled on your target network, or if it's enabled but configured to use push button or PBC, then the method that I showed you in the previous lecture will not work. Therefore, you will have to go and crack the actual WPA or WPA2 encryption. And like I said, when these encryptions were designed, the developers knew about the weaknesses in WEP, and they made sure that they properly fixed these weaknesses. They actually did a pretty good job at this. Therefore, we cannot use the same method used in WEP to crack WPA and WPA2. So in WPA2, the keys are unique, they're temporary, they're much longer than what they were in WEP. Therefore, the packets sent in the air contain no information that is useful for us. So it doesn't matter, even if we capture 1 million packets, we can't use them to crack the key. The only packets that contain useful information are the handshake packets. These are 4 packets transferred between a client and the router when the client connects to the network. So in this lecture, I'm going to show you how to capture these packets, and in the next lectures, we'll see how to use them to crack the WPA or WPA2 key. First of all, as usual, you'd want to run Airodump-ng against all the networks around you. I've already done that, and as you can see, this is my target right here. It's using WPA2, and this is the MAC address. I'm going to copy it. And the first thing we'll do is just run Airodump-ng on this network and store the data in a file, exactly the same way that we used to do it with WEP. So we're just going to do Airodump-ng --BSSID and give it the BSSID of my target, --channel, and give it the channel of my target, which is 1 -- right, to specify a file name to store all the data that we're going to capture in. And let's call this WPA handshake, because we're going to capture the handshake. And finally, we're going to give it my wireless adapter in monitor mode, which is mon0. So very simple command. We've done this multiple times by now. We're using Airodump-ng. We're giving it the MAC address of my target after the BSS ID. I'm giving it -- channel to specify the channel of my target. I'm using -- right to store all the data in a file. This file will contain everything that we capture. So if we capture the handshake, it will be in this file. And finally, I'm giving it the name of my wireless adapter in monitor mode. So now I'm gonna hit enter. And as you can see, Airodump-ng is working against my target network. And right now, all we have to do is literally sit down and wait for the handshake to be captured. Like I said, the handshake is sent when a client connects to the network. So we'll literally have to sit down and wait until a new client connects to the network. Once a new client connects, we will capture the handshake, and you will see in here, Airodump telling us that the handshake has been captured. Alternatively, we can use something that we learned before, which is a deauthentication attack. We know using that attack, we can disconnect a client from the network. So we can do this for a very short period of time. We can disconnect this client from the network. He will automatically connect once we stop the attack. Therefore, when he automatically connects, the handshake will be sent in the air and we will be able to capture it. This way, we will not have to sit down and wait for someone to voluntarily connect to the network. So we've seen how to do this before, and it's going to be exactly the same command as we did it before. We used areplay-ng, we did --deauth, then we specified a really large number of packets to keep the client disconnected for a long period of time. This time I'm going to set this to 4 to only send 4 deauthentication packets. This way, my client will be disconnected for a very short period of time. They won't even feel that they got disconnected, but this is enough for the handshake to be sent because they will be disconnected, they will automatically connect, and when they do that, we will capture the handshake. Now, the next argument we want to set is the MAC address of my target. So we're going to do -a followed by the MAC address of my target. Then we're going to do -c followed by the MAC address of the client that we want to disconnect. So it's this client right here. I'm going to copy, paste it here, and finally we're going to give it the name of my wireless adapter in monitor mode, which is mon0. And we are done. Again, I've spent a full lecture on this command explaining what a deauthentication attack is, so if it's a bit confusing, please go back and revise that lecture. Basically, all we're doing is we're using areplay-ng to run a deauthentication attack to disconnect this device for a very short period of time. That's why I'm setting this to only number 4. Then I'm using -a to specify the MAC address of my target, -c to specify the MAC address of the client connected to this network, and then I'm giving it my wireless adapter in monitor mode. Now I'm going to hit enter and keep an eye on this side right here. You'll see the handshake will be captured in here. So we're going to hit enter. The authentication packets are being sent. And perfect. As you can see, once the client connected again, we received the handshake. So now we can quit Airodump-ng, so Control-C, because we have the handshake now. It is stored in the file that we set after the right option, which is called WPA handshake. And in the next lecture, I'll show you how this handshake can be used to get the key for the network. From the previous lectures, we learned that when it comes to WPA and WPA2, the only packets that contain some information that can help us with cracking the key are the handshake packets. And in the last lecture, we learned how to capture the handshake and store it in a file. Now, the handshake does not contain any information that can help us to recover or recalculate the WPA key. The information in it can only be used to check whether a password is valid or not. Therefore, what we're going to do is to create a word list, which is basically a big text file that contains a large number of passwords. Then go through this file, go through the passwords one by one, and use them with the handshake in order to check whether this password is valid or not. You can actually download ready word lists from the internet, but in this lecture, I want to teach you how to create your own word list, and in the next lecture, I'm going to explain to you how the word list and the handshake are used in order to recover the password, and we'll see how to do that in practice. So in this lecture, we're going to learn how you create your own word list using a tool called Crunch. This is a really handy skill to have under your belt if you want to be a penetration tester, because you're going to face a lot of scenarios where a word list attack can become very handy. So using the tool is very simple. All you have to do is just put the name of the tool, and then you specify the minimum number of characters for the passwords to be generated. Then we're going to specify the maximum number of characters for the password. Then you specify the characters that you want to generate passwords from. For example, you can put all lowercase characters, all uppercase, you can put numbers, digits, or you can just specify a smaller number to make the word list smaller. You can also use the option T, which is an optional, to give a pattern. So for example, let's say that you were looking at the person while they were typing their password, and you've seen that the password will start with an A. So you can tell Crunch that the password will start with an A, and then give me all possible combination of passwords that start with an A. And after that, we use the -O option to specify the file name where the passwords are going to be stored. So we have a small little example here that will generate a list of passwords that start from 6 characters to 8 characters. And contain these characters right here. So it's going to create combinations of 1, 2, 3, ABC, and the $sign. And it's going to store it in a file called word list. And these passwords are going to start with an A and end with a B. And it will generate passwords based on all possible combinations between the A and the B. So all of the generated passwords will always start with A and end with B. So let's have an example of the tool. Now the tool actually have a lot of options other than what we've seen so far. So if you just type in man crunch, you'll see all the options that you can set, and you'll see detailed description about all of these options. So it's actually really good. You can go ahead and spend some time to get familiar with the tool. Now I'm going to show you the example, and based on the example, you'll be able to run all of these commands. But if you want to run or create some advanced word lists, then I highly recommend that you go over this. One of the really cool options that I want to highlight is the -P option. The -P option tells Crunch to generate passwords that don't have repeating characters. For example, when you specify all lowercase characters, you specify A, B, C, D, it will start by generating passwords made of A, and then A, B, and all of that. So when you do this, Crunch will actually ignore these type of passwords, and it will only create passwords that don't have any repeating characters. And that will reduce the size of the word list from the number of characters to the power of the length to the number of characters factorial. If you scroll down, you'll actually see more examples of commands and the type of word lists that will be created. So again, you can have a look on these and get yourself familiar with. Once you're done looking at the man, you can just press Q and you'll be out of it. And we're gonna run our command here. So we're gonna use Crunch. And I want to generate passwords of minimum of 6 characters and maximum of 8 characters. And I want them to contain combinations of A, B, C. And let's say the digits 1, 2. Now in here you can actually keep listing things. You can list characters, you can list uppercase characters, or even symbols if you wanted to.
Once you're done with listing the characters, we're going to specify the file to save it to, and we're going to save it in a file called test.txt. So the command is very simple. It's crunch minimum length of the password, the maximum length of the password, followed by the characters that we want to use to generate passwords from, and then O to the file that the passwords are going to be stored in. I'm going to hit enter. And as you can see now, it's telling us that it generated 448,000 passwords approximately, and they're all stored in a file called test.txt now. The size of the file is 4 megabytes. And now I can open this file by doing cat test.txt. And as you can see now, we can see all the passwords that have been generated. I'm going to Control-C out of it because it's a huge file. And as you can see, it actually contains all possible combinations of ABC12. I also want to show you an example of using the -t option. So I'm going to set this to only 6 to 6, so it's only 6 characters. And we're going to use the -t option, which is the pattern option. And I'm going to tell it that I want the password to always start with an A. And then I want you to fill all possible combinations of characters between the A and the B. So I want passwords that start with an A and end with a B. And in the middle, at the @ sign, you can fill all possible combinations of ABC12. Gonna hit enter. As you can see now, the number of passwords is much less. It's only 625 passwords because I've narrowed down the possibilities of passwords. Again, if I do cat test.txt, you'll see that I have all the passwords right here. So this is it. Tool is really useful, can be used in many scenarios. I highly recommend that you spend some time with it, and also have a look on some of the existing word lists out there on the internet. Now, from the previous lectures, we learned in order to crack WPA or WPA2, we need to first capture the handshake, and second, have a word list which contains a number of passwords that we're going to try, and hopefully one of them will be the password for the target network. So right now I have both of these components, and we are ready to go and crack the password. To do this, aircrack-ng is going to unpack the handshake and extract the useful information. The MIC right here, or the message integrity code, is what's used by the access point to verify whether a password is correct or not. So it's going to separate this and put it to the side, and then it's going to use all of the other information right here combined with the first password from the word list to generate an MIC, another message integrity code. And then it's going to compare this MIC to the one that's already in the handshake. If the MIC generated using this information plus the first password is the same, then the password used to generate this MIC is the password for the network. Otherwise, this password is wrong and it'll move to the next password. Again, it'll do the same. It'll use all of this information combined with this password, generate a new MIC, compare this new MIC to the one that's already in the handshake. If it's correct, then this is the password. If it's not, then it's going to move on to the next password. And it'll keep doing this through all of the passwords in my word list. If any of them generates the right MIC, then this is the password for the network. Otherwise, we won't be able to get the password. That's why the success of this attack really depends on your word list. So, let's see how to do this in practice. Right now, I have my word list right here. It's called test.txt. And I've actually manually added my password to the end of the list right here, just so that when I run the word list against the handshake, I will actually find the password, because the word list did not contain my password by default. I also have the handshake file right here, as you can see, and all of this is in my home directory, which is my root directory.
So if I do ls in here, you'll see I have the word list and the handshake file. So we're ready to run aircrack-ng. So we're going to type the name of the program as usual, followed by the name of my capture file, which is wpa handshake01.cap. So far it's identical to the way that we used to use it with WEP. The only difference right now, because this is a WPA2 network, we have to specify a word list with the -w option. And the name of my word list is test.txt. So very simple. Aircrack is the name of my program. WPA handshake01.cap is the name of the file that contained my handshake. And I'm using -w to specify my word list file. I'm gonna hit enter. And as you can see now, aircrack-ng is running through the word list, testing each word in the word list one by one, as shown in this diagram, calculating an MIC based on this information and the word list, and then if the MIC is correct, it's going to tell me that this is the password. Now, the speed of this depends on your processor and the size of your word list file. So if you have a huge file, obviously it will take you longer time. There are also online services that you can try where you upload the handshake, and they have huge word lists and they have supercomputers to run through these word lists and try to give you the password. Unfortunately, I can't share their links with you, but you can easily find them on Google if you search for them. And perfect, as you can see, we managed to find the key. It's telling us the key is found, and this is the key to the network. And this is the correct key because, as you know, this is the same key that we got when we exploited the WPS feature. So now we can go ahead and connect to the network, and we'll be able to run all of the cool stuff that I'm going to teach you in the post-connection attack section. Now, this is the only practical way known so far to crack WPA and WPA2 keys. There are methods to speed up this process, so you can use the GPU for cracking because it's much faster than the CPU. That's if you have a GPU. You can also use rainbow tables. You can also pipe the word list as it's being created in Crunch to aircrack-ng. This way you can create bigger word lists without using any storage on your computer. There are also methods so that you can pause your cracking process and then come back after a while without losing your progress. But the main idea is the same. The only way right now to crack WPA and WPA2 is through a word list attack. You can use social engineering, however, to get the password using an evil twin attack where you trick one of the users to give you the password. This is actually all covered in my advanced network hacking course. The cracking using the GPU, piping Crunch to aircrack-ng, getting the password using an evil twin attack, and much more advanced network hacking techniques. If you're interested in that, then I highly recommend you have a look on my advanced network hacking course. Check out the bonus lecture of this course, the last lecture of this course. It contains links to all of my other courses and a comparison between them. We saw in the previous video how we can use aircrack-ng to crack WPA encrypted passwords using a word list. In the previous video, aircrack-ng went through our word list. It combined each password in the word list with the ESSID to create the PMK using the PBK2 algorithm, and then compared the PMK to the handshake. If the PMK was valid, then the password that was used to create the PMK is the password we're looking for. If it's not, it just went to the next password and created a PMK from it. So aircrack-ng was creating the PMKs on the fly. The process of combining the password and the ESSID to create the PMK takes a good bit of time, so it takes the most time of the cracking process. Therefore, in many scenarios, while we're waiting to capture the handshake, in many scenarios we'll have access points that doesn't have any clients connected to it. So if we have something like that, we have to wait until someone connects to the access point to capture the handshake. So while we're waiting, we can actually save time by converting our word list to a PMK list.
because as I said, converting the password to a PMK takes the most time. So while we're waiting, we can change each password in the list and create a new PMK list from our word list. And then once we capture the handshake, we can use our ready PMKs, and the cracking process is going to be much quicker. We're going to do this using Airodump-ng. So let's see how it works. Okay, so our first command is going to be to create a new database and import our word list in that database. So it's going to be Airodump-ng. We're going to create a new database. So let's call it test DB. And we're going to import passwords. And we're going to put the name of our word list, which is called WPA word list. So very simple. Airolib is the name of the program. Test is the name of the database that we're going to create. And we're telling it to import passwords. And the passwords are going to be taken from a file called WPA word list. Gonna hit enter. And as you can see, a new database called test DB has been created. And the passwords have been imported into it. So the next command we're going to do is we're going to import our ESSID to the database. So I'm just going to store the name of the ESSID of the target network into a file. I'm going to do this using a Linux command, the echo command. So I'm just going to say test AP. I'm going to echo it to a file, and I'm going to call the file test ESSID. So that's basically, so I'm going to read it now. Cat test ESSID. That's just making sure that the name is there. So this command, I just created a file and I saved the word test AP in that file. That's the name of my target access point. And then here I just read the file to make sure that it actually contains test AP, and we can see that it contains test AP. Now I'm going to import this file into my database. So we're going to use the same command that we used before. The only difference is we're going to say we're importing ESSID this time, and the name of the file that contains the ESSIDs is test ESSID. So again, Airodump-ng test DB, that's the name of my database that I'm importing information to. Import is the command, we want to import stuff. ESSID is the name that we're telling it we want to import ESSID. And test ESSID is just a text file that contains the name of my target access point. Gonna hit enter, and that has been imported successfully. Now this is the step that takes the most time. We're gonna convert each password in the list. We're gonna combine it with the ESSID. So we're gonna create a list of PMKs from our word list. Again, we're gonna use Airodump-ng, and we're gonna put the name of the database that contains our word list, and then we're gonna tell it to batch, which is just convert each password, combine it with the ESSID, and create a PMK from each password in the list. Okay, so as you can see now, it computed all the PMKs. So that's the number of PMKs. That's the number of passwords that I have in my original list, and all of these passwords have been converted to PMKs, and they're stored in my database, which is testdb. And we can see that it took 366 seconds. So we're saving this time because in the scenario that we're working on, we'd be only waiting for the handshake. So we can do this while we're waiting to capture the handshake. Once we have the handshake, then we can crack it straight away using the PMKs, the already done PMKs, which will be much quicker. Let's see how we do that. We're going to use Airdump-ng, and we're going to use the option R to specify our database, which is called test DB. And then we're going to specify our handshake file, which is WPA or test handshake.cap. So very simple, Airdump-ng R to specify the test DB, and then we're going to specify the handshake file. Gonna hit enter, And as you can see, we cracked the password in much quicker. We cracked it in less than a second. So in the previous video it took 2 minutes and 16 seconds. Now it took less than 1 second. So it's much quicker, because instead of Airodump-ng converting each password to a PMK, we are using a list of already made PMKs. So this is useful if capturing the handshake is taking a while because there is no clients connected to the target network. We have our PMKs ready so that once we capture the handshake, we can crack it straight away. So in the previous 2 videos, we saw how we can use Airodump-ng to crack the password, to crack the WPA key. The first method was using a word list straight through Airodump-ng, and the second method was after we convert the passwords to PMKs. However, in both methods, we were using our CPU to do the work. So in the first method, Airodump-ng was using the CPU to calculate the PMKs. In the second video, we calculated the PMKs first, and then we used Airodump-ng, and Airodump-ng used the ready PMK database. But in both methods, we were using the CPU to do all the computations. GPUs are usually quicker than CPUs. Therefore, if you have a strong, powerful GPU, the cracking process can be much quicker if you use the GPU instead of the CPU. So we're going to talk about a tool called Hashcat, which allows us to crack the key using the GPU, not the CPU. I'm going to explain how to use the tool from Windows. You can use the tool from Linux. The only reason I'm going to explain how to use it from Windows because most devices it's easier to find a driver for your graphics card for Windows than Linux. All graphic cards are supported on Windows, whereas you might have some trouble finding the driver for your graphics card for Linux. Therefore, I'm going to talk about how to use Hashcat from Windows. So first of all, you're going to need to download 2 files. First one is Hashcat, the tool that actually does the cracking, and the second one is Hashcat GUI, which is the graphical user interface for Hashcat. After we do that, we're going to need to convert the handshake file to a HCCAP file. So the handshake was captured in a CAP file, as we saw in the previous videos. We have to convert it to a HCCAP file so that Hashcat can read this file. So we can do that from their website, hashcat.net. Let's see how we do that. So hashcat.net. It's cap to HCCAP. And it's gonna ask us to browse to download the file, so we'll do that. To upload the handshake file, so we have it called test handshake. Here we go. Open, and then I'm gonna add the ESS ID, which is called test AP, and I'm gonna click convert, and it's converted the file, and it's allowing me to download HCCAP file that's ready to download. So I'm just gonna click OK, and that's been downloaded. I'm just gonna copy it to the desktop so it's easier to access it. Okay, and now we're gonna run Hashcat. Just double click it, the Hashcat GUI. Gonna click run, and we're gonna navigate to OCL Hashcat here. So first thing, we're gonna choose our hash file. So that's the handshake file that we just downloaded, the HCCAP one, and that's it here. So I'm just gonna open it. That's done. Now we're gonna choose the encryption that we want to decrypt, and it's WPA2. And the binary file, you're gonna have to, as I said, we're gonna have to download 2 files. The first file here is that's gonna contain the binary, the actual program that does the decryption, and or the word list attack. And then the second one is just the GUI. So we're actually in the GUI right now, and we have to specify the binary. So you browse and you go to wherever you extracted your binary and you click the binary file. So I'm going to use the 64-bit because I have a 64-bit computer. I'm going to click open and everything's ready now. So you choose your HCCAP file, you choose the encryption, you put the binary, and then you can click on reverse engineer to get it to work. Actually, I should pick the 32 version and to click it. And as you can see, I get an error because I actually don't have a graphics card in this computer. So I just made this video to let you know, or to show you how you can use Hashcat. Now, if you have a graphics card and if the driver is installed, it should work for you. But for me, I don't even have a graphics card, so that's why it's complaining about OpenCL. So that's it. Using the GPU should be much quicker than the CPU. So if you have a powerful one, then that's gonna help you a lot with the cracking process, and it's gonna speed it up by a huge amount. Now, we've talked about 3 different methods of cracking the WPA key. Now there's other methods, there's a lot of methods to do that. There's also online services that you can just upload your handshake file, and they have huge word lists, and they have hypercomputers that will try to crack your password by running those huge word lists against your handshake file. They're actually really good, those services, because their computers are very fast, they're hypercomputers, and their word lists are huge. So you can also try them if you're stuck, if you couldn't find the key by your local machine or using your local word list.
Okay, so through all the previous lectures, we've seen all the weaknesses that can be used by hackers in order to compromise WIP, WPA, and WPA2 encrypted networks. We've seen how they can use these weaknesses to crack the password and get the actual key to the network. We also seen that attackers are able to deauthenticate or disconnect any device from any network without the need to know the key to that network. And in the previous lecture, we've seen how we can modify the settings of our routers so that we can increase the encryption of our network, increase the security of our networks, so that hackers can't use the attacks and get the password. Now, in order to apply the settings that we talked about in the previous lecture, you need to be able to access the settings page for your router. Now, each router has a web page where you can modify the settings for the router, and it's usually at the IP of that router. So first of all, I'm gonna check and get the IP of my computer or of my device, and I'm just gonna do ifconfig lan 0. And as you can see, this is the IP of my computer. So I'm gonna open my browser, and I'm gonna navigate to 192.168.0, and the IP of my computer was 25. Usually the IP of the router is the first IP in the subnet, so this is the subnet. At the moment it's 192.168.0, and I'm just going to add number 1 because that's the first IP in the subnet, and that will take me to the router settings page. And as you can see, it's asking me to enter a username and a password. Now, routers come in with a pre-specified username and password. You can check what's the default username and password, and then I highly recommend you change them after that. So usually it's written in the manual. So check the manual, see what's the default username and password, and then you can log in. Now, in some cases, the attacker might be doing a deauthentication attack against you, so he might be preventing you from connecting to your network wirelessly. So what you can do is you can connect to your router using a cable, using an Ethernet cable, and when you do that, then the attacker cannot use a deauthentication attack to deauthenticate you or disconnect you. So you'll be able to access your router settings using the wire, and then you can modify your security settings and change the encryption, change the password, do all the things that I recommended in the previous lecture in order to increase the security so that the attacker will not be able to attack your network and get the key. Now, the settings of each router are different. They depend on the manufacturer and even the model of the router. But usually the settings, the way that you change the settings is the same. And like 90% of the cases, the router is always at the first IP of the subnet. So all you have to do is you get your IP using fconfig command like we did here when we got it, and it was 192.168.0.25. That's the IP of my device. And then I changed the last 25 to number 1 to the first IP, and that is the IP of my router. Now, I'm going to navigate to the wireless settings. Now, as you can see, there's a lot of settings that you can change for your network, and we're concerned with the wireless settings at the moment. So, as you can see, my wireless is enabled. You can change the name of the network, you can change the channel, and the bandwidth and all that. So I'm going to go to the security, and as you can see now, I'm using WPA encryption with WPA or WPA2 in authentication, and the encryption using AES and TKIP. And if I go on WPS, you can see that the WPS is disabled, as we said now. So basically, I'm not using web, so they cannot use any of the attacks that we spoke about that allow you to crack WEP encryption. I'm using WPA, which is much more secure, and I disabled WPS, so they cannot use Reaver to determine my WPS pin and then reverse engineer my password. The only way that the hacker can access or get my password is by obtaining the handshake first and then use a word list to find my password. Now, my password is very random, even though it actually doesn't use numbers or digits, just letters, but it's very random, so there is a really small chance of someone being able to guess that password. Now, there is another thing that I'd like to show you here is the access control. And using this, you can add policies. So you can add an allow policy or a deny policy. And using that is based on the MAC address. You can specify MAC addresses that you want to allow to connect to your network. You can also specify MAC addresses that you can deny from your network. So for example, you can just, if you don't have many visitors coming to the house, or if you're in a company with a specified number of computers and you want to only to allow a number of computers to connect to that network, then you can just ask the people, get their MAC addresses, the people that you want to allow, and add them in an allow list. Now, even if someone has the actual key, the right key for your network, and they don't exist in the whitelist or in the allow list, they will not be able to access the network. You can also add a deny list, which is if you want to deny a certain computer or a certain person that you think are suspicious, you can just add their MAC address in the deny list, and they will not be able to connect to your network. So this is about it. As I said, the settings page usually look different. The names might be called different names, as in the names for each of these tabs. But usually the main thing is you should be able to access the router settings using the subnet IP and adding number 1, which is the first IP at the end. And if you're being attacked, if you can't connect to your network at all, then just use a cable and modify the settings like we discussed in the previous lectures. In this section, we're going to talk about post-connection attacks, so attacks that you can do after connecting to your target network. Now, it doesn't matter whether the target network is a Wi-Fi network or a wired or an Ethernet network. It really doesn't matter. As long as you gained access to this network, as long as you're able to connect to it, you'll be able to do all of the attacks that I'm going to show you in this section. Now, you'll notice once connected, you can do so many cool things. So you'll be able to gather detailed information about all of the clients connected to the same network. You'll also be able to intercept data and see any usernames, passwords, or any information they use on the internet. You'll be able to modify data as it's being sent in the air. So you'll be able to inject evil code and do so many cool things on the network. Now, to do all of the attacks that I'm going to show you in here, you have two options. The first option is to run the attacks against the virtual NAT network against the Windows machine. You just need to make sure that the virtual Windows machine is connected to the same NAT network as the Kali machine. Or you can run the attacks against real computers connected to your real Wi-Fi network, and you need to make sure that you have a wireless interface connected to the Kali machine, and the Kali machine needs to be connected to your target Wi-Fi network. Now, throughout this section, I'm actually going to be using both options. So I'm going to be running some attacks against the Wi-Fi network, and I'll be running some against my virtual NAT network, just to make sure that you're comfortable with running all of these attacks in different environments and in different networks. Because like I said, it doesn't really matter how you gained your access to the network. The network type doesn't really matter either, as long as you are able to connect to the target network.
The last machine that we're going to talk about installing today is the Windows machine. So this is just a normal Windows machine that with Windows 10 that we will also try to hack into. This one will be used with scenarios that mimic a normal user that is just using their Windows to browse the internet or do whatever normal people do with their machines. So Microsoft has actually released a free versions or free virtual machines of Windows that you can download and use. These are free and you're allowed to download them, and we're downloading them from Microsoft's website. So you need to go into this link to download it. As you can see here, this is the same link. So make sure you select what host operating system you have. So if you have Windows, you click on the Windows tab. If you have Mac, on the Mac, and if you have Linux, on the Linux. I have a Mac, so I clicked on the Mac tab. And from here, make sure you select Windows 10 Stable. And make sure you select the VirtualBox image. So these are all applications that allow you to install virtual machines. At the moment, we're using VirtualBox for everything. So just make sure you use the VirtualBox image. Once you do that, you will have a zip file like this one. Uncompress it, and you will get this file right here. Now this is a virtual machine, a VirtualBox virtual machine file. So I'm gonna double click it. And as you can see now, VirtualBox is asking me to import this machine, and it's already set up the settings for it right here. Now we can import it the way it is and then modify the settings. Now as you can see here, I have my Windows installed right here. And I'm just going to boot into it by, actually I'm going to modify the settings first, because I remember I think it gave it 4 gigs of RAM, and I think that's too much. So I'm going to go in to here, and I'll set this to 2 gigs. And yeah, and set that, okay. And I'll start it. And as you can see, Windows starting straight away, no need to install it. It's already installed and ready and given to us by Microsoft. Now, as you can see, we have a fully working Windows machine right here, Windows 10, and it's going to be our second victim or target machine.
Information gathering is one of the most important steps when it comes to hacking or penetration testing. If you think of it, you can't really gain access to a system if you don't have enough information about it. So for example, let's say you're connected to a network, and one of the devices connected to this network is your target. Now for you to hack into that target, first you need to discover all of the connected clients to this network, get their MAC address, their IP address, and then from there try to maybe gather more information or run some attacks in order to gain access to your target. Now, there are a number of programs that will do this for you. Examples are NetDiscover and Nmap, which do this job really well. So in this lecture, we'll start with the simpler one, which is NetDiscover, and see how to use it to quickly map the network we're connected to. And in the next lecture, I'm going to show you how to use Nmap to gather detailed information about all of the clients connected to the same network. So I have my Kali terminal in here, and if I do ifconfig, you'll see I have ETH0, it has an IP address, and like I said, this is the virtual interface created by VirtualBox when we set the Kali machine to use a NAT network. Now, I also said that this NAT network behaves exactly like an Ethernet network, and as far as the Kali machine is concerned, it thinks that it is connected to a real wired network. And as you can see in here, it's telling me that wired connected. Now, I have my virtual Windows machine right here. It is configured to use the same NAT network as the Kali machine. Remember, we're still in the network hacking section, so both you and the target machine need to be connected to the same network. So as far as these two computers are concerned, they think that they are connected to the same network. So what I want to do right now is use NetDiscover and see how we can use it to discover all devices connected to the same network. Now, the method that I'm going to show you will work exactly the same whether you're using it against a virtual network like I'm doing right now, or against real network, and even if your target is a Wi-Fi or a wireless network. So all you have to do is type the name of the program, which is NetDiscover, and then type -r to specify an IP range to search for. This needs to be a range that can be accessed by you. So right now you can see that my IP is 10.0.2.16, and I can only access IPs on the same subnet. So IPs on the same subnet start at 10.0.2.0 and they would end at 10.0.2.254 because 254 is the last IP that a client can have. So my range is going to be 10.0.2.1, and I want to search for clients that might have an IP of 10.0.2.1, 10.0.2.2, 10.0.2.3, all the way up to 10.0.2.254. So instead of manually typing all of these IPs, I can just type over 24, and NetDiscover will automatically know that I'm trying to search for all of the IPs that start at 10.0.2.1 and end at 10.0.2.254. So this is a way of specifying an IP range for the whole subnet. So if I hit enter now, you'll see that NetDiscover will show me all the IPs of the devices connected to the same network, and note that the first three parts of the IPs are always the same because they are on the same subnet. And I also have the MAC addresses of these clients, and NetDiscover is also attempting to guess the device vendor. Now if I press Q, this will quit the program, and right now we have a list of all the connected clients to the same network. Now, like I said, you can also use this method to discover clients connected to the same Wi-Fi network. The only thing is, right now, if I do ifconfig, you can see that my Kali machine does not have a wireless adapter. It's not connected to a Wi-Fi network. And like I said before, you cannot access the built-in wireless card from a virtual machine. Therefore, if you want to do this or run any of the wireless attacks that we're going to see in the future against a real computer and a real wireless network, you're going to need to use a wireless adapter. Now, I'm going to include links in the description that will help you pick a good adapter that works with Kali Linux. But right now I actually have one, and I'm just going to connect it and use it just to prove to you if things work on the virtual machines connected to the virtual network, they will work exactly the same against a real network with real machines. So I'm going to connect my adapter now, and if I do ifconfig, it's still not showing up. So I'm going to connect it from my devices, USB, and click on the adapter name. And let's see if it shows up now. Perfect. As you can see, I have an adapter now called LAN 0. And what I'm going to do is I need to connect this adapter to a Wi-Fi network first before I can discover all the connected clients to this network. So I'm going to go to my network manager. I'm going to click in here, and you want to click on select network. And as you can see, automatically now it actually connected to a network. But in your case, you'd want to select a network and click on connect, and then it will ask you for the password. So now I'm actually connected, and you'll see if I do ifconfig again, right now LAN 0 has an IP address. So this means that it is connected to a network, and this means that we can use it now with NetDiscover. So again, I'm going to use the exact same command that I used before just to show you and prove to you that if this works against virtual machines, it will work against real machines. And the only difference is going to be the IP. So I'm going to remove this IP. And as you can see right now, my IP is 192.168.1.8. So therefore, the range that I'm going to look for is going to start at 192.168.1.1. And I'm going to leave the over 24 here because this will tell NetDiscover that I want to start at 192.168.1.1 and finish at 192.168.254. So if I hit enter now this did not work, and I know why. In order for this to work, you actually have to disable the NAT network. So to disable the NAT network, we're going to go on devices, we're going to go on network, and we're going to uncheck the connect network adapter. So now once done with this, if we just run the exact same command again, as you can see, it's discovering all the connected clients, all their IP addresses, all their MAC addresses, and it's guessing the manufacturer. And you can see it's also discovering some Apple devices here. So as you can see, it's working perfectly using the exact same command. Now I only did this just to show you that if things work against virtual machines and against virtual networks, then they will work against real machines, because these virtual machines and virtual networks are modeled over real machines. And as far as the machines are concerned, they actually think they are real computers and real machines. The second program that we'll use for network mapping is Nmap. Now in the previous lecture we used NetDiscover, and we've seen how nice it is to quickly discover all the devices connected to our network, see their MAC address, and maybe get the vendor. Nmap takes scanning to a whole new level. It might be a little bit slower than NetDiscover, but it will show you much more information about the target. So you'll be able to see the open ports, you'll be able to see the running programs or the running services on these open ports. You'll be able to determine the computer name, the operating system running on that computer. If you're in a network, you'll be able to discover all of the connected clients. You'll be able to bypass security, bypass firewalls, and so much more. Nmap is actually a huge tool, and there are books and complete courses done just to teach Nmap. The Nmap book would actually be a really good read once you're done with this course. Now, because this tool is huge, we're not going to be able to cover all of its uses, but in this lecture I'm going to show you the basics of this tool, how to use it to discover all the connected clients and see useful information about them, and we'll actually use it more when we get to the gaining access section. We're actually going to be using Zenmap, which is the graphical user interface of Nmap. So to run it in terminal, you just have to type Zenmap, or you can find it under your applications menu. Now, as you can see, it has a very simple interface. The first thing that we see is the target input box. In here, you can put your target. You can scan any IP that you can reach, whether it's a personal computer, whether it's a server, whether it's an IP for a web server, for a website, for example, that you want to discover all the open ports and all the running services on it. Or, like what we're going to do right now, we can put a range similar to what we did with NetDiscover, and it'll scan this whole range, discover all the live IPs, all the IPs of the connected machines on the same network, and display information about them. Now we'll have a look on how to scan servers in the gaining access section. So for now, since we are still in the network hacking section, we're gonna put a range to discover all the connected clients and see useful information about them. So right now I'm actually connected to my wireless network. That's why I'm gonna specify the whole range on that network, and we've seen how to get that in the previous lecture. So it's 192.168.1.1 over 24. At the bottom, you can see the command. This is actually the nmap command that will be executed when I hit the scan button. So like I said, ZenMap, what we're using right now, is just a graphical interface that will run this nmap command in the background and show me the results. So if you know a custom nmap command, you can put it here, or if you just want to see nmap in terminal, you can literally copy this command, paste it in terminal, and it'll give you the same results that you would get if you run it here. Alternatively, if you don't really know much about nmap and its commands, you can use one of the ready profiles in here. So in this lecture, we're actually going to be using a number of these profiles, and we'll see the difference between them in terms of speed and the information gathered. So I'm going to start with the ping scan. This is a very quick scan. It literally just pings every possible IP in the range, and if it gets a response, it'll record this response and it'll show me the devices that gave me a response, which means that these are the devices connected to the network. Now, a lot of devices do not respond to ping requests even if they are alive, so the list that you'll get in this scan might not include all the devices connected to your network. Now, once the scan is done, as you can see, we can see the list of all the connected devices in here. And in here, we can also see the MAC addresses for each of these devices. We also can see the vendor. So for example, we can see that the device at 192.168.1.1 is a Cisco device. This is actually my router, and it is made by Cisco, so this is correct. So we can go ahead and start looking for exploits in this device. We can also see the 192.168.1.10 is a HTC device, and again, this is a HTC phone. This is correct. And since it's HTC, then we know that it's probably running on Android. So as you can see, we're getting more information about the connected clients. Again, we can see the 192.168.1.12 is an Apple device. So it could be a phone, a tablet, or a Mac. We can see the next device is a Dell. So again, it was a very quick scan, but as you can see, it still gave us much more information than what we got from NetDiscover. The next scan that I want to show you is the quick scan. Now this is going to be slightly slower than the ping scan, but it's going to show us more information. So right now you can see that the scan is showing us the same information that we've seen before with the ping scan, but it's also showing us the open ports on each one of the discovered devices. So it's able to discover the following ports in the router, and we can see that port 80 is open. This is actually the port used for the router settings page because it runs on a web server, so this is correct. Again, we have our Apple device here that we said it might be a phone or a computer or a tablet, but we can see now it has port 22 open, so this is a port for a service called SSH, which is designed to allow remote access to the system it's running on. Again, if you go on all the other devices, you can see all the open ports and the services running on each one of these ports. Now, in the next lecture, we'll build up on this. We'll see how to gather even more information, and you'll see how important information gathering is, because we're going to use the gathered information to hack into an iPhone that is connected to the same network. Now, in the previous lecture, we had a quick look on ZenMap and how it can be used to gather information. So in this lecture, we'll build up on that. And the main scan that I want to show you right now is the Quick Scan Plus. This scan takes the Quick Scan one step further. So first of all, it'll be slower, but it's going to show us even more information. So first, we're going to be able to see the operating system running on the discovered devices. We will also be able to see the device type, whether it's a phone or a laptop or a router. And we'll be able to discover the program and the program version running on the discovered ports. So before, for example, we were able to discover port 80 is open, but we didn't know what program is running on this port or what version of this program. Getting the exact program version is really helpful when we get to the gaining access section, and you'll see then how we can use that to exploit vulnerable services and gain full control over the computers that have these services installed. Now, straight away, when you look at the results, you'll see that we got much more information than all of the scans we ran so far. So the first thing you'll notice is the icons beside the IPs of the discovered devices. These icons represent the operating system running on these devices. So right now we have the operating system for all of the connected devices. And now it's showing us the programs running on each of the discovered ports and the versions of these programs. So for example, if we look at the 192.168.112, the Apple device, on the last scan, we knew that port 22 open and we knew that SSH is running on it, but we didn't know what version of SSH was running. Right now we can see that it's running Open SSH version 6.1. So we can go on Google and look for exploits and vulnerabilities in this specific version, and we might actually find something. We'll actually talk more about that in the gaining access section. Now, if you look at the device type, you can see that it's a media device, it's a phone. So before, we knew this is an Apple device, but we didn't know whether it's a tablet, a phone, or a MacBook. Right now, we know that it is a phone. It's also discovering that it's running Apple iOS 4, 5, or 6. Now it's actually running a newer version of iOS. I'm not entirely sure. I think 9 or 10, but still it's close enough. It's telling me that it's an Apple. It's telling me that it's a phone. It's running iOS. So this is really, really good. Now if we go to the next device here, the 192.168.120, this is a Linux device, and when we ran the quick scan, we were able to identify port 80 and port 49152 open, but again, we didn't know the program running or the service version running on this port. So right now we know it's Apache HTTPD 2.2.22. It's running on Ubuntu. So again, now we have the operating system, the exact version of the service running, so we can go and look for weaknesses and exploits in this specific version. And this port, we didn't even know what service was running on it. Right now we know it's a UPnP service, and the server is MediaTomb UPnP. We have the exact version again. So again, we can go ahead and look for exploits in these specific versions, and if we discover any, we'll be able to gain full control on this computer. Again, if we go down to the 192.168.122 machine, we can see that it's running a Microsoft HTTP API on port 5357. You can also browse by the services. So from here on the left, if you click on services, you'll be able to categorize the discovered clients based on the services. So if we click on HTTP, we'll see all the clients that have a HTTP service running. If you click on SSH, we can see the Apple device here. It's the only device that has a SSH service running. So let me actually show you a quick and fun example. If we go back here to the hosts and go back to the Apple device, the 192.168.112, as I said, we know it's a phone, we know it's an Apple phone, we know that it has an SSH service installed on it, running on port 22, and we know that SSH is a service that allows you to remotely execute system commands on the computer that has the SSH service installed. Now, obviously, before you can use this service, you have to use a username and a password. Once you authenticate, it'll allow you to execute system commands remotely on that computer or on that phone. Now, by default, iOS devices do not have an SSH server. Usually, when you jailbreak the phone or the device, it'll automatically install an SSH server, and the password for that server is set to Alpine by default. That's ALPINE. Now, since we know that this is an iPhone and it has port 22 open with Open SSH server, we know that this phone has been jailbroken. Now, since the phone is jailbroken, we know the password to log into SSH is Alpine unless the user changed it. Now, most users do not even know about this, and even the ones that know about this, like myself, are too lazy to change it. So it's always worth a try if you discover a phone like this in the same network. It's always worth a try to go and try to connect to it with the default password. So I'm just going to go to my terminal and I'm going to try to connect to this phone using SSH. So I'm going to type SSH root, which is the username for the admin in Linux, at 192.168.112. This is the IP of the phone. I'm going to hit enter. It's asking me if I should trust this connection. I'm going to say yes. And now it's asking me for the password. And like I said, when the phone is jailbroken, the password is set to Alpine. So I'm going to type ALPINE. I'm going to hit enter. And as you can see, I logged in as root. So right now I have the highest privileges on the phone and I can do whatever I want on the system. And now we can use system commands to completely control the phone. Now this is a little bit ahead of time. We are still in the network hacking section, so don't worry too much about this. We'll talk more about it in the gaining access section, but it's just a quick example that I wanted to show you of how powerful information gathering is, because we literally did not exploit anything right here. We just relied on the information we gathered and we were able to hack an iPhone that is connected to the same network as us. Now, like I said, Nmap is a huge tool. I highly recommend you go ahead and try the other profiles in here. And like I said, once done with the course, I think the Nmap book would be a really good read. We'll also use Nmap much more in the gaining access section, and we'll see how we can use this information to gain full control over the computers using code execution vulnerabilities and so on. But in this lecture, I just wanted to give you a quick overview, and we'll build up on this as we go through the course. Now, in this lecture and the next few lectures, I want to start talking about man-in-the-middle attacks. These are attacks that we can launch only if we are able to intercept the communication between two devices. Hence the name man-in-the-middle attacks. So, a normal communication would look like this, where the device is directly communicating with the entity that they want to communicate with. In a man-in-the-middle attack, the hacker would be able to place themselves in the middle of the connection, allowing them to intercept and see anything that is being transferred between the two devices. Now, there are a number of ways to achieve this. The first method that we'll cover in this course is using an ARP spoofing attack. ARP spoofing allows us to redirect the flow of packets, so instead of it flowing as shown in this diagram, it would flow through my own computer. So any requests sent and any responses received by the target computer will have to flow through the hacker computer. This means that any messages, any websites, any images, any usernames, any passwords entered by the target will have to flow through my computer. This allows me to read this information, modify it, or drop it. So as you can see, this is a very serious and very powerful attack. And the reason why it is possible is because ARP is not very secure. Now, for us to understand how this works, you need to have a basic understanding of what ARP is. ARP stands for Address Resolution Protocol, and it's a very simple protocol that allows us to link IP addresses to MAC addresses. So, for example, let's say we have a network here. We have devices A, B, C, and D. They are all connected to the same network. And we have the router here for this network. We can see that each device has an IP and a MAC address. And let's assume that device A needs to communicate with device C. Now we're also going to assume that device A knows the IP of device C, but as we know so far, in order for these devices to communicate within the same network, device A needs to know the MAC address of device C, because like we said before, the communication inside the network is carried out using the MAC address and not using the IP address. So this is a perfectly normal situation where we have a client that needs to know the MAC address of another client so that it can communicate with this client. So what this client does, it uses the ARP protocol. What do I mean by that? Basically, it sends a broadcast message. So it sends an ARP request to all the clients on the network saying, who has 10026? Now, all of these devices will ignore this packet except the one that has this IP address, which is 10026, which is device C. So all devices will not do anything, and the only device that will respond is device C, sending an ARP response. In this response, device C is gonna say, I have 10026, my MAC address is this MAC address. This way, device A will have the MAC address of device C, and now it will be able to communicate with device C and do whatever task that it wanted to do initially. So all of this communication is facilitated using the ARP protocol. Like I said, the ARP protocol is a very simple protocol. As you can see, all it has is requests and responses, and the whole point of it is so that we can link IP addresses to MAC addresses or translate IP addresses to MAC addresses. So a device can send a request asking for a MAC address, and then the device that has the MAC address would respond with its MAC address. So each computer have an ARP table which links IP addresses on the same network to their MAC addresses. So if I go on the Kali machine and do ARP-A, you can see my ARP table here, and as you can see, it's linking the router's IP to the router's MAC address. Now same if I go to the Windows machine and run my CMD and do ARP-A, you'll see again it's linking the router's IP to its MAC address. So this machine, anytime it needs to send any request to the internet, it will direct that request to this MAC address, to the MAC address that's associated with the IP of the router, which is 10021. Now, this value in here can be easily modified by exploiting the ARP protocol. So let me go back to my diagrams, and right here we have a diagram of a typical network, and you can see that normally any device that's connected to the network, if it wants to send requests, it will send them to the router will go and send that request to the internet, wait for the response, and then forward the response to the device that requested it. So if the hacker or the victim or any other computer on the network wanted to send a request, they will send that request directly to the router. Now what we can do is we can exploit the ARP protocol and send two ARP responses, one to the gateway and one to the victim. We're gonna tell the gateway that I am at the IP of the victim, so the access point will update its ARP table and it will associate the IP of the target with my MAC address. We'll do the same with the victim, so we'll send it an ARP response. We're gonna tell it that I am at 10021. So it's going to update its ARP table and associate the IP of 10021 with my own MAC address. So the result of this, the victim is gonna think that I am the router, and the router is gonna think that I am the victim. So anytime the victim wants to send any requests, the requests will have to flow through my computer, and I'm gonna forward them to the router. And then anytime the access point or the router wants to send responses, they're gonna go to my machine because it thinks that I am the victim, and then I'm going to forward it to the victim. So as you can see, This puts me in the middle of the connection and it gives me so much power, and we'll see all the things that we can do once we become the man in the middle. Now, the main reason why we can do all of this is because ARP is not secure. Because first of all, clients can accept responses even if they did not send a request. So, as I said before, we're going to send a response to the access point and a response to the victim, telling them that I am at a specific IP. Without them asking who am I, or without them asking for this IP, I'm just going to send a response and they're going to accept that response anyway. Not only that, but they're also not going to verify who I am. So when I say that I am at 10.027, I am clearly not at that IP because this computer is at this IP. But the access point will trust this and it'll actually update its ARP table based on the information that I send. Same goes to the victim. I'm going to tell it that I am at 10.021. It's going to trust and believe this even though I am clearly not at this IP because the access point is at this IP. So these are the two main weaknesses with ARP protocol that allow us to run ARP spoofing attacks. Now that we know how ARP spoofing works, let's see how we can run this attack and redirect the flow of data so it flows through our device. This will allow us to intercept data and see everything sent to and from a target computer, including usernames, passwords, and so on. Now, there are a number of tools that can be used to run an ARP spoofing attack. You can even build your own tool, and I covered this in my Python programming course. But in this lecture, I want to show you how to use a very simple yet reliable tool called ARP Spoof. Then, in the next lectures, we'll use a tool called Man-in-the-Middle F because it has more features. Basically, the main reason why I want to cover ARP Spoof in this lecture because it is a very simple tool, but it's very reliable. It's also ported to many operating systems, including iOS and Android. Therefore, if you learn how to use it here, you'll be able to use this tool on all of the other operating systems. So, you can only use this tool to redirect the flow of data and make it flow through your computer, and then you'll have to use another tool like a packet sniffer like Wireshark to analyze this data and do more stuff with it. And we'll cover all of this later on in the course. Now, using ARP Spoof is very simple. First, we're going to have to type its name, so it's ARP Spoof. Then, we're going to do -I to specify the interface that is connected to the target network. And in my case, it's ETH0 because that's the interface that's connected to the network. So if I do ifconfig, you'll see ETH0 is the interface that's connected. Now, as you can see, I'm going to be running this attack against my virtual NAT network. You can run this attack against any type of network, even Wi-Fi networks, and I will cover that later on in the course. But for now, just until you properly understand how this works, I highly recommend you do like I'm doing right now and test the attack against the virtual NAT network. So all you'll have to do is make sure the Kali machine and the target Windows machine are both configured to use the same NAT network. So we're going to do -T to specify the target, and my target is at 10.027. As you can see in here, that's the IP of my target. And I'm going to have to give it the IP of the gateway, which is at 10.021, as you can see in here. Now this will spoof the target, telling him that I am the router. We'll also need to run this command once more in here. So I'm going to clear the screen. And again, I'm going to do ARP spoof IETH0. And the target this time is going to be 10.021 and 10.027. So right now we're going to be telling the router that I am the victim. So the first one will fool the victim, the second one will fool the router. Now keep in mind, this attack will work against both Ethernet and Wi-Fi or wireless networks. I'm running it right now against the virtual network, which acts as an Ethernet or a wired network, but the attack can be executed exactly the same against wireless networks. All you have to do is connect a wireless adapter to the Kali machine, connect the adapter to the target network, and use it. So the same concept as the network scanner applies. You need to have a wireless adapter that works well with Kali, and you need to have that adapter connected to Kali and connected to the target network. So I'm gonna hit enter here, and I'm gonna hit enter here. And now if we go to the target machine and run the same command, ARPA, you're gonna see that the MAC address now for the router is different than what it was. And this is actually the MAC address of the Kali machine. So right now, this Windows machine thinks the router is at this MAC address, and every time it needs to send requests, it will send it to this MAC address, which means that they will be sent to this computer right here. Now, this computer is not a router, so when it gets requests, it's actually going to stop them from flowing and going to the router. This is a security feature in Linux. So you need to enable port forwarding so that this computer would allow packets to flow through it just like a router. Now to enable port forwarding, we're going to do echo 1 to proc sys net IP version 4 IP forward. And as you can see, this command gets executed with no issues, and right now this computer will still have its internet access, so we can go and browse any website we want. But all these requests are not going directly to the router, but they are going to this computer first, and then this computer is forwarding them to the router as shown in this diagram, and then when the responses come back, they're gonna go to the hacker first, and then they go to the victim. So it allows us to read a very simple data, so it flows through our computer, allowing us to become the man in the middle. And once we're the man in the middle, we can inject code in the browser of the target. We can steal usernames, passwords, see all the information that the person sends and receives, replace downloaded files with Trojans, and much more. In this lecture and the next few lectures, we're going to talk about a tool called Man-in-the-Middle Framework. And as the name suggests, this tool allows you to run a number of man-in-the-middle attacks. So let's run the tool, see how we use it, and we're gonna do a basic ARP poisoning attack exactly like we did in the previous video. If I do ifconfig just to show you my interfaces, you'll see that I have my ETH0 is connected to the internal network at 10.20.14.203. So I'm actually just gonna go on the Windows machine and do an ARPA to show you the MAC addresses. And you can see that we have the gateway at 10.20.14.1 and the MAC address ends with 3500. So we're gonna run the ARP poisoning attack and see if the MAC address changes and if we can become the man in the middle. So to use the tool, the name of the tool is man-in-the-middle-f, so we're going to put the command first. Then we're going to tell it to do ARP poisoning. Then we're going to give it the gateway, so the IP of the router. And then we're going to give it the IP of our target. And then I'm going to give it the interface. So the command is very simple. It's man-in-the-middle-f, the name of the tool. We're doing ARP spoofing. Then you give it the gateway, and I spelled that wrong. So the IP of the router, and then you give it the IP of your target, and then you give it the interface. If you don't specify a target, it'll default to the whole network, to the whole subnet. The interface here, as I said, I'm specifying my wired virtual interface, but you can specify your wireless card if it's connected to the network. Now, before we can run this command, we need to install man-in-the-middle-f, because it does not come pre-installed with Kali Linux. So I'm going to go down and I'm going to open a new terminal window, and I'm just going to do apt-get update to update my sources, and then I'm going to do apt-get install man-in-the-middle-f. So as we know, apt-get is the program that we use to install packages. We're telling it that we want to install a program called, or a package called, man-in-the-middle-f. I'm going to hit enter. And now it's asking me if I really want to install all of this. I'm going to say yes, hit enter, and it'll install it for me. Once this is done with no errors, this means man-in-the-middle-f is installed now, and I can go back and use it. So I have the command ready now, and all I'm going to do is just press enter to run the program.
And the tool is running now. Let's go to the Windows machine, do an ARPA, and see if we manage to become in the middle of the connection. So I'm going to run ARPA again. And as you can see, the MAC address has changed to 47E9. And that is the same MAC address as the virtual interface that we have here. So it ends up with 47E9. So that means we're the man in the middle at the moment. And the tool automatically starts a sniffer for us. So instead of ARP spoof, which only places us in the middle, this tool actually starts a sniffer, which captures the data that is sent by the devices in our network. So I'm going to go to a website. Now, first, I'm going to go to a HTTP website and see how we can capture the username and a password. And then in future videos, we'll see how we can capture passwords from websites that use HTTPS. So I'm going to go to a website called CarZone. And then I'm going to go to the login page to log into my account. And then I'm just going to use a username and a password. So I'm going to put the name as Zaid. And then I'm going to put my password, and I'm going to put a false password, but we'll just see how we can capture this password. So I'm going to put 123456. Now, if we go back to man-in-the-middle-f, you'll see that we have the username has been captured, which is zaid@isecurity.org, and the password has been captured, which is 123456. So basically, we are able to capture any username and any password that is entered by the target computers, by the computers which were ARP spoofing. You can also see all the URLs that the person have requested. So for example, you can see that they requested carzone.ie. You can also see the URLs that CarZone requested. So these are only URLs requested by the ads that's displayed on the website.
Now, everything that we did so far will only work against HTTP pages. The reason why it works against HTTP because, as we've seen, the data in HTTP is sent as plain text, so it's text that humans like us can read and understand. That's why when we're the man in the middle, we're able to read this text, and if we wanted, we're able to modify this text as we wish. Now, this is obviously a problem, and this problem was fixed in HTTPS. So, as you know, most websites these days use HTTPS, and all good websites, famous websites, use HTTPS. The reason why, like I said, because it's a more secure version of HTTP, and basically the way it works is it adds an extra layer over HTTP, which is where the S comes from. So it's a secure HTTP protocol, and this extra layer will encrypt the plain text data that HTTP sends. So if a person manages to become the man in the middle, they will be able to read this data, but the data will be gibberish. It will not be readable to the person intercepting the connection.
So what we're going to do, we're going to use a tool called SSL strip, which will downgrade any HTTPS request to HTTP. So whenever the target person tries to go to https.hotmail.com, for example, they'll be redirected to HTTP of hotmail.com. Let me show you first. So I'm going to go to my browser on the target, and I'm going to try to go to hotmail.com. Now, as you can see here on the top, you'll see that the website uses HTTPS. So if I try to become the man in the middle now, this website will display a warning. So to bypass this, we're going to use a tool called SSL strip to downgrade any request to the HTTPS website and get it redirected to the HTTP version of this website. Once we go to the HTTP version, then the sniffing the data will be trivial, exactly like happened in the previous video. So you can use SSL strip manually, but luckily man-in-the-middle framework starts it automatically for us. So I'm actually going to run exactly the same command that we seen in the previous video. I'm not going to change anything in it. And if you notice here, once we run this program, you'll see that it will actually tell us that SSL strip have been started and it's online. So I'm going to go back and I'm going to try to go to hotmail.com, and you'll see that instead of the HTTPS version that we're getting here, we're actually going to go to a HTTP version of hotmail.com. Now notice the top here. Notice that there is no HTTPS, so we're actually at the HTTP version of the website. You'll also notice that we didn't see any warnings, so it just looks like exactly a normal website looking exactly like hotmail.com. So I'm going to put in my email. And again, I'm going to use a false password. I'm just going to put 123456 and I'm going to sign in. Now, if we go to the Kali machine, you'll see that we managed to capture an email of zaid@hotmail.com. And we also managed to capture the password, which is 123456.
So when SSL strip is working, all the HTTPS connections will be downgraded to HTTP. Now, since the connections are going to be downgraded to HTTP, that means the data is going to be sent in plain text, which means that we'll be able to read all the data that's being sent, just like we usually do with HTTP. Now, there is one exception, which is websites that use HSTS. Now, HSTS is used by Facebook, PayPal, and Gmail, for example. And basically, the way this works is the browser at the victim, at the target, comes up with a hard-coded list of websites that it should only load as HTTPS. So even if we try everything that we can and try to downgrade this connection to a HTTP, the browser will just refuse to load this page because it knows that this page has to load over HTTPS. Now, so far there isn't a practical way of bypassing HSTS. There was, but that got fixed. But I will update you as soon as there is a new way to bypass it.
In this lecture, we're going to learn what DNS spoofing is and how to perform it. DNS is basically a server that converts domain names, so www.google.com for example, to the IP address of the device where Google website is stored. And since we're the man in the middle, we can have a DNS server running on our computer and resolve DNS requests the way we want. So for example, whenever a person requests google.com, we can actually take them to another website because we're in the middle. So when they request it, we'll actually give them any other IP that we want, and then they'll see a completely different website than what they're expecting. So we can have a fake website running on our own web server and get requests, for example, from live.com to that website. We can have a website requesting the target person to download a backdoor. We can do anything we want, really, pretending to be any other website. So the possibilities are endless of what you can do with this attack. Let's go and see how we can do this. The first thing, I'm going to be redirecting people to my web server. So the web server is going to be running on my local Kali machine. You can redirect people to any web server, anywhere you want, but in this video, we're redirecting them to our local web server. So to do that, we're going to start Apache web server. Comes in pre-installed with Kali. So all you have to do is service, Apache 2, start. And the web server has started. So the files for the web server are stored in var www.html. So I'm going to open my file manager and I'm going to go to var www.html. And if we open this, this is our index. So this is the page that will be displayed to people who browse our web server. Now you can have a whole complete website installed in here, and it will be displayed whenever a person visits your web server. At the moment, I have a really simple page that just says a simple text just as a proof of concept. Okay, so if we go to my browser and browse to 10.20.14.203, which is my own IP address, my internal IP. If we go to it, you'll see that we can see the text here. So we're all good. Let's configure the DNS server that comes in with man-in-the-middle framework. And to do that, we're going to use leafpad, which is just a text editor. And then we're going to go to etc, man-in-the-middle framework, man-in-the-middle.conf. Then I'm going to scroll down to where the A records are. And the A records are basically the records that are responsible to transform domain names or translate domain names to IP addresses. So we're going to be targeting live.com, and using the star is a wildcard. So basically we're saying any subdomain to live.com should be redirected to 10.20.14.203. And that's my own IP address. So you can replace this with any IP address. For example, you can put an IP address of a remote website that you have hosted on any hosting company, or you can have it redirected to Google, for example, if you put Google's IP. Any IP you put here will redirect live.com to it. So I'm going to close that. And I'm going to run my command. And the command is very simple to the commands that we were running before in previous videos. The only difference is I'm going to add one extra option, which is DNS. So it's exactly the same command. It's man-in-the-middle framework, ARP spoof, gateway, target, interface, and then we added one extra option, which is DNS. Gonna hit enter. And you'll see that DNS spoofing is enabled. So let's go to the target and try to go to live.com and see what happens. And as you can see, live.com, it actually uses HTTPS, and it has been redirected to our own website, saying simple text, obviously. But as I said, you can have this in here. You can install anything you want. You can ask them to download something, or you can have a fake page and steal credentials or whatever you're looking for. It can also be used to serve fake updates to the target person. For example, there is so many uses to DNS spoofing. So this is just the basic case of how you can do DNS spoofing. And then you can use it and combine it with other attacks or with other ideas to achieve really powerful attacks. In this video, we're going to have an example of a simple plugin that comes in with man-in-the-middle-f. So I'm going to do man-in-the-middle-f help. And if you scroll through all this help, you'll see a lot of plugins that you can use to do various things on the target computer. So you can use the inject plugin to inject code into the web pages that the target person loads, and we'll have an example on that later. What I want to do now is just show you an example of a simple plugin, and then we'll do more in the future. So for example, you can see here we have a screenshot plugin. And basically what this plugin does is it takes screenshots of each of the pages that the person uses. So whenever the person uses a page, it takes a screenshot of that page. And you can set up the interval right here. So that's the amount of time in which the program should take a screenshot. So it defaults to 10 seconds. So it takes a screenshot every 10 seconds, but you can modify it using the interval option. So we're having a basic look on how you use the plugins. So the first thing you do is you put the plugin name, and then you put the option that you want to set. So we're going to use the same command that we always use. And then we're going to put the plugin name after it. So the plugin name for me is going to be screen. And if you want to change the interval, you can put it this way. So you put the interval, and then you put the interval for taking the screenshots. I'm going to keep it at 10 seconds, so I'm not going to do anything. I'm just going to delete that. And I'm going to hit enter. And now we should be good to go. So I'm going to go to the target computer. and just browse the internet. So I'm going to go to bing.com and Google anything. You can go on images, whatever, doesn't really matter. So it's taking screenshots of everything now. Well, every 10 seconds it's taking a screenshot. And you can see that it's actually injecting the code in here every time. So I'm going to stop this, and then we're going to go and have a look on the screenshots that we captured. So the screenshots will be captured into the logs directory. So I'm going to go to files, and it's going to be in var logs and in man in the middle F. And you can see all the screenshots that we captured. Now, some of them have actually been captured before from other sessions. So you can see right here, we have the one for the picture, the one when I Googled the pictures right here. So all the stuff that's going to be captured, all the images will be stored in this directory, and you can see them and get an idea of what the person is doing on their computer. Now, there's other plugins that you can use. So you have the JS keylogger, which will basically inject a keylogger into the target page. But it's kind of useless because since you're the man in the middle, you can see the usernames and passwords anyway, or anything that gets sent on the target computer. But if that's what if for any reason you wanted to have some sort of a keylogger injected into the target computer or into the target website, then all you do is, again, same command that we always run, and just type in JS keylogger after it. And that's the keylogger injected. So again, if we go here and search for something else, or maybe we go and log in somewhere. So let's go and go to cardzone.ie. And I put my password as 123456. Logging in. Going back. Now, obviously, this has been captured because we're the man in the middle anyway. Now, if we go up, you can see that our JS keylogger, it's detecting that stuff are being entered into the field that is called email, user email. And we enter TETES, and then we put test at, and the final result was test@test.com. And then in the password, we were putting 112.123 up to, and then it was 123456. So again, if the target person is writing anything on any page, then you'll be able to capture it using this. But anyway, since you're the man in the middle, you can do that using Wireshark and analyze all the packets and see what the person is typing. This is another method of seeing it or of doing it. It's an example of how you could use the plugins that come in with man in the middle F. Now again, typing man in the middle F will give you all the options, all the plugins that you can use, and using them is very similar to what I've been doing. So you usually just put the option or the plugin name, and if you're gonna set any options for it, then you put a space and you set the options. In this lecture, we're gonna be talking about how to inject code into the browser, into the target computer. So since we're the man in the middle, and since everything flows through our device, then when someone requests a page, we can actually insert any type of code that we want into that page. Browsers can run two types of code. They can run HTML code and they can run JavaScript code. HTML code is the code responsible for the way that the page looks. So it's the code for the buttons, for the text, for the images, all of that. So it can't really be used to do anything that will allow us to gain any access to the target computer. JavaScript, on the other hand, it's a programming language that can be used to do many things, and we'll see that in future videos. In this video, we'll see how we can inject JavaScript code into the target browser. You can use the same method to inject HTML, but JavaScript is more useful. That's why we're going to use our example to inject JavaScript. So let's first of all run man in the middle F with the help command, and we'll see what options do we have with the inject plugin. So I'm going to do man in the middle F. And if we scroll up, you'll see that we have the inject plugin. So we're going to be using the same command that we always use. The only difference is we're going to insert the inject plugin. And then we have different options for injection. So there's three main options. There is
the file. So you can have your code stored into a file, and you can use JS file or HTML file to inject the code stored in that particular file that you specify. Or you can use, if your code is stored online and it has a URL, then you can use that URL or that link using the JS URL or the HTML URL options. Or you can actually supply the code itself through the command using the JS payload or the HTML payload. So we're going to be supplying the code through the command the first time, and then I'll show you using a file. So we're going to be using the inject payload, and then we're going to be doing JS payload. So I'm actually going to run the command here so we still have the help. So our command is going to be the same as always. And then we're going to add the option, the plugin, which is inject. And then we're going to tell it that we want to specify the code through the command. So we're going to use the JS payload. Then you can put the JavaScript code after this option. So I'm going to put my JavaScript code, and I'm going to use very, very simple code that will only display a message on the target computer. So our code is not going to do anything bad. It's not going to try to hack anything. All it's going to do is just display a message box on the target computer. And in future videos, we'll see how we can use that this option to do more powerful attacks. So basically, my code is going to do an alert, which is a function in JavaScript, and the alert is just going to say test. So our command is the same. It's man in the middle, F, ARP spoof, our interface, the gateway, the target, and then we loaded the inject plugin, and we're telling it we're specifying the code through the command. And the code that we want to run is alert, test, and that's it. I'm going to hit enter. And now the tool is running. Let's go to the target computer, browse a normal web page, and see what happens. So I'm just going to go to bing.com. And as you can see, the page bing.com displays a message box, and that message box says test. So again, this is very simple code that doesn't really allow us to do anything on the target computer, but we can use it in future videos to do more powerful attacks. Again, you can actually Google JavaScript codes and see codes that will be useful for you. For example, there's JavaScript keyloggers, there's codes that can take screenshots of the target computer, and there's a lot of codes. You can redirect the target computer somewhere else, steal their cookies. You can do a lot of these powerful attacks. Another way to run this attack is using the file. So if you are using one of these more complicated codes, it's going to be hard to write it through the command. So you'll be better off storing the code into a file and using the JS file option. So all you'll have to do is open your leafpad or get your code. So I'm actually just going to run leafpad, and I'm going to write the same code that we did there in a file. So I'm going to do an alert, and I'm just going to do test2 this time. And I'm going to store that in my root. That should be okay. And I'm just going to call it alert.js. And that's stored now. So again, if you're Googling or if you're using a more complicated code, you can have it all into this file and then inject it using the way I'm going to do it now. And then run the same command that we did. But the only difference, instead of using the JS payload, we're going to use a JS file. And we're going to specify the file, the full path to the file. So I stored it in root and alert.js. So if you downloaded a file of the internet that contains a keylogger, for example, or a file that will redirect the target computer to somewhere else, then again, same command, but make sure you put the JS file and then you put the full path to where that file is stored. I'm going to hit enter. And man in the middle is working for me. I'm going to come back here. And let's browse for something. Let's say JavaScript. And as you can see, our code, the second code that we put, which was called test2, was executed on the target machine. Now again, these are really simple codes, just displaying a message box, but you can download or look for more complicated JavaScript codes, or just follow up in the future lectures and see how we can use this feature to carry out more powerful attacks.
Now, please note that man in the middle F can only inject JavaScript code in HTTP pages, not in HTTPS. It is possible to inject JavaScript code in HTTPS pages, but the process is a bit more complex and requires some scripting. That's why I'm not going to include that in this course, because this is an introductory course that is designed to cover the basics of most hacking fields. However, I do cover it in my advanced network hacking course, which is called Network Hacking Continued, Intermediate to Advanced. So if you're interested, check out the bonus lecture, the last lecture of this course, for more info.
In this lecture, we're going to have a look on a tool called Beef. Beef is a browser exploitation framework allowing us to run a number of commands and attacks on a hooked target. A hooked target is basically a target which executes a URL or a JavaScript code given to us by Beef. Once a target is hooked, then we'll be able to run all the commands that Beef allows us to. So to run Beef, all you have to do is just click on the Beef icon right here. One click. It's going to start it for us. And it's going to automatically run this URL, which contains the browser interface or the web interface of the tool. So it's asking us for a username and a password, and the username is Beef and the password is Beef as well. Once logged in, you'll see on the left, we'll see the browsers that we have access to. So we can see here we have the hooked browsers. So the online browsers are the browsers that we currently have access to, and the offline is the ones that we had access to. So at the moment, I can't run any commands on these browsers. I had access to these browsers before, but at the moment, I can't do anything on them. So what interests us is the online browsers. There's a number of methods to get browsers or targets hooked to Beef. So if we just get back to the terminal window, and if we have a look here, you can see that it's telling us the script that has to be executed on the target browser so that they get hooked to Beef. This is the script, and if you can find or think of any way to get this piece of code to be executed on the target computer, then that target will be hooked to Beef, and then you'll be able to run all types of commands on that computer. So you can use stuff that we already learned. So you can use DNS spoofing to spoof any request to any page, to a page containing the hook. Or you can do ARP poisoning and inject the hook code on its own into any page that the target person browses. And we'll have an example of that. We can inject this code into the browser, into the pages that the target person browses, and they'll be hooked to Beef without clicking on anything, so without having to send them anything. So we're going to be using the same command that we were doing before when we were injecting an alert dialog. So it's going to be man in the middle F. And then we're going to do inject. And we're going to do JSURL. And we're going to give it the URL where the hook is. So the hook is in HTTP. So same command that we always use, it's man in the middle F. We're doing ARP spoofing. We're given the gateway, we're given the target, we're given the interface, and we're using the inject plugin, and we're using a JSURL, so URL for a JavaScript, and the URL is the URL where the hook is stored. So I'm going to hit enter. Now I'm going to just browse something normal. I'm just going to go to bing.com. If we go back to our Beef, you'll see that we have a target, and that target is the Windows device. So the code has been automatically injected into bing.com. So the user didn't have to visit anything or click any URL, any web page that they're going to visit. They'll actually, the code will be injected into that page and they'll get hooked. So the user will basically get hooked as soon as they browse any website. So if we go to the page source, if you look at the bottom here, you'll see that we have the hook script right here have been injected at the bottom of the page source. That's why it's been executed. So now that we have our browser or target hooked, we can go on the commands and start executing commands on that target. You can use the search to filter you're looking for a certain command if you know what you're looking for, or you can use the categories and look for commands suitable to what you want to do on the target computer. Some of these commands are information gathering commands, some of them are social engineering, some of them will even give you full control over the target computer. There's a lot of commands, so I won't be able to go over all of them, but I'll be showing you examples of simple ones so you know how to experiment and run the other commands. So we're starting, if you go in the browser, you'll see commands related to stuff that you can do inside the browser. So you can see things that will allow you to, for example, get a screenshot. You'll be able to try and gain and turn on the webcam and see if it works, and basically open the webcam on the target. You can gather information. If you go here on the exploits, you'll see a number of exploits that you can run. Again, depending on what's running on the target computer, you can run them. All you have to do is just click on the module that you want to run and click on execute. Sometimes some modules need to send some options to be set up, and we'll have examples of that as well. In the social engineering, again, there's some really cool stuff that you can do. You can show fake updates, fake notification bars, and stuff like that. So let's have an example of a very simple command. So again, we're going to do just an alert to show an alert box. So I'm just using the search to filter, and you can see here this will just create an alert dialog, and it's going to say beef alert dialog. You can modify this and type in anything you want. For example, I'm going to type in test, and then when you hit execute, go on the target, and you'll see that the target got a message saying test. So this has been injected into the target browser. Another really good plugin is a plugin. It's a redirect plugin, and it'll basically allow you to redirect the browser to any web page you want. This could be very useful because you can use it to redirect the target person and tell them that they need to download an update, and instead of giving them an update, give them a backdoor. You can redirect them to a fake login page, for example, for Facebook. You can really do anything you want with this. So you can set the website that you want the target to be redirected to, and we're going to redirect them to Beef Project in this example. And once you hit execute, as you can see here, they're redirected to Beef Project. Now let's have a look on a social engineering plugin that will allow us to steal usernames and passwords for accounts. So basically the way this works is it'll dim the screen and it'll tell the person that you got logged out of your session, so please log in to your account again so you can get authenticated. So this will allow us to bypass HTTPS, HSTS, all the security that's used by the target account page. For example, if you're trying to get username and password for Facebook, then you'll be able to bypass all the security that Facebook uses, because what you're doing is you're actually just showing a fake Facebook page. So the user will never actually get in contact with Facebook. So let's just click on this, and you'll see that you can click from here. You can click what account that you want to hijack. So let's say we're going with Facebook, and you can select what the backlight will be. So we're just leaving that at gray, and we're going to execute this. And when we go to our target, you'll see that they're being told that they got logged out of their session. So please log in with your username and password. So I'm going to put my username as Zaid. Then I'm going to put my password as 123456. Hit enter. And if we go back here, you'll see that we got our username was Zaid and the password was 123456. So again, this is a really good way of gaining access to accounts, because even if the user is not planning on logging into the account that you're trying to steal, then you'll kind of force them to enter their username and password to get to be logged back into their account, and then you'll be able to capture the username and the password. Now this was a very basic look on Beef. There's more methods to hook targets to Beef other than ARP poisoning. There is also a lot more attacks that you can do with Beef. There's attacks that would give you full control over the target computer, but I won't be going over them because they're really outside network penetration testing. If you're interested into learning more about gaining access and exploiting target computers, then I suggest you have a look on my general ethical hacking course, in which I explain a large number of methods that will allow you to gain full control over computers.
In this video, we're gonna cover how to use man-in-the-middle F against a real network. Man-in-the-middle F can be used against real networks exactly the same way that we were using it against virtual networks. The only difference is you want to make sure that you specify the right IPs, the right interface, and connect to the same network that the target person is connected to. I'd also like to go over a few points that might prevent man-in-the-middle F from working properly. So the first thing that I'm gonna do now is just do ifconfig to show you my configuration. And as you can see, I only have ETH0 right here, and it's connected to my NAT network because I configured my Kali machine to use a NAT network right here. So first of all, the first thing that you want to do before you target a real network is make sure that that's the only network that Kali is connected to. So the first thing that I'm going to do is I'm going to disconnect myself from this network. This is very important, and it's actually the main thing that seems to be interfering with man-in-the-middle F. So the attack might work, but you will have DNS issues, or the target machine will experience very slow internet connection, or they'll lose their internet connection completely. So the first thing we're going to do is we're going to disconnect from this virtual network. So we're going to go to devices, we're going to go to network, and see the check right here? That means we're connected to the network because it connects the network adapter. So I'm going to click that, and that's going to disconnect me from the NAT network. So if I do ifconfig now, you'll see that ETH0 is not connected to anything right now. So I'm literally offline in the Kali machine. I can't even ping anything. As you can see, I can't even ping Google. The next thing that we need to do is connect to the same network that the target machine is connected to. And in this video right here, I'm going to be targeting this Mac machine. So it's a real computer, it's a real physical computer connected to a real physical Wi-Fi network. And the name of the network is UPC 0460916. So this is the network that I need to connect my Kali machine to so that I can attack this computer. As we mentioned before, you can't use the internal wireless card inside VirtualBox, inside virtual machines. So to connect to a Wi-Fi network, we're going to need to use an external wireless adapter. I'm going to connect my wireless adapter right now through a USB port. And then I'm going to go to devices, USB, and connect my wireless card. That's the name of it, Atheros. Now if I do ifconfig, you'll see that I have a new interface, and it's called LAN 0, and this is my wireless card. But as you can see now, this wireless card is not connected to any network. So to attack our Mac OS machine, as I said, we need to connect to the same network that it's connected to. And to do that, I'm going to go click on this arrow. I'm going to go to Wi-Fi. I'm going to go to select network. I'm going to connect to the same network that the Mac is connected to. And I'm going to put the password. Now that I'm connected, if I do ifconfig, you'll see that LAN 0 has an IP address. And notice that the first three parts of the IP address here are the same as the first three parts of the IP address in Mac OS. So if I do ifconfig here, note that the first three parts here are the same as the first three parts here. And that basically means that these two wireless cards are on the same subnet, on the same network. And now I can use LAN 0 to target this computer right here. So if we do ARPA here, notice the MAC address now. This is the right MAC address of the router.
And when we run man in the middle F, this should change to the attacker's MAC address. So let's run man in the middle F exactly the same way that we used to do before. So we're going to do man in the middle F. We're going to do ARP spoof. We're going to give it the interface. And this time we're targeting a real computer, we're targeting a real network, and LAN 0 is connected to that network. So we're going to use LAN 0 for the interface instead of ETH 0. Then I'm going to set the gateway, and that's usually the first IP in the subnet. So it'll be 192.168.0.1. And then I'm going to specify my target, which is the Mac machine, and it had an IP of 192.168.0.19. So again, it's exactly the same command that we did before. The only difference is we're using different arguments. We're using LAN 0 because LAN 0 is the wireless card that's connected to the target network. We're using the gateway, which is the first IP of the same IP that we have. And then we're using the target, which is this Mac machine, and we've seen it to be 192.168.0.19. I'm going to hit enter and come back here. Now, as you can see, the old MAC address of the router used to be this. Now, if we do ARPA, the MAC address should change to the Kali MAC address. But as you can see now, in this case, it still didn't change. And the reason for this is because we're actually targeting a physical computer in a physical network. So this could actually take up to 1.5 minutes for the changes to reflect. So just give it some time and then check the MAC address again. I'm also gonna go and browse to a website just so that I'll generate some traffic on my computer, on the target computer, so that it'll go ahead and update its ARP table. Now let's check again. And as you can see now, the MAC address changed to the MAC address of the attacker's one. And if we go here, you'll see that man in the middle F is sniffing data and it's capturing data that's sent by my Mac OS. Now let's go to Hotmail and log in. Now I'm going to put the username as test@hotmail.com. And I'm going to put the password as 123456. And right here, as you can see, we managed to get the email, which is test@hotmail.com, and the password, which is 123456. And again, this worked against a real computer that's connected to a real network. So the main thing to keep in mind is make sure that you're connected to the same network as the target person. If that person is connected to a Wi-Fi network, then make sure you're using an external wireless adapter and you're not using bridged, you're not using NAT, you're literally connecting through the network manager of Kali Linux. So you need to attach the wireless card and then connect from here to the target network. Also keep in mind that you should disconnect the Kali machine from the NAT network if it was connected to one by going to Devices, Network, and then uncheck this option right here. Because we want to make sure that the Kali machine is isolated. It's not connected to any network other than the target network. So right now, if I do ifconfig, you'll see that ETH0 does not have any IP addresses. The only device that has an IP address and that's connected is LAN 0. Once you're done with all of that, and if you wanted to go back to using your NAT network to target other virtual machines, or if you just wanted to get your internet connection through the host machine, so if you wanted to use the NAT network again, all you have to do is just go to Devices again, go to Network, and click on Connect Network Adapter. That'll again connect your ETH0 to the NAT network and it'll allow you to use it as you were using it before. So if I do ifconfig now, you'll see that ETH0 has an IP address and it's connected again to the NAT network. In this lecture, we're going to talk about a tool called Wireshark. Wireshark is a network protocol analyzer. It's not designed for hackers and it's not designed for hacking and spying on other people on the network.
It's designed for network administrators so that they can see what's happening in their network and make sure that everything is working properly and that nobody's doing anything bad or doing anything suspicious on the network. The way that Wireshark works is it allows you to select an interface and then logs all the packets or all the traffic that flows through that interface. So you're selecting an interface. It could be a wireless card, it could be a wired card on your current computer, and then it'll start logging all the information that flow through that interface. It also has a really nice graphical interface that allow you to analyze this traffic. So it allows you to filter these packets based on the protocol using them, like HTTP, TCP, and all that. It also allows you to look for certain things. For example, if you're looking for cookies or if you're looking for posts or GET requests. And it also allows you to search through these packets. You can search through the information that's stored in the packets and find the things that you're looking for. It's a really, really big tool, and you need a whole course for it. So in this course, we're actually going to use it in a few lectures, just covering the basics or the things that's related to us. So the main idea here is Wireshark is not a hacking tool. It only allows you to capture the traffic that flows through your own computer, through your own interface. I'm going to use it now and it's going to become more clear to you. So I'm just going to go to Kali and we're going to start Wireshark. You can run Wireshark from the command prompt, or you can just go on all applications and type Wireshark and it'll show up right here. I'm going to click that and that's going to load the program for me. This is just a normal error. Just ignore this error. And this is the main interface of Wireshark. So first of all, you can actually just go to the file and go to the open, and in here it'll allow you to open a file that you've already captured. So for example, if you captured packets using a different sniffer, using Airodump or using man-in-the-middle-F or using T-Shark, which is the command prompt part of Wireshark. So if you captured packets using any of these programs and you stored it in a file, you can just come in here, open it, and start analyzing that file. This is really handy because sometimes you don't really want to analyze the traffic on the fly. So sometimes you just want to capture it. Sometimes you're capturing from small laptop, or you're capturing from your phone, and you're not even at home, you're in somewhere else doing your pen test, and then you go back home and then you want to analyze what you captured, then you can store that in a file and then just come here, go to the file open, and open the file that you want to analyze. So what I want to show you here is the idea that Wireshark is not a hacking tool. It's not going to capture things happening in another device. It will only capture things that flow through your own interface. So right here we can see that we have all the interfaces in my computer. So we can see that we have ETH0, we have any, which is just any, and we have all the other ones that some of them are created by VirtualBox. So the main one here is ETH0, which is the virtual interface connected to my NAT network. And you can see that there is no traffic flowing through this. So you can see that this is constant and nothing's happening. So what I'm going to do now is I'm just going to make this a little bit smaller. And I'm going to open my browser here. And I'm just going to go to a normal website. I'm just going to go to google.com. Now, as you can see right here, you can see the traffic in ETH0 is spiking up. So there was some traffic generated through ETH0. So if we're sniffing on this, we'll be able to capture these packets that were sent over ETH0. Now, what I'm going to do is I'm going to go to my Windows machine just to prove that point. And I'm going to browse the website here, and you'll see that ETH0 will not be affected, and the traffic that's generated on this Windows machine, which is in the same network as the Kali machine, it will not be captured by the Kali machine. So if I just go to Google again here, you'll see that nothing happened in ETH0. So there is no traffic flowing through this. It's still constant, and we can only capture packets that go through ETH0. So now you'll probably ask then why Wireshark is so useful. Why are we even talking about it if we can only see things that go through our own computer? Why are we talking about it? Well, we're talking about it because we've seen there is a large number of ways that you can become the man in the middle. Now, we talked about two methods to become the man in the middle. We talked about doing that using ARP spoofing,
And if we create a fake access point, then we'll naturally be the man in the middle because all the requests will be sent to our computer. So when we are the man in the middle, if we start sniffing on the interface that's used to become the man in the middle, we'll be able to capture all the traffic generated by the people that we're targeting in our man in the middle attack. So if you started a fake access point, you can start sniffing on the interface that's broadcasting the signal, and you can capture all the packets sent or received to anyone who's connected to that fake access point. If you became the man in the middle using ARP spoofing, then just select the interface that you used when you launched your ARP spoofing attack. So I'm going to do this with ARP spoofing because it's quicker and easier than generating a fake access point. But again, this works in both ways. And it even works if you manage to become the man in the middle using a different method. Just make sure you select the interface that's used to launch that attack. So I'm going to do ARP spoofing. Now you can do this using ARP spoof, or you can do it using man in the middle F. So I'm just going to do it using man in the middle F. And I'm going to go and just get the IP address of this computer. So it's 10.20.14.206. So our command is going to be man in the middle F, ARP spoof, interface, which is going to be ETH0. Then we're going to specify the gateway, 10.20.14.1. And then the target, which is 10.20.14.206. So we did this command before. This will just put me as the man in the middle. It'll redirect the traffic from the computer that has the IP that's 10.20.14.206 to my computer, placing me the man in the middle. So I'm just going to run this attack quickly. Now let's go to the Windows machine and see if I do anything here, if it's going to affect the traffic in ETH0. So we'll see if Wireshark will be able to capture traffic generated by this computer. So let's write anything here. I'm just going to Google, or I'm just going to go to a different website. I'm just going to go to Bing. And if we come back here, you'll see that we have traffic being generated here. And we can see that ETH0 is actually capturing whatever that's happening in a completely different device, in a device that's not even connected to our network. This is happening because when we are the man in the middle, all the packets that's generated by the Windows device is actually being redirected to my own computer right here, to the Kali. And then Wireshark is sniffing that from the Kali machine. It's sniffing it from my own local machine. It's not sniffing it from the network. It's not sniffing it from the target computer. It's only listening on my current interface, which is ETH0, and it can capture packets that's flowing through ETH0 because man in the middle has redirected, man in the middle F has redirected the traffic of the Windows machine to flow through my computer. So again, if you're doing this with the fake access point, then just listen on the interface that you're broadcasting. If you're doing this with a real wireless network, if you're connected to your home wireless network using LAN 0, then you can just do this with LAN 0. But with ARP spoofing, you have to first redirect the traffic, then you can use Wireshark. Now this is just to show you what Wireshark is and how it works, and I just wanted to stress the idea that Wireshark is not a hacking tool. It's only a program that allows you to log packets flowing through a certain interface and then analyze these packets. So in the next video, we'll see how we can sniff and analyze packets using Wireshark. In the previous video, we seen how we can launch Wireshark, and we said that we can actually just open a file that contains packets that we already captured, and we can start analyzing them using Wireshark. In this video, I want to start sniffing packets and then generate some traffic in my Windows machine, and then we'll see how we can analyze these packets using Wireshark. So I'm already the man in the middle. As I said, you first have to be the man in the middle to use Wireshark. And then the traffic that's generated in the Windows machine is actually flowing through ETH0, as we've seen in the previous video. So before I start capturing the packets, I want to go to the options, and I just want to show you what options we can set. So first, you can see all the interfaces that you have, and you can see the traffic generated on them. And you can see ETH0 is actually generating some traffic every now and then because it's actually coming from the Windows machine, which is already in here. And now anything that we do in here, for example, if we search for anything, you'll see there's a spike coming up here because the traffic is flowing through this. So in here you can select the interfaces that you want to start capturing on, and you can actually select more than one interface, and all you have to do is just hold the control and then click other interfaces that you want to listen on. For example, we can just click them like this. But for now, I actually only want to sniff on ETH0. Now, if we go on the output, you'll see that you have an option to store these packets somewhere. So again, if you only want to sniff and you don't want to analyze things, then you can just go on the browse and you can store the packets that you're gonna sniff somewhere, and then you can analyze them whenever you have the time at a different time. You can just open them with Wireshark like I showed you in the previous video. You can just go on File, Open, and then open the packets and start analyzing them. Now, I have ETH0 selected, and I'm just gonna click on Start. And that will start capturing packets. Anything that's going to flow through ETH0 will be captured and it will be displayed in here. Anything. I mean images, pictures, messages, cookies, anything that computer does on the internet will flow through ETH0 and therefore will be captured by Wireshark. So it's not like Man in the Middle Life where it was only showing us the important information. Right here, you'll see anything, all the traffic that's generated. So let's first of all generate some traffic here. So we've already generated this, but this wasn't captured. So let's look for something. So for example, let's look for a car. We're just going to look for a car called GTR. Maybe we go on images. You can see some nice pictures. Maybe we open one of them. Now let's go back to Bing. And let's go to Dailymotion. Okay, now let's try to analyze the packets or the traffic that we generated. So I'm just going to stop this. Now this is the main interface of Wireshark. And you can see that the first thing we have is each one record of this is a packet. Now you'll see here the columns. First of all, here is the number of the packet. So you have this one is number 1, number 2, number 3, number 4. In the time, you'll see the time when this packet was captured. So 0 is when we first started sniffing, and then the time increases as we go down, and it shows when these packets were captured, when they were sent basically. You can also see the source. So this is the device that the packet was sent from. And you can see that this one is not sent from our target. It's actually coming from the internet, from a server that has this IP, and it's going to our target computer, which is 10.20.14.206. You can see the protocol, so it's TCP for this one. You can see that it's ICMP in this one, and you can see that it's ARP for this. You can see the length, which is the size, and you can also see info about this packet. Now you can also notice that these packets have different colors. Usually green is TCP packets, dark blue is DNS packets, and if we go down, we should actually be able to find some of them. And you can see all of these are DNS packets. Light blue usually is UDP, but we don't have any UDP packets at the moment. And you can also see that we have some black packets, and these are TCP packets that had a problem, that had issues. Now, if you double click any of these packets, it will display more information for you here. It's the same information that's being displayed in here in the bottom. So if we just bring that down a little bit, you can see right here, you have the frame, you have the Ethernet, the Internet Protocol, and the Transmission Control Protocol. And using that, you can just click on the arrow and then you'll see more information that's stored in here. Now again, if you just double click the packet, you'll get the exact same information and you'll be able to get information about the packet that you just selected. Now what we did on the target computer so far, most of the traffic that we generated was HTTP traffic. So to get rid of all this information that's hard for us to read, we're just going to type in here in the filters, we're just going to type in HTTP. Hit enter. And as you can see now, that filtered all the packets to HTTP traffic only. So for example, right here, you can see that we have a post request send from our target computer to
a server. We still don't know what that server is, but it's to a server on the internet. And when we double click that, we'll get more information about this packet. I'm going to make this smaller here. So in the frame, you can see the interface that's used. You can see information about the packet itself. In the Ethernet 2, you'll see information about the destination and the source, so you can see that the MAC address is used. In the Internet Protocol, you'll see information such as the geolocation of the target, so we can see that this packet is sent to the United States. In the transmission, you can see information about the ports used. What really interests us is the Hypertext Transfer Protocol, and this is where you really see the interesting information in our case. So in here, you can see that the request was sent to Bing.com, and you can see that this request was searching for www, and you can see that the content type was a text. So you can get this information about each packet that's sent. So you can see that Wireshark logs everything that happens. It doesn't only log, or it doesn't only show the interesting stuff, it literally logs everything. So it contains the interesting stuff plus much more. Now, if we go down, we can see that we have another post request. And if we double click that, it's probably going to be my second search, which is when I search for the GTR. And you can see here, I searched for a car and it's called GTR. So again, right here, we can see all the searches that we did. We can see all the URLs that the user entered so far. And if we go down, you'll be able to see all the other URLs that we visited. So you'll be able to see Google and Dailymotion as well. In this video, we'll see how to use more Wireshark filters and capture a username and a password. And also we'll see how to see the cookies of a person if they're already logged into a service and they didn't enter their username and password. So I'm going to start a new capture. I'm going to close this without saving. And I'm going to remove this filter from here. And I'm just going to go to Hotmail. And I'm going to log in with my username, which is zaid@hotmail.com. And then I'm going to put the password, which is going to be a random password, but it's going to be captured. So we're going to put 123456. Hit enter. And as you can see now, we managed to capture traffic. I'm going to stop this. And I'm going to look for HTTP. And we're going to look for post requests. So we can see here we have GET. These packets are sending GET requests. And we're going to look for something that's sending a post request. And you can see now this is the first one sending a post request. So it's being sent from the target computer to the server. So let's double click this and see what's inside it. And looking right here, you'll see that this was sent to login.live.com, but we can't see any username and passwords in this one. So I'm going to close it. And I'm going to look for the next post packet, which is this one. Again, double click it. And let's see what's inside it. Now, if we come here to the HTML form, you'll see that we have the login, which is zaid@hotmail.com. So this is what we entered. And you can also see the password, which was sent as 123456. So again, man in the middle F was doing this very easy for us, and it was showing us the information easily. It was filtering the important information for us. But right here, we can see that we can actually capture anything that's sent on the network, and we can see it using Wireshark. Another thing that you can do is you can actually search through these whole packets. So you can just go to Edit and then go to Find Packet. And right here you can select if you want to search in the packet list, which is just this, or in the packet details. So we're actually going to search in the packet details. We're going to keep this narrow and wide. And right here, I've set this to string, so you can actually put a display filter if you want, but I'm searching for a string, which is just a normal text. And if we search for Zaid,
it will actually go straight to the packet, this packet, which contains my username. And again, if we just look at it here, or we can double click it, whichever is easier for you, you can see that we managed to capture the username, which is zaid@hotmail.com. Now you can do find next, and you'll get the next one. Find next, and again, it'll find the next one, which actually had my password in it. So again, the search right here is really useful function that will allow you to navigate through all of these packets and find what you're looking for. Now let's start a new capture and see if we can actually capture the cookies. So I'm gonna again continue without saving. I'm gonna go to my Windows machine, and I'm gonna go to Dailymotion, which I already logged in before. And as you can see, it's not asking me to log in because I've already logged in, and it already has a name here. So I'm just gonna go to this channel. Now it's just a fake channel that I created just for this lecture. Now, if we go to our Wireshark right here and stop the capture and look for, instead of HTTP, we're going to look for http.cookie. So if we go down, you can see that right here the person got to their homepage, which is that's the username, the fake username that I had. Now if we go to the post request before that, and look at the hypertext, you can see the cookie that was sent to authenticate that person. So if you use, you can just download a plugin for your browser and inject these cookies into that browser. You'll be able to log in to that username, to that account, without using the password, the same way that the user entered. So this is the same that what we did with Ferret and Hamster. Again, I'm just doing this to show you that Wireshark can be used to do all of the attacks that we did before, plus much more, because basically it can capture anything that flows through our device. So any request sent or received to or from the target computers will be flowing through our interface, and then Wireshark will be capturing anything, regardless of whether it thinks it's important or not. It's going to capture everything. So it's a really, really handy and useful tool.
Now, from the previous lectures, we know once we connect to a network, it's game over, because once connected, we can run an ARP spoofing attack to redirect the flow of packets so that they go through our computer. This allows us to become the man in the middle, and once we're the man in the middle, we can run so many dangerous and effective attacks. So we can spy on all the users, steal their passwords, redirect them to different websites, and this is all just a small taste of what you can do. You'll actually see us build on this in the client-side attacks section, where we're going to completely hack into computers connected to the same network as us. And if you go and do my advanced network hacking course, then you'll see more advanced attacks that will allow us to do so many cool stuff on the network. And again, all of this is possible because once we connect, we can run ARP spoofing and become the man in the middle. Now in this section, I actually want to show you another method that will allow us to become the man in the middle. And once we're the man in the middle, we'll be able to run all of the attacks that you've seen so far and all of the other man in the middle attacks that you'll learn in the future. So let's go back to the first diagram that we learned in this course. When we were talking about how networks work in general, we said the only device that has access to the internet is the access point, and whenever a client wants to access something, they send the request to the access point goes to the internet, gets the response, and send it back to the client. Now, what if we replace this access point with our hacker computer? So what if we can use our machine to create a Wi-Fi network that actually has internet access, so people will actually try to come in and connect to our network to access the internet, and then when they connect to our network, by default, we will be the man in the middle because we are the router. so we won't really need to exploit anything. We are automatically the man in the middle, and the clients will automatically send us any requests because they want to access the internet, and we will see these requests, obviously, go to the internet, get them what they want, and give it back to them. This way, we'll be able to launch all of the attacks that I showed you previously without the need to exploit the ARP protocol, so without the need to run ARP spoofing. All we'll have to do once our network is running and we have clients connected, we can just start sniffing using Wireshark or using man-in-the-middle F. So, for this to work, you need a computer, and we already have our hacker computer with Kali Linux. You also need internet access, and you need a wireless device that's going to broadcast the Wi-Fi signal and tell all the neighboring devices that I am a network, you can come in and connect to me. So, you will need, first of all, an interface that has internet connection. This interface, it can be a Wi-Fi interface connected to the internet, it could be an Ethernet interface connected to an Ethernet network, it could be a 3G or a 4G dongle, and it even can be a virtual interface, and this is what I'm actually going to do. It's going to be my ETH0, the virtual interface that is connected to my NAT network. So this can be any network device as long as it has internet access. The next interface that you will need, like I said, it's gonna have to be a Wi-Fi interface because it needs to be able to broadcast the signal for the network. And you can't use any Wi-Fi interface. This interface needs to be able to act as an access point. So it needs to be capable of acting like a proper access point, like a router. Now, all of the Wi-Fi adapters that I recommend support this mode, and I've already included a video in the resources before when I first spoke about wireless adapters, but I'm also going to include this video in the resources of this lecture. So if you're going to buy one, or if you're not sure how to pick the right one, then check out this video. It should be helpful for you. So once we have this set up properly, we can use our computer to start an access point, and it's going to act exactly like a router. So people will be able to see the network when they look for Wi-Fi networks, they'll be able to connect to it and get internet connection. But when they connect, they will have to send us all of their requests because we are the router, we are the access point, so by default, we will be the man in the middle. Therefore, you'll be able to execute all man-in-the-middle attacks that you learned so far and any other man-in-the-middle attacks that you will learn in the future. So basically, ARP spoofing is one method of becoming the man in the middle, and what I'm going to show you right now is another method of becoming the man in the middle. Now, you can see that in order to use our computer as an access point, we need a number of components to be configured properly. So first of all, we need our wireless interface to broadcast the signal as if it's a real network. This will allow other clients to connect to it, but that's not the end of the road. The wireless interface needs to know when these clients are requesting websites. It needs to be able to forward these requests to the other interface that is connected to the internet. Then again, it will need to be able to know when the responses come back and forward all of this to the right client. Now you can configure all of these things manually, and I actually cover this in my advanced network hacking course, and I cover a lot of advanced things that you can do with the fake access point, like launching an evil twin attack, hacking into WPA2 Enterprise, and so on. But this would take at least 30 lectures, and this is not a network hacking course. This is a general ethical hacking course. Therefore, that would be out of the scope of this lecture. If you're interested in learning how to do this manually and how to run advanced attacks using the fake access point, then check out my advanced network hacking course in the bonus lecture the last lecture of this course. For now, for this course, I'm going to show you a great way of quickly creating a fake access point that will allow us to become the man in the middle, similar to what's shown in this diagram. The tool that we're going to use is called Mana Toolkit, and it's basically a set of tools that allow us to automatically create a fake access point, automatically sniff data, bypass HTTPS, and so on. So the tool comes with three main start scripts. So the first one, start now upstream, will allow us to start a fake access point with no internet access. So this is not really useful for us, and I will not use this in this lecture. The next one is start not simple. This will start a fake access point with internet access. The third one, start not full, will start a fake access point with internet access, and it will automatically start sniffing data and bypass HTTPS. Now I actually always use start not simple. I never use start not full because this fails a lot of the times, and we already learned how to start sniffing and bypass HTTPS using man in the middle F. So you can always start not simple. This will start a fake access point for you with internet access, and then you can open another terminal window, use man in the middle F exactly as I showed you before, and you'll be able to sniff data and bypass HTTPS. You can also use Wireshark if you want to sniff the data and analyze them, again exactly as shown before. Now in the next lecture, I'm going to show you how to use Mana Toolkit to create a fake access point with internet connection. Now before doing anything, I want to show you the network settings of my Kali machine. So I'm going to select it here. I'm going to go to Settings, Network, and as you can see, it's set to use a NAT network. So now if I go to my Kali machine and do ifconfig, we'll see we have an interface called ETH0. This interface is a virtual interface created by VirtualBox because we set this machine to use a NAT network. You can also see that this interface has an IP address, which means that it is properly connected to this NAT network, and it will provide the Kali machine with internet access as long as my host machine right here has internet access. So now on my Kali, if I go and let's say if I just go to bing.com on my browser, you'll see that I can successfully go to the website because Kali is connected to the internet through this virtual interface that is called ETH0. Now, if we go back to our diagram that shows what we need to create an access point, you can see that we need an interface that is connected to the internet. We don't care what type of interface this is, as long as this interface has internet access. So in our example, we're going to be using ETH0 to provide our fake access point with internet access. The other interface that we need, we said that this needs to be a wireless adapter that is able to act as an access point. Again, if I go back to the result of my ifconfig, you can see I already have a wireless adapter connected to this computer. It's called LAN 0. Keep in mind that this is in managed mode. It's not in monitor mode, and it is not connected to anything. So you can see it does not have an IP address. This is very, very important. It needs to be, first of all, in managed mode, and second, not connected to any network. So even if we go at the network manager in here, you can see we have wired connected. This is my ETH0, and Wi-Fi not connected. Once we have everything configured properly, we can go ahead and start the access point. But first, you'll need to install Mana Toolkit because it does not come pre-installed in Kali.
We can install it using apt-get, just like Terminator and other tools. So all we have to do is just do apt-get update to update the sources. Then apt-get install Mana Toolkit. Now I have it installed, that's why it's telling me Mana is already installed. But if it's not installed, this command will install it for you. Once you have everything installed, you're ready to use Mana, and before we started, we should modify its settings. Mana's settings are stored in a text file. So to edit the settings, we're going to open this file and edit it using LeafPad, which is just a text editor. So I'm going to type LeafPad, followed by the location of the file that we want to modify. And the settings file for Mana is stored in etc mana toolkit hostapd mana.conf. So all we're doing with this command is we're using a text editor called LeafPad to open a file that is stored in this path. So when we hit enter, you'll see we have the text editor here opening the file for us. And all of these are the settings that you can modify for Mana. You can actually get a full list and a full description of all the settings that you can modify in this link. But we don't need this for now. The main thing that you need to modify is the interface. This is the interface that you want to use to broadcast the signal. So basically it is this component, and in my example this is going to be LAN 0. This is my wireless interface. So I'm keeping this the same. The next thing that you might want to modify is the SSID. This is the network name that will appear when people look for Wi-Fi networks. I'm going to keep this as internet, so when people look for networks, they will see my fake access point under this name. So I have nothing to save right now, but if you modified anything, make sure you save the file from File Save and then close it. And the next file that we'll need to modify is the start script. This is the file that will actually start Mana Toolkit for us. Again, we're going to use LeafPad to open and edit this file. So we're going to type LeafPad followed by the location of Mana's start script, which is in user share Mana Toolkit run Mana start not simple.sh. Now in this file, there are two main things that you need to modify. The first one is the upstream interface. This is the interface that has internet access. So this is this component right here. And as we've seen before, this is ETH0 in my case. So I'm going to leave this the same. The next one, the PHY, is again the interface that is gonna broadcast the signal. So in my example, this is my wireless adapter and it is called LAN 0, not LAN 1. So I'm actually gonna modify this to LAN 0. Then I'm gonna save it, Control S, and quit it, Control Q. And that's it. We're ready to start the fake access point. And like we said before, we're going to be starting it using this script right here, the start not simple. That's why we modified it. So all we have to do is I'm going to copy this because that's its location. So in order to start it, because this ends with a .sh, we're going to do bash followed by the location of the script. So when we wanted to modify it using a text editor, we used a program called LeafPad followed by the path of the file. Right now, we don't want to modify it. We want to execute the code inside it. The code inside it is a bash script code. That's why we're saying I want to run this file using bash. Now I'm going to hit enter. And as you can see, it's telling me that the access point is enabled and I can press enter to kill the access point, so to exit it. Now, sometimes the first time that you run this script, it will not work. It will actually give you an error. So it's a good idea to actually just run the code again, literally the same command. If it fails, if it complains about a specific error, just run the command again and it might work. If it didn't work for the second time, then ask me in the Q&A section and we will respond to you and help you fix this issue. So now let's go and try to connect to this network and see if it actually works. So right here I have a Windows machine. It's another virtual machine, but I have another wireless adapter connected to this machine. Do not test this from your host machine because the fake access point is getting its internet access from the host machine through the NAT network. So if you test this network from the host machine, the network will not work. So either test it from another virtual machine with another wireless adapter, or if you don't have another wireless adapter, then you can test it from your phone or from another laptop or any other computer within range. But do not ever test it from the host machine. So right here, I'm going to search for networks to connect to. And as you can see, I have a network called Internet. It does not use a password, so I'm just going to connect to it. As you can see, I'm connected now, and I'm going to open Firefox just to check if I have internet connection. So I'm going to go to bing.com. And as you can see, bing.com is loading, so now I actually have internet access. So now anything I do on this computer will have to be sent to the access point. If I want to access any websites, if I enter any passwords and usernames, everything is gonna go to the access point. And the access point is the hacker machine, so the hacker machine is already the man in the middle. So now you're at the same position that you would be after running an ARP spoofing attack. So you can go ahead and use Wireshark to sniff packets and analyze them, or you can go and use man-in-the-middle F exactly as I showed you before. The only thing that you need to keep in mind when using Wireshark or man-in-the-middle F or any other tool, you need to set the interface to the interface that is broadcasting the signal. So this is the interface that you set in the PHY option, not in the upstream. So in my case right now, this would be LAN 0, not ETH 0. Also, if you're going to use man-in-the-middle F, theoretically, you wouldn't need to use the --ARP --spoof argument, but I noticed that the tool will not work unless you add that argument, so you can add it in and you'll see that it'll work exactly as shown before.
In this lecture, we're gonna learn how to generate an undetectable backdoor. A backdoor is just a file that when executed on the target computer, it'll give us full access to that computer. So it'll basically allow us to hack it and do anything that we want on that computer. There's a number of ways to generate backdoors, and what we're interested in is to generate a backdoor that is not detectable by antivirus programs. Now, this is not very hard to achieve, as you'll see, and we're gonna do this using a tool called Vil Framework.
Now, I already have Vil's project page open in here. I'm going to include its link in the resources of this lecture on the top left. Now, if you're not familiar with Git, this is a version control system that allows programmers to host, share, and update their programs. So, to download something from GitHub, all you have to do is click on the green button in here, copy this link, and then go to Terminal, navigate to the location where you want to download this project, and in this example, I want to go to OPT. This is the directory where you should be installing optional software, and if I do ls, you will see I only have one directory in here called teeth. So, to download Vil in here, all you have to do is, first of all, write the git command, which is git. And what we want to do is we want to clone a repository. And the link for this repository is the link that we copied in here from the green button. So I'm just gonna paste it here. So a very simple command. We're using git to download a repository from Git. We're saying that I want to clone this repository, and the link of the repository that I want to clone is this one. So if I hit enter now, you'll see it's gonna download it for me. And once it's done, if we do ls, you'll see we have a new directory called vil, and we can navigate to this directory by doing cd vil. And in here, if I list, you'll see we have a number of files, but the main file for the program is this one, vil.py. But we can't run this file right now because we still didn't install this tool. Now, vil relies on a large number of libraries and third-party programs, so you're gonna have to install all of these first before you can use it. Now, luckily, you don't have to do this manually because vil comes with an installation script. Now, this script is placed in the config directory, so we have to navigate in this directory first. So we'll do cd config, and if we list here, you'll see we have a file called setup.sh. Now, as the name suggests, if you run this file, it will install all the needed libraries and third-party applications that vil uses. So, to run an sh or a bash file from the terminal, all you have to do is type // followed by the file name, and in our case, it's called setup.sh. Now, you can run the setup as is like this, but I want to add two arguments to this. The first argument that I want to add is the -- silent. This argument will run the installer as an unattended installer. So basically, it'll install everything with its default settings, and it won't ask us to configure anything. The next argument that I want to add is the -- force, so that in case you're running this a second time, if you already installed vil and something went wrong and you're installing it again, the force argument will overwrite any existing installations. Now, I didn't just figure out these arguments myself. If you actually read the description here on the project page, you'll learn exactly how to install it and what each of these arguments do. So, I'm going to hit enter now. And as you can see now, it's going to automatically gather information about my current operating system. It's going to install the needed libraries and the needed applications. This might take some time because it's going to download a lot of packages, so please be patient and give it its time. Now I'm going to pause the video because this is going to take some time, and I'll continue recording once it's done. So, right now, as you can see, the installation is finished and it's telling me that everything is done. So, I can run the tool now, but what I'm actually going to do is I'm going to first close this terminal window and open a new window just to show you how you'd start it by default. Because usually when you open terminal, you'll actually be in the root directory. So if I do pwd right now, you'll see I am in root. So in order to run vil, we have to first navigate to the location where you downloaded it. And we downloaded it to the opt directory, so we're going to do cd opt vil. Now if we do ls, you'll see we have the file that I told you that's the file for the program, and we have the config directory where we were and where we ran the installer. Now we've already installed everything, so we don't need to run the installer, and to run vil, all we have to do is type // followed by the program name, which is vil.py. I'm gonna hit enter, and as you can see, the program is working with no issues at all. Now, in the next lectures, I'm going to show you how to use this program to generate undetectable backdoors that can be used to hack Windows computers.
Okay, now that we have vil loaded, you can see it shows us the main commands that you can use with vil. So the first command is you can do exit to exit. You can do info to get information about a specific tool. You can do list to list the available tools. You can do update to update vil, and this is very, very important because you always want to be up to date when it comes to bypassing antivirus programs. And then you can do use to use a tool. Now, let's start using vil evasion, and as we do it, it's going to become so easy and you'll be able to understand it more. Now, vil has two main tools, and if we do a list, you'll be able to see them. So we have the first one, which is the one that we're interested in, which is called evasion, and that's the one that generates undetectable backdoors for us. And then there's the second one, which is called ordnance, and this tool generates the payloads that's used by evasion. So you can look at this as a helper or a secondary tool. Now, what I mean by a payload is the part of the code of the backdoor that does the stuff that we want, that does the evil stuff, if you want to say. So it's the part of the code that gives us a reverse connection. It's the part of the code that download and execute something on the target computer. It's the part of the code that allow us to achieve what we want by executing that file. And this is going to become more clear as we start using vil. Now, for now, we're interested into using evasion. So we're going to do use 1 because that's the first tool. That's number 1. And as you can see, we have vil evasion loaded now. And as I said before, this used to be a standalone tool that you just downloaded on its own, but now they have it all combined together. Now, as you can see, the first thing that we get when we load vil evasion is the commands that you can run on this tool. So the first thing that we want to do is we want to list to see all the available payloads. And as you can see, we have 41 different payloads. And all of these payloads follow a certain naming pattern. And you can see, for example, let's take this example right here because that's the payload that I'm going to be using. You can see the payload is divided into 3 parts. The first part right here refers to the programming language that's the payload is going to be wrapped in. So we have the evil code, and then the evil code is going to be wrapped into a certain programming language that the target computer understands. And right here you can see that this payload uses Go programming language. We can see this one uses C. We can see these ones use CS. We have Python, we have PowerShell, and we have Ruby if we scroll down. The second part of the payload is really important. This is the type of the payload, the type of the code that's going to be executed on the target computer. In this example, we're using Meterpreter, which is a payload designed by Metasploit. Metasploit is a huge framework for hacking and it allows you to do a lot of things. But in this lecture, we're focusing on creating a payload called Meterpreter. And what's really cool about Meterpreter is it runs in the memory and it allows us to migrate between system processes. So we can have the payload or the backdoor running from a normal process like Explorer, for example, and this payload will allow us to gain full control over the target computer. So we'll be able to navigate through the file system, download, upload files, turn on the mic, turn on the webcam, even use that computer to hack other computers, install a keylogger. You can literally do anything you can think of. And all of this will be running from the memory from a normal process on the system. So it's very hard to detect and it doesn't leave a lot of footprints. That's why it's a really, really cool payload and we'll be using it a lot. The third part of the name is the method that's going to be used to establish the connection. So in here you can see that this is called rev HTTPS. So rev stands for reverse and HTTPS is the protocol that's going to be used to establish the connection. So we can see that this payload will create a reverse HTTPS connection. You can see this one right here, for example, it creates a reverse HTTP connection. And we have this one in here that creates a reverse TCP connection. Now, what I mean by reverse is the connection is going to come from the target computer to my own computer. So I won't be connecting to the computer that I want to hack. What's going to happen is once the person double clicks the backdoor will connect back to me from the target computer. What's cool about this is I'll be able to bypass antivirus programs because the connection is not going to the target computer, it's coming back to my computer. So it's literally as if the target person is just connecting to a normal website. I'm going to use a port that websites use, which is 80 or 8080. So again, if the person analyzes the connection, it'll look as if they're literally just connecting to a normal website. Also, if the target computer is hidden behind a router or behind a network, again, this is gonna work because the connection is coming from the target computer to me instead of me connecting to the target computer. So using a reverse connection is really handy, and I think this is really the only practical way of gaining access to a computer, because there is a lot of things that can stop you from connecting to a certain computer. Now, this is the general naming pattern. You'll see some payloads like this one right here, which doesn't follow that general naming pattern. And basically what these payloads do, for example, you can see this one is called shellcode inject. So what it's going to do is it's going to create a payload that injects your other payload. So it's going to create a normal payload, and that normal payload injects an interpreter payload, for example. Now it does this to try to bypass more security, but usually they won't bypass more things than the normal payloads would bypass. So that's why I usually just use one of the normal payloads in here. So this is it. This is all about the payloads. Sorry I took a bit of time, but I wanted to make sure that you guys understand the naming pattern. I wanted you to understand what a payload is and the difference between a reverse and a bind and a TCP payload. This way, the rest of the course will become more clear to you, and I can just use the payload that I want without explaining what it is. Now, in the next lecture, we're going to be generating a payload, and we'll be testing it against antivirus programs. Okay, so in this video, we're going to be using Vil to create a backdoor. So the first thing I'm going to do is I'm going to do list to list the available tools, and I'm going to use number 1 because we want to use evasion. And then I'm going to list my payloads. And like I said in the previous lecture, I want to use Go Meterpreter Reverse HTTPS. So that's number 15. So I'm going to do use 15. And that's going to list first of all, it's going to show me information about this particular payload. And then it'll show me the options that I can set for this payload. So the main option that you want to set, and the most important one, is the IP address. So this is the IP address which you're going to be receiving the connections on. As we said, we're going to have a reverse connection, and we need to set the IP address which the payload or the backdoor will try to connect back to. And in our case, we want to receive the connection back to this Kali machine. So we're going to set the IP lhost to the IP address of the current Kali machine. Now, to get the IP of my Kali machine, I have to run ifconfig. So I'm going to split the screen by doing right click and click on split horizontally. And I'm just going to bring this down a bit. And we're going to run ifconfig. Now you can see the IP address in here is 10.20.14.213. This is the IP of my Kali machine. This is the IP of the machine that I'm using as the attacking machine. So this is where I want the connection to come back to, so I can hack the target computer once the backdoor is executed. So I'm going to set lhost to 10.20.14.213. So you can set any of these options using the set command. So all you have to do is write set followed by the option that you want to change. So in this case, we want to change the lhost, and we want to change that to 10.20.14.213. Now, the L port is set to 80, which is really good because that's the port that's used by web servers. So as I said, the connection will look as if the target person is connecting to a website, and it's not going to be suspicious. But I don't want to use that port because I'll have a web server running on this, and we'll talk about that later. So I'm going to change that to 8080. 8080 is another port that's used by web servers, so it's still not suspicious, and it should still bypass firewalls. So I'm just going to do set. Same way that we did it before with the lhost, we're going to do lport. to the value that we want to set this option to, and we're going to set it to 8080. Now, if I do options again to list all the options, you'll see that the L host changed to 10.20.14.2.13 and the L port changed to 8080. Now, if you generate the backdoor like this, you will bypass all antivirus programs except AVG. I've already tried this, that's how I know this, and that's not good enough because we want to bypass everything. Now, the way antivirus programs work is they have a very large database of signatures. These signatures correspond to files that contain harmful code. So what they do is they compare the signature of your file, of your backdoor, to all the files in this huge database. If your file matches any of these files, then they'll flag it as a virus or as malware. If it doesn't, then they'll think that it's a normal file and it's not malware. So the main point in here is we're going to try to modify the file, our backdoor, as much as possible to make it more unique so that it bypasses the signature database and will be able to bypass antivirus programs. Now, as I said, Vil is already doing that for us. It's encrypting the backdoor, it's obfuscating it, it's injecting it in the memory so that it doesn't get detected, and it's doing a good job at it. It's bypassing pretty much everything except for only one antivirus program. So just to bypass this last antivirus program, I'm gonna set some optional options that really won't do much of a difference. They'll just make the backdoor look a bit different. So the first thing that I'm gonna modify is processors. And that's the minimum number of processors to be used by the backdoor. I'm not gonna set a huge number because that'll just make my backdoor not work. I'm just gonna set it to 1, which is pretty much nothing really, but I'm just gonna set this option to make the code look a bit different. So I'm gonna do set. Again, the same way that we are setting the L port and the L host, we're just gonna put the option name, which is processors. And we're gonna set that to number 1. And I'm also going to set another option, which is the sleep option. And that basically lets the backdoor sleep for a number of seconds that you set before it executes the evil code that you have in there, before it executes the payload. So I'm going to set this to 6. Again, no real reason for this. I'm only doing this to make the backdoor look a bit different. So I'm going to do set sleep to 6. So I'm going to hit enter. And I'm going to do options again to make sure that all the options are set the way I want them to be. So I have my IP address set properly, I have my L port, I have my processors, and I have my sleep. So I'm going to generate the backdoor. And now it's asking me to name this backdoor something. So I'm going to name this backdoor rev https 8080. Just so that we can remember which payload and which port to use for this backdoor in the future. Now the backdoor is generated, and you can see it's telling us the module that's used, and it's telling us where the backdoor is stored. So the backdoor is stored in this path right here. So I'm gonna copy that. Let's go ahead and check to see if the backdoor is detected by any antivirus programs. Now you can use the built-in feature by Vil using the check VT command, but this feature only uses the signature of the file and it's not 100% accurate. Sometimes it tells you that the file will bypass all antiviruses, but it'll actually be detected. You can also use VirusTotal, but I don't recommend that, and please don't do that, because if you do that, your backdoor will become less effective, because VirusTotal share the results of their scans with antivirus programs. What we're going to do is we're going to use a website called NoDistribute. So we're going to go to it now. So I'm just going to Google for NoDistribute. And what this is going to do, it's similar to VirusTotal. The only difference is it's not going to share the scan results with antivirus programs, so it won't affect your backdoor. So I'm going to click on Browse to navigate to my file. And I'm just going to copy where the file is stored. So Vil is telling me now it's stored in this location in user share Vil output compiled. So I'm going to copy this. And I'm going to come here. I'm going to click on the pen and I'm going to paste the location. I'm going to click on open and scan the file. Now, as you can see, I've already scanned this file and it's telling me that this file has been scanned before. So I'm just going to click on view previous results. And as you can see, the file is actually scanned on the same day as today, which is the 29th of March 2017. And as you can see, the file is bypassing all antivirus programs. So we can use this backdoor against any device and we'll be sure that the device or the computer will not be able to detect this file as a virus. Now, there's a few things to keep in mind. Antivirus programs always update their database and will always update their code as well. So you want to always make will up to date. Also, sometimes with the same exact backdoor, it might get detected and it might not get detected because depending on the way the backdoor is getting encrypted and it's getting generated. I've actually generated this backdoor before with no sleep, and as I said, it got detected by one antivirus program. I generated with 10 seconds and it still got detected, and then with 6 it was able to bypass it. So you want to keep playing around with the options, you want to keep playing around with the payloads until you manage to achieve the best results so that you can bypass as much antivirus programs as possible. Now, the backdoor that we created uses a reverse payload. So, like I said before, it does not open a port in the target computer. It actually connects from the target computer to our computer. And by doing that, it'll bypass firewalls and it'll look less suspicious. So for this to work, we need to open a port in our computer so that the backdoor can connect from the target computer to us on that port. So if you remember, when I created the backdoor, I set the port to 8080. So I need to open that port in my Kali machine so that when the target person executes the backdoor can connect back to me on port 8080. So I'm just going to write the name of the payload that we used because that's very important when you're listening for incoming connections. So we used a payload that's written in Go, and that was a meterpreter rev HTTPS, which is a reverse HTTPS payload. Now this is not a command, I'm just going to write it in here so just that you keep this in mind. And we used port 8080 for the reverse connection. So these are the most important things to keep in mind when listening for incoming connections. So I'm going to split the screen and I'm going to listen for incoming connections in here. And to do that, I'm going to use the Metasploit framework. Now to run Metasploit, all you have to do is just run MSF console. Now Metasploit framework is a huge framework for penetration testing. So the meterpreter backdoor or the meterpreter payload that Will created for us is actually programmed by the people who made Metasploit. That's why we're using Metasploit to listen for incoming connections. So Will Evasion actually uses Metasploit to generate the backdoor that we chose in the previous video. So to listen for incoming connections, we're going to use a module in Metasploit. Now Metasploit, as I said, is a huge framework and it has a lot of modules. So the module that we're interested in is a module that allows us to listen for incoming connections from a meterpreter payload. To use that module, we're going to do use to use a module, and then we're going to specify the module name. And the module name is exploit multi-handler. Okay, so the command we're using is use to specify the module that we want to use, and we're using a module called exploit multi-handler that allows us to listen for incoming connections. I'm going to hit enter. And I was already in that module, so you can see that nothing changed for me, but for you, you should navigate to that module. And I'm going to do show options. To see the options that I can set for this module. And you can see that you can specify different options for it. The most important thing that you want to specify is the payload. So you can see in here, for me, it's set to Windows Meterpreter Reverse TCP. And if you remember what we used a Meterpreter Reverse HTTPS, not TCP. So you want to change this. The first part is fine because our target is going to be Windows, but you want to change the reverse TCP to reverse HTTPS. And you can change that exactly the same way that we did with vil evasion. So you type in set, you put the option name that you want to change, and we want to change the option for the payload. So we're going to say payload. And we're going to set that to Windows Meterpreter Reverse HTTPS this time. Okay, so we're doing set to set an option. We're setting the payload to Windows Meterpreter Reverse HTTPS. Now this payload should correspond to the payload that you chose in the backdoor. So in the backdoor we used Meterpreter Reverse HTTPS. That's why in here we're using Reverse HTTPS as well. If you chose Reverse HTTP, then set this to Reverse HTTP. If you use Reverse TCP, then set this to Reverse TCP, and so on. So I'm gonna hit enter for this, and that's gonna do it for me. And if I do show options now, you'll see the payload changed to Windows Meterpreter Reverse HTTPS. Now the same concept applies for all the other options. So you want to set the lhost to our IP address, and you can see that this is already set to the right one. So if it was wrong for you, all you have to do is just do set lhost and put your IP address. So you can get the IP address using ifconfig like I showed you in the previous lecture. So for me it's 10.20.14.213, and again this is the same IP that I used when I created my backdoor. And same goes for the port. You want to set the same port. So we're going to do set lport to 8080. Because that's the port that we used when we generated the backdoor. So again, the main idea with this is you want to set the payload, the lhost, and the port to exactly the same options that you chose when you created the backdoor. Once done with that, we're going to do show options one more time. And you'll see that I have my payload set properly, Windows Meterpreter Reverse HTTPS. I have my lhost, and I have my lport. And all of that is done properly. So all we have to do now is just do exploit. And now Metasploit is waiting for connections, as you can see, on port 8080 and on my IP address, which is 10.20.14.213. So now if anybody opens the backdoor that we created in the previous lecture, because it's a reverse backdoor, the backdoor will try to connect to the IP that we set when we created the backdoor, which was 10.20.14.213, and it'll try to connect on port 8080. It's going to come to this computer, and this computer is already waiting for that connection from this multi-handler module. So the connection will be established, and then I'll be able to control the target computer, and I'll basically hack it and have full control over it. Now in the next lecture, I'll show you a very basic way to deliver the backdoor to the target computer and how to test the backdoor and make sure that it works properly. So far we have a backdoor that is not detectable by antivirus programs, which is very good. But we still haven't talked about any smart ways of delivering this backdoor to the target person. We literally just downloaded it and ran that backdoor. Now, in real life, your target will probably not just download an executable and run it if you ask them to. So what we're going to do is we're going to talk about a smarter way of delivering the backdoor. We're going to fake an update. So the target person will have a program, and the program will either display that there's an update, or if the person checks whether there is an update, we'll show that person that there is an actual update, even though that there isn't. And once they agree to install that update, we'll actually install a backdoor into their system. So The target person will think they're installing an update on their computer, but they'll actually be installing a backdoor which will allow us or give us full access on that target computer. Now this scenario will work anytime that you're the man in the middle. Now there is a number of scenarios that will place you in the middle of a connection. For example, if you had a fake network running, then the traffic will be running through your computer. If you were doing ARP poisoning and doing a man in the middle attack, obviously you'll be in the middle of the connection as well. And there's other scenarios that can be done if you're physically connected to the target computer. For example, if you had a phone, an Android phone, and you were plugged into that computer, then you can redirect the traffic through your phone and then run evil grade and do the same attack. So the main idea is, as long as you're the man in the middle, you'll be able to run this attack. What we're going to do it using a method that we already learned before, which is DNS spoofing with ARP poisoning. So we're in the same network as the target person. And at the moment, I'm actually in a wired network, not a wireless network. So you'll see that my interface is ETH0 and it's not LAN 0. Works the same. As I said, DNS spoofing and ARP poisoning works exactly the same whether the network is wired or wireless. So we're going to use DNS spoofing, which we already know, and we're going to use a tool called Evil Grade, which will act as a server to produce the fake update. Now installing the tool is really simple, and I'll show you here. I will be attaching the installation instructions with this video, so you can just download it from the resources of the video. So you literally, all you have to do is just copy and paste these commands and the installation will work for you. So at the moment I have it installed and I'm going to run Evil Grade. Now I'm going to do show options. Using Evil Grade is very similar to Metasploit. So I'm going to do show modules actually to see all the programs that we can hijack updates for. So you can see there is 67 programs that you can hijack updates from, and there are some really popular ones there. There is DApp, which is the one that we're going to do our example on, which is Download Accelerator Plus. There is Google Analytics, there is Nokia, there is Opera, there is Safari, so there is WinZip. So there's some really popular programs in there that you can use. So to use a certain program, we're going to do configure DApp, which is the module that we're going to use. Then I'm going to do just like Metasploit, show options to see all the options that we can configure. The main option that we'll be dealing with is the agent. We need to set this to the program that will be installed as the update. So you can put any executable in here. In my case, I'm going to put the backdoor that we created before. So when the update is installed, we will have a backdoor installed on the target computer. So I'm going to do set, and we're going to change the option exactly the same way we change options with Metasploit. So we do set, option, and then the value. So I'm going to do set agent to, so I have it stored in var www.html backdoor.exe. Then I'm going to do show options again. And we can see that the agent has been configured correctly. So everything is ready now. We can start the server. And now basically, anytime Evil Grade gets a request for an update, it'll tell whoever is requesting for an update that there is an update. And it'll serve the backdoor that we specified here as the update. So what we need to do now is redirect any request that's coming for update.speedbit.com to Evil Grade. So our target program, whenever it wants to check for updates, it requests or checks with update.speedbit.com. So we're going to do a basic DNS spoofing attack, spoofing any request from update.speedbit.com to Evil Grade, to our own IP address. And we're going to do that using man-in-the-middle framework, just like we did before. So I'm going to open my leaf pad in etc man-in-the-middle framework. And I'm going to go down. And I want to actually show you here that I changed the port for my DNS server to 5353 because Evil Grade runs on 53. So both of them will be running on the same port and they're going to conflict. That's why I'm using 5353 here so that they don't conflict with each other. Now, if we come here to our A records, you'll see that I'm redirecting any request to update.speedbit.com to my own IP address, which Evil Grade is already running on, and it's going to tell the people that, or the program, that there is an update. So all we have to do now is run man-in-the-middle framework the same way that we used to run it. So man-in-the-middle framework, ARP spoof, gateway, our target gateway, target, our target computer, and then we have our interface, and I'm doing DNS spoofing. I'm going to hit enter. And now we're ready. DNS spoofing is ready. So whenever the target person is going to request, or the target program is going to request update.speedbit.com, man-in-the-middle framework is going to redirect that to here, where I have Evil Grade running, who is going to say that there is an update, and it's going to serve my backdoor. The backdoor will be downloaded, and it will be executed. And for me to get a connection, I need to listen on a port. So we're going to do that exactly like we did before, using the multi-handler. I've done all the commands already, so I'm only going to show you the options. And you can see that I'm using Windows Meterpreter Reverse HTTP. I have my L host, my IP, and the L port is set to 8080. So I'm going to exploit this to listen on this port. And we're all ready. So I'm just going to go over this one more time. The target program is going to check for update using update.speedbit.com. The update is going to be redirected to my own IP address because I'm using man-in-the-middle framework. And man-in-the-middle framework is going to redirect the request here where Evil Grade is running, and Evil Grade is going to say that there is an update serving my backdoor as the update. So I'm here at the target computer and I have DAP running. I'm going to check for updates. I'm just going to click on next. And you can see that it discovered an update. It's a critical update. So I'm going to say install. It's going to download and install the update for me. I'm going to click on next, next, finish. And if we come here, you'll see that we have a Meterpreter session. So if I do a sysinfo, you'll see all the information of the target computer, and we'll talk about how to use the Meterpreter and control the target computer. So basically, I have full access over the target computer right now by serving the target computer a fake update. In today's lecture, we're going to learn some basics about how to interact with Metasploit's Meterpreter. So I already have a session here, and as you can see, it just says Meterpreter. In Linux and everything, in every command line, the help command is always the best command you can run. So the first thing we're going to do, we're going to do a help. And as you can see, you get a big list of all the commands that you can run and a description of what each of these commands do. So I'm going to show you some basics right now. And the first thing that I'm going to do is get my current working directory using the pwd command. And as you can see, I'm in C users at the moment. Now, if I want to list all the files and directories, I'm going to use ls. And let's say that I want to navigate to this file, ie user. I'm going to do cd ie user. And if I do pwd now, you'll see that I'm in users ie user. And let's go into downloads. List the files. As you can see now in the files that we listed, we can see a file here called passwords.txt. So this seems like an interesting file. So let's see if we want to read this file. If I wanted to read it, all I have to do is do cat and passwords.txt. And as you can see, we can see that it contains test1 and test2. So if I go here and run the file, you can see that this is the actual content of the file. Now let's say that I really want this file and I want to keep it for later, then I can download that file. To do that, we're just going to say download, and we put the file name, which is passwords.txt. Now the file has been downloaded successfully, and if I go to my root folder, you'll see that I have a file called passwords, and it contains test1 and test2. Let's say that I have a backdoor or a virus or a Trojan or a keylogger that I want to upload on the target computer. So I can upload it very easily. Now I'll go back to my root actually to show you that I have a file called backdoorcalc.exe. So we're going to try to upload that file. And to do that, we're just going to run upload. And we put the file name. Hit enter. And as you can see now, the file has been uploaded successfully. Now let's list to make sure that the file exists. And we can see that we have a new file called backdoorcalc.exe. And to execute this file on the target computer, now we only uploaded it. So if it was a virus or a keylogger and you want to execute it, all you have to do is execute and specify the file that you'd like to execute after the F command, and then type in the name of the file. So in this case, it's backdoorcalc.exe. And as you can see, it's telling us that process 3128 has been created, so my backdoor has been executed. Now, if this was a virus or anything that you uploaded, it'll do what it's supposed to do because you just executed that file. Another feature that I want to show you is shell, which basically just converts the current Metasploit or Meterpreter session into an operating system shell. So if I just type in shell, you'll see I'll get a Windows prompt or Windows command line where I can execute Windows commands. Now, as you can see now, it's on a different channel, and I can run any Windows command that I want through this now. So I can just do dir to list all directories. I can do ipconfig, or use any Windows command that I want, exactly like running the commands through the command prompt. Now, there's much more commands that you can do for file system management. So if you type in help and you go to the file system section, you'll see that you can edit, you can download, we showed that, you can move a file to another file. It also can be used to rename files. You can delete files, you can remove directories, you can search. So there is so many more things that you can do with file system. That was just an overview of the basic or main commands that you can use with managing the file system of the target computer. Right, so let's talk about how we can detect ARP poisoning attacks. First of all, let me show you the ARP table. So in our Windows device, which is the device that we always attack, I'm going to run a command, ARPA, to list all the entries in the ARP table. So each computer has an ARP table, and that table associates IP addresses with MAC addresses. So we can see the IP address of the router, which is 10.20.14.1, is associated with the MAC address 52.54, and it ends up in 35.00. So this is the MAC address for the IP for the router. So the way that ARP poisoning works, like we discussed before, is it works because each request is trusted, and clients accept responses even if they didn't send a request. So what the hacker does is he sends a response to the client telling them that they are the router, So the client will accept that, it will trust it, and it's going to accept the response even though it didn't send a request. Then we'll send another response to the router telling them that we are the client. So what this is going to do, it's going to modify the entries in the ARP tables in both in the router and in the client. And for the client, it's going to contain the hacker's MAC address, and it's going to associate that with the router's IP address. So what's basically going to happen is it's going to modify the MAC address here, and it's going to change that to the attacker's MAC address instead of the router's real MAC address. So when that happens, then the hacker will be in the middle of the connection, and they'll be able to read, analyze, and modify the packets because they're going to be flowing through the hacker device. So let's run the ARP poisoning, a normal ARP poisoning attack like we always do it. And when I go back here, I'm going to execute the same command. So I'm going to do an ARPA again. And note how the MAC address is going to be different. So the MAC address for the router, it used to be this one. And when we ran the command, then the MAC address changed to this one. And this MAC address right here is the MAC address of the network card that the attacker is using. So if I come here and just do an ifconfig, you'll see that this is the MAC address, the same MAC address that is displayed in here. So this is the easiest and the simplest way to discover ARP poisoning attacks. It's not the handiest way though, because you're gonna have to keep doing this command and keep comparing the entries if you really wanted to check if you're being ARP poisoned. So there's a tool called XARP, and it does that automatically for you, and it's available for Linux and Windows. So I already downloaded. You can just Google XARP and you can download it. Very easy to download and install. And I'm just going to run it. I'm actually going to stop the attack first, and then I'm going to run the tool. Now notice when you stop the attack, the IP address is going to go back to what it was. So you can see that the MAC address of the router is back to its default right value of the router. So I'm just going to run XARP now. And you can see that everything is good. And you can see that the entries are very similar to what we did when we did ARPA. So we have the IP addresses and the MAC addresses associated with it. What the tool basically does, it's just going to automatically monitor this. And whenever something changes, it's going to know that something's wrong is happening, because each IP address should have a unique MAC address. There should be no duplicates in the network. So I'm going to do another ARP poisoning attack exactly like we did it before. And when we come here, you'll see that XARP is giving us a notification and telling us that something's happening. It's telling us that the MAC address for the router, which is the 10.20.14.1 IP, has changed from this to that. And if we look here, I'm going to click OK. And if we look here, we can see that the affected machines are the router, my own machine right now, and the attacker. Sorry, that's me, and that's the attacker. So basically, we know that the machine at 10.20.14.203 is trying to do an ARP poisoning attack, because it's the one that the router's MAC address has changed to. Therefore, we know this is the attacker machine. So this tool is really handy because it does the monitoring automatically for us, and it will tell us whenever someone is trying to ARP poison the network. Okay, so now let's see how we can use Wireshark to discover suspicious activities in our network. And before I do anything, I'm going to go to the preferences. And I'm going to go to protocols, ARP. And I'm going to enable the option to detect ARP request storms. What this will do, it'll actually discover if anybody is trying to discover all the devices on the network, and it's going to give me a notification. So I'm going to click on OK, and I'm going to start my capture. And now I'm going to go to my Kali machine, and I'm going to use net discover. So I'm not going to do ARP poisoning. I'm only going to try to discover all the connected devices to my network. So we're using exactly the same command that we used before, net discover, interface, and the range. I'm gonna hit enter. And we can see that net discover finished. It discovered all the devices that we have. So if we come here, even before we look at the output of the notifications, let's just look at the packets that have been generated. You can see that there's a device here. This source is broadcasting, so basically it doesn't have a destination. It's asking all the other devices in the network, and it's inquiring about each possible IP. So it's basically asking who has this IP and tell the 67 IP. And then it's asking who has the 241 IP, tell the 67. Who has the 251, tell the 67. And it's doing this for every possible IP. So it's basically checking if any possible IP in the range exists, and it's asking to return the response to the IP at 10.20.14.67. So from this, we can deduce that someone is trying to discover all the connected devices, and that someone is at 10.20.14.67. Now, if we go on the analyze and expert information, you'll see that we detected an ARP packet storm. So basically it means that there was a single device sending a very large number of ARP packets. So they're probably trying to discover connected devices or trying to discover connected ports. So it's telling us that this person is trying to do something suspicious. Now let's go, and I'm gonna do a ARP poisoning attack using man-in-the-middle framework, and we'll see if we can get any notifications or warnings in Wireshark. Now I'm gonna go to analyze and expert info again, and if we look, we'll see we have a warning here, and the warning is telling us that there is a duplicate IP address configured. So again, this is telling us that the IP address of the router had two different MAC addresses. What this means, basically, it means that someone was tampering with this and tampering with our ARP table, trying to place themselves in the middle using an ARP poisoning attack. Now, we've seen a number of methods to detect ARP poisoning. Let's discuss how we can prevent it or protect ourselves from it. Now, I'm just going to run an ARPA, and we're going to look at our table. There is switches that will monitor this for you as well, and they'll notify you or even prevent ARP poisoning attacks. Another way to do that is, if you look at here, if you look at your router, you'll see that this entry in the table is dynamic. So the type of this entry is dynamic. What that means, it basically, this can change. It's the system allows this value to be changed. You can see right here, you have static values, which basically means the system will never allow these values to change. So you can use static ARP tables, which basically means that you'll have to configure each IP address. So you have to actually configure your ARP table and map each IP address to the MAC address, to the relevant MAC address. But once you do that, even if someone tries to send a response to your computer trying to change it, the system will refuse to change anything because you configured your ARP table to be static. The only problem with that is every time you connect to a network and every time there is a new device connecting to your network, you'll have to manually configure that device to work with your network. So it's not a very useful solution if you're in a big company or if you're in a big firm, but maybe in a small house or in a small company, then this would be a really good solution to prevent ARP poisoning attacks, because everything is going to be static. You're going to have to set it up manually. But when someone tries to do an ARP poisoning attack, even if their attack is successful and they use the best tools they can, your table is set up in a way that it's fixed. It can't be changed. So the system will always refuse to change the values of the MAC addresses, which will basically mean ARP poisoning attacks will never work against you.